now at the right place. All right, so let's start thinking in terms of, as we're preparing data and we're looking at, you know, resolving some issues and some uh, farm problems. We played around a bit yesterday with this file and saw, let me see if there's a picture of it in our, yeah, not really. Anyway, we saw some issues where when we're not using um, the break line data, and we're just using the contours where we're missing a lot of information. So um, just to, I guess, bring that to closure, let's go ahead and build a surface so you can see one of the other tools. So I'm going to go and run Carlson here with, I'll go back to my AutoCAD version 2024 to match everybody's there. So let's take a look at that same file. That was a this sample from T3 Global. So go ahead and load that up. And again, we see some of the data. And let's see, I had you can restore. No, all right, that's fine. Get rid of that. Okay. So again, what we had, and I'm going to show you a couple of other commands that you might want to consider. And let me also point out something in the book to help you as well. When you are going through the book and you're looking up certain, commands and things like that, you're going to see, let's look, I want to go to the command reference. At the end of our exercises, we have this command reference here. Let me back up to the area here. So it starts after the end of our exercise here. We start with the command reference, and this basically is going to step through all of the different menus. So we've got, file, edit, view. Of course, edit is quite extensive. We got view, draw, settings. I missed the inquiry somewhere along the line, and points. And then once you're through that, and that's the stuff common to all the modules, then you'll see starting again, command reference, but this is for the survey module menus specifically. And it starts with the survey menu that you would see right there. And it goes through all the different things on that menu, et cetera, et cetera. Now, what I wanted to show you is this. Let's see, is that still, there's my exercises. When we are looking at things in the menus, occurs a couple things to pay attention to. Some commands you're going to see, like right here on this opening on the file menu, you're going to see this thing called drawing cleanup. You notice it is in red print and boldface. Same thing if I go ahead a page, I look on the edit menu and I see erase by layer, but temporary erase and copy to layer, those are also commands there, but they're not in red boldface. So all that means, and there's nothing more to it, and it's very subjective, is that these are commands that I myself have found to be very helpful because they save a lot of time. They're obviously, there's 100 different ways to do the same thing in this software. You can do the AutoCAD P-line command to draw a polyline, or you can use Carlson's draw two-dimensional polyline. You can draw lines and then stitch them all together, all kinds of different ways. But Some of these commands are basically sort of enhancements to standard type commands, like this one here, for instance, erase by closed polyline. That is basically where you would draw a closed polyline and then select it and say trim, and then you would click on all of the things that cross that closed polyline, either on the inside or the outside, however you want to do it, to trim them out. And then you would erase all the things that were either inside or outside of it um, that didn't touch it, but you would just erase those items. So again, you could do all that in that fashion, or you could choose that particular command where you basically would draw a polyline that you want to use as a cutting edge. This is sort of a cookie cutter function. And then you would erase by closed polyline, and you could choose the types of things you want to erase, inside or outside, all of that. So it's a very useful tool. So that's really all that red text is showing you, is something that I found in my work has been very useful. Some of the others I may not use them. For instance, there's one called multiple offsets, something I just don't need a whole lot. It's there, certainly a good command. And your particular workflow, though, you may do that all the time. You may find it more important. So don't take this as any kind of gospel. It's just stuff that, through the years I have found to be um, very useful and worth an extra closer look. Also, the other thing to notice is that when you are going through this manual and you look at these commands, here's the edit menu. Notice the first one you see is erased by layer. But if you look over at the picture, you see the edit menu contains undo, redo, some things under clipboards, and then erase, erase select, erase single, erase last. Every one of those things are all just standard AutoCAD commands. Erase by layer is the first Carlson command, or non-AutoCAD command that comes in our list. And so these are the ones that are listed out in this command reference. If it's a standard AutoCAD command, you won't see it listed here necessarily, other than, like on the file menu, it tells you about this new open and close. And then you get to project as your first, um, non-standard Windows or AutoCAD command. Okay, so that's the way to use this command reference. All right. So now, and you can see as an example, for instance, if you want to try, if you're new to some of those commands, a lot of them are on this edit menu, and notice there's a whole lot of these that have pull rights. Okay, so there's a lot of functionality there. There's also one thing to point out. If you go to the edit menu, polyline utilities, remove polyline, and then remove polyline vertex. That was the command I was using yesterday to click off those uh, little vertex points along that shrink wrap boundary. But notice if you're going to run the command, it takes clicking on the edit menu, then you go down to polyline utilities, and you go right to remove polyline. You go right again to remove polyline vertex. Well, it's pretty deeply buried. Okay, and so that's maybe a command candidate that you would consider doing something like, I'm not seeing these show up here a minute. Let me see something. That may be why I'm not seeing everything. Let me. I should have. I don't see my full status bar. I should see some things pop up down here below, which I'm not. see here. Let me see about that for a minute. So if I edit, no, still not seeing that. Let me see. Right down here, and that may be where in our survey settings, if we showed this occupying backside point, and then if I went to set an occupied point, would be a point there. Yeah, it's still not showing up. See, it's down here on this status bar, and that's also where I'm trying to see a lot of, commands, most of these commands anyway. When you hover over a command, you should see, and maybe yours does, there may be some setting that I've got in mine that's not working the same. You should see down here on the bottom a little line of text that tells you what the command is. If you see that, go to Edit, Polyline Utilities, go to the right, go down to Remove Polyline, and then hover over Remove Polyline Vertex. You should see on the status bar, and maybe the new versions of AutoCAD have taken that away, or maybe it's a switch that I don't know what to go turn back on. But the other versions like IntelliCAD or some of my previous AutoCAD installations, you should see down on the status bar at the very bottom, down on the last line of the screen, you should see a little brief explanation of what the command does and a colon, and then you would see a typed, the command if you were to type it, and it would say RMVERTEX or something like that for remove polyline vertex. Do you all see that? Anybody?
I do
If
not.
you say you do not,
No, sir.
okay, so that must be maybe a change in the AutoCAD user interface in recent years. But it used to down at the command line. It's something that's sort of useful as you go through these commands. When you hover over a command, you would get that shown down on the status line so you could see what the name of the command is if you wanted to run it instead of um, having to choose it from the menu or something. But here's another thing to notice on these menus if you are looking for these tools and you don't want to dive down into these menus so deep. If you see to the left of any of these commands, and you can see on this particular screen, two of these four commands on my furthest right menu have little icons next to them. Just like on the previous menu back here, I've got these four and I've got two down here that have little icons next to them. What that means is that if it has an icon next to it, that means it lives somewhere on some toolbar. It doesn't tell you which, but then just use a little bit of detective work and say, well, that's a polyline type of thing. And I look at all my different toolbars and I can see, up here, I've got my polyline toolbar right here showing up here. And, you can also, as you look for these different, I'll come down here. Oh, there's one called polylines. So sort of explore your way around and see where those are, because those polyline edits are very helpful and they're very useful to keep on the toolbar so you're not diving so deep to go get them. All right, same thing for like this edit erase by layer lives on a layers toolbar, and it's the Carlson layers toolbar, not the AutoCAD layers toolbar, which you can have them both up there. They don't conflict, and they can just, either one be helpful for you if you want to use it. You also don't have to use any toolbars whatsoever. You can use everything from the ribbon or from the menu. It's entirely your choice, but you may find it easier and a little faster to choose, particularly the layers toolbar and the polyline toolbar. So they're very helpful. Other things as well, standard and Carlson menus and, different things that you might find as you go along. All right. So keep that part in mind, that if you do stumble across a command, like if I go to draw arc and I come down here, there's one called curve calc. Now it's buried under the draw arc command. It's a very useful command though. If I select it, pop it up, it docks this little window on the side and it lets me do something. If I want to say, I can come up here into the field and say type a 50-foot radius with a 45-degree delta angle. And if I tab out of those fields, then it's going to, once it has enough to calculate, it'll calculate everything else. At this point, I could draw it in the screen. And if I do that, it's asking me on my command line to pick a start point. I'll pick there, and then it wants me to know the direction. I can either do the tangent direction or the direction of the chord. So if I choose the chord direction, and so define the chord direction by point there, and I just click there. So that now drew my chord direction. And is that the correct direction? Yes or no? If I say no, it'll flip it back around. Okay, so that was something that I typed in the values. It drew it for me. Now you can also do with that same little toolbar. Let's say we've got an arc. We've drawn, or somebody has drawn an arc. We'll just do a little 3-point arc. We've got one here and here and here. And then maybe we've got, say we do a polyline from here to here and to here. Okay, just as an example of some things in your geometry. So if we choose that draw arc curve calculator, you also, instead of just typing values in, you can say select, and then you could pick. It's going to prompt you now over here to select an arc or polyline. So you pick something, and if it is an arc or if it's an arced segment of a polyline, it reads it, shows you what it is. Okay, so it'll calculate it. Again, railroad and roadway type of degree of curve calculations. So you can do that select. You can also choose 3 points in which it's asking you to now pick an endpoint of the arc and then pick the other import. And it reads you the data. Let me see if I do. Say pick in a clockwise direction. All right, so pick the endpoint there and endpoint on the arc. So let's say if it goes through that, and then the other endpoint, maybe I'll get that one. All right, so that was the arc that goes from the endpoint through this point, through that point, even though it's not drawn. But then I could, again, just plot it. So plot the last 3-point arc, yes, and it shows you, what you just picked. All right, so it's not necessarily something that you would use every day, but it could be something that's very useful for you. And again, you get reports and, all kinds of stuff you can do with that. All right, so just a little tool, and it's buried deep, but it has that curve calc. There's a little calculator icon, and I'm not really sure what that lives on. There's a standard calculator on the inquiry toolbar. So, it's on one of them. That's an example of one that I don't know where it lives. I don't use that command very often, but it has one. So I would, maybe look around. I don't see any particulars. I don't think it's on Kogo. No. Anyway, that's the idea. So you would find your, maybe a command that you use a lot, search through it, see if you can find it. There's also ways, I think, go to my Carlson help, curve calc. So if I look for that particular tool, curve calc. So it tells me the pull down menu is on the keyboard command. I thought maybe it would also tell you the toolbar, but it doesn't. Okay. But that also shows you the typed command. They used to show up on the command on the status bar, which you could do as well. And you have some things under your settings menu where you've got this thing called quick keys. And this is a means of, if you like that command, curve calc, but you don't want to type out curve calc all the time, then you can either see if it's already abbreviated anywhere in here, which I do not see. There's curve info, but not curve calc. So you could add, one to it and say maybe, let's just call it CC. And that was, let's see, it would probably be of this form, and we'll call that curve calculator. Let's see if that works. We'll say okay. So it's just called CC. So if I type CC and hit enter, up it pops. And you could make that work there under that quick keys as well. So these are just some of the little behind the scenes things that are easy to overlook. So a couple of things that are of some good use is this drawing cleanup on the file menu. And it has a bunch of things that can all be done from within this one command, that you can do all of these in separate areas. But these are things that are typically done at the start of a project, particularly if you get a job from some outside agency or other user. You might need to change something about that file to make sure it's going to work in your, for you going forward. And notice at the bottom, we've got some defaults. These are the ones that the programmers have decided are the ones that you should probably use most of the time. Or clear, I'm going to say, I've never found the programmer's wisdom to necessarily be optimal on these regards, but you can read over some of these things that this can do. It can remove empty layers. It can remove duplicate line work or little teeny tiny snippets of lines. If they're too small, maybe somebody trimmed something and left something behind. It can get rid of, you can have text items that have no characters in them. They're just blank. So you can get rid of these particular things. One of the things that's very common is, or not very common, but it's hard to find, let's say, when it does happen. You can get, particularly when you get files from other types of software like Civil 3D or some other source, that you'll get these entities that have extrusion values in them, and you need to set those out because Carlson doesn't know how to handle that particular structure. And I'm not talking about extruded solids. Carlson can handle that just fine. And these are things that their definitions are extruded in they're defined in relationship to something else that is not in the world coordinate system, which is the unrotated type of coordinate system. So if you do that, it will split it back out and redefine it in reference to world coordinates. But here's one that I find very useful. And you can see a lot of these are very commonly useful, but I do this all the time. If I get a file in from somebody, one of the first things I'm going to do is to look at it in 3D to make sure there's nothing wrong with it visibly, like maybe some lines are placed at the wrong elevations or stretched way out. They have parts of them that go down to 0 and then come back up. So I can find that very quickly by looking at it in 3D. So I'll do that visually. But let's say I have a problem trying to calculate a surface. And I keep getting, some kind of like a giant pit or a peak or a spike or something in my data, because I'm assuming that everything I'm selecting is at elevation, but maybe I've got something else that the original user thought they were down at 0 elevation when they were creating these little lines and things. And quite often they're not even geometry of the model, but they're, maybe, um, drafting things, just lines or leaders or things like that. And maybe they're at like a negative 0.2 elevation, or a 15.5 elevation, because that was the current elevation when they were doing some stretch of their work. So you got something that's at some rogue elevation that, maybe needed to have been at 0 elevation or should have been at a different proper elevation. So one of the things that I like to do a lot when I first get a file is I bring this command up. It's File, Drawing Cleanup. I'll just clear all the selections, and then I'm going to set on the very last one of the group here that says set any elevations outside of range to 0. Now I could go ahead and type in numbers like this, but before I do that, I'm going to hit this scan drawing button to the right of that choice. And when I do that, it's going to read through the drawing elements and report to me everything that is non-zero. So if I saw now, when it comes up and you see the min and max elevations, if I see numbers that I know are outside of the range of what I'm expecting, let's say I know that this is a site that's around 1,300 feet elevation, then what I'm reading there now looks reasonable. But if I see something like a minimum elevation of minus 40,000 or a max elevation of, 35,000, up in the air, I know I've got a problem. So when I see those giant numbers, all I have to do is just, edit these fields. So if that were, say, a negative 10 instead of this 1279, then I might say, well, I want to say everything, say, outside of, 1,000 to 1,500 maybe. And so if I would set my limits after I see what the drawing tells me it has, then I would hit OK, and it would go through and it would find those things or portions of things that lie outside of that window of elevation, and it would set the elevation to 0. So it does not erase the item. It just puts it down to 0. And I may have to elevate it myself later, with properties or with some command like change elevation or something. So that's a very useful tool that I find. Now I see with that one that it is in good enough shape without needing to change it. So there's another tool that's very useful when you first get a drawing in from somebody, called Drawing Inspector. And that's on our inquiry menu, because again, think your way through where these commands might live. Here's sort of the decision tree I'll give some of my new students. As I said, you're working in a drawing file, and the drawing file contains within it drawn entities. And so here's the decision tree as to how to try to figure out where you might find a command that you are looking for. You can ask yourself, well, this is a file that holds geometric entities in it. So the only state that those things can have is either they exist in there or they do not. So if I needed something that's not in this drawing, that means I have to create it. So I'm going to look at my menu titles, and of those titles, it's not going to be something I find on the edit menu or the view menu, but I need to create it. So I'm going to look first maybe on the draw menu. Okay, so I would think my way around that. If it happens to be something that's more specialized, like a road center line, some kind of thing that's linked to some type of civil or survey data, I might look on those extended menus and I would look for things like draw centerline file. I look under the surface and I see down here I've got there's a little profile section at the bottom to draw a profile. I've also got this draw surface and I can draw, the triangles, or I can draw the boundary. There's a little separate thing under the surface menu where you can contour from. So that creates your contours. All right. So some of these are the more specialized ones, particularly when they draw more than one particular thing. But if it's just a standard entity that I need to create, I might look first under draw, and there's where I have all my line work and stuff. Now, the Carlson versions of almost all of these commands, one of the big differences between drawing a 2D polyline with a Carlson command and say just drawing a standard AutoCAD polyline, which is the P-line command, both of which create polylines, both of which are correct to use. But the Carlson versions of these points will, when the standard AutoCAD version is asking you to pick a point, which you would typically either snap to something or pick on the screen, Carlson will say pick a point or point number. And that right there is one of the biggest differences and enhancements that it has to the AutoCAD standard practice, is to um, ask you for those particular point numbers. So if you have coordinates and you've got Carlson points in your file, then you can use those by point number. There is a way, by the way, to have AutoCAD ask you for those point numbers. All right. And if you do this, let me show you that particular one because it's something I sort of stumbled across late in my history. So let's go to let me see. Let's see if I can open another file here. Some projects. There. Survey class. I'm going to open class example one. Well, that's one we did yesterday, class example one. That would work, but um, just open a new file or just open something that's empty. And then I want you to go to the points menu and choose um, set coordinate file. And then the first one to set, I want you to choose this exercise one coordinates.crd. And that, when you set that, it's now there. Then go to the points menu and draw locate your points and just draw them all. And you're going to get a bunch of points that show up like so. Okay. Now, remember, if we're doing and I would still prefer to use my Carlson versions of, like, let's draw a 3D polyline, and we'll just say, okay. And let's say, notice it's asking me on the command line down here now, it says to pick a point or point numbers. So if I say 1-5 and hit enter, and hit enter to conclude, there is that 3D polyline. And in fact, I'll spin it up here and 3 dimensions, you can see it's actually at 3 dimensions. It looks like my points are at 0. Why did that happen? I've got, it should be located on a real z-axis. See, something has been changed when I switched to that version. Let me draw locate my points again. That's my draw locate points. Yeah, now there you see they're at elevation, and there was my 3D polyline. And again, that was one of the things that Carlson offers, is to use those point numbers. Now, like I said, there's a way to make other AutoCAD commands that don't ask you for point numbers, allow it to then ask you for point numbers. So let's draw, instead of Carlson's draw 3D polyline, let's just type 3D poly. That's AutoCAD's version of a 3D polyline. So it says specify the start point of the polyline. Well, you can, click a point in space or snap to something, but if you want a particular point number, remember these, we talked yesterday about these transparent point commands. So if I pull this over here, notice if I see here, I've got a 2D point or a 3D point. So I can choose that. If I say a 3D point, it says 3, angle, enter the point number. So that's going to be a 6. So that's its start point. And now it wants to know, specify the end point of the line or keep going, et cetera, et cetera. So I'm going to choose that again. I'm going to use that 3D. Notice the 3 enter point numbers. And I might say 7-11. Hit enter. And hit enter again. So now there is 6, 7, 8, 9, 10, 11 done, but with a standard AutoCAD command, and it's not even asking me for point numbers until I pulled it out of this. Now you can do that. You see this one here says a 2D point. So if you're drawing something that you just need the 2D and not the elevation, you could use that one. You can use this one for 3D, but notice the little number beside the explanation where it says gets the 2D XY coordinates, but point number from the current coordinate file 2. This one says its description, then 3. This one says its description, then CL. So those are little codes that you can type instead of having to pick it from the command line. And you could say, let's just do a standard 2D poly. So specify the point, the start point, we'll say start with, say 14. Sorry, I did the wrong thing there. That's just a standard polyline. Okay, start point, I have to type 2 instead of pick it from the command line. And I'm going to say now, I've got something messed up here. Let me see. Poly. Okay. Apostrophe 2. Yes, that brings up. So if I use the apostrophe and then the 2 or the 3 or the CL or whatever, I can use those transparent point commands. So if I entered 2 now, if I said 14, and then when, the next point, I can say apostrophe 2 again. Maybe I'll say 4 or 15 to 22 and enter and enter. And so there now I've used the standard AutoCAD polyline command, and yet it allowed me to pick those because I was using those transparent point commands. All right, so just a little subtlety, even though the Carlson draw 2D poly and 3D poly has all kinds of other things with it. You can specify an elevation. You can set the elevation by the first starting point, or you can have it auto correct for 90 degrees corners. So if you're, say if I turn that on, for instance, and I go here, and if I'm just drawing, notice I'm not really exactly at a 90 degree here, but if I have that switch set within a certain tolerance, you see how it sets it. I guess I missed the first one, but within a certain tolerance, it snaps the angles, forces those to be 90 degrees. So if you're drawing like, building footprints or something, that's a useful thing to have on. Now, I will caution you, however, when you run that successive times, that switch stays on. So if you don't want that to happen, uncheck that so that you can have it skewed a little bit if you need to. Otherwise, it will square those edges up for you. Right. So those are just a couple of, and I'm going to go ahead and close this off and get back to our other file. But those are just a couple of those things in our Carlson little enhancements that, you're going to run across to have these little aha moments. So one of the other useful tools, if I look under my inquiry menu, I have a drawing inspector. Okay. So if I were to choose that, and that's a toggle that turns it on and off. So if I click it, it is now on. It tells me on the command line um, that the inspector is on. Right click to activate the pop-up menu. And then I don't see anything. And it's an empty command line. It says, type. I'm going to bring this up a little bit like that. So it says type a command. So I can do, just continue working while this is on. However, I do see a subtle difference in the cursor. I have my standard AutoCAD cursor plus a typical Windows arrow pointer. And if I move the mouse fast enough, you see they can get it sort of out of sync. They're not exactly paired, but they'll catch up with each other. But then if you hover the mouse over the drawing, don't click it, don't select stuff, just hover the mouse. And right now you can see it's reading me some information, and it's reading what appears to be the layer name. Okay, so that's V site fence, that's V topo break line, there's V topo minor, there's V topo major, there's V site outline OTLN for the cemetery because it's on this outline layer of that cemetery. You get the idea. So it's showing me the layer name. Well, that's sometimes useful if I want to know the layer name. If you right click the mouse, you can come down here and choose what you want to see. So let's click on display elevation. So now if I right click the mouse again, you see it's kept on the layer name, also the elevation. So now if I'm hovering over the mouse, hovering over these items, I see not only the layer name, but the elevation. And here are these 3D lines. And as you just hover and go down, notice the elevation is changing. Now here's the elevation on a contour line. Notice that elevation is constant, okay, because it is truly reading the elevation at the cursor. If you don't want to right click and click, right click and click, right click and click and turn off, right click and turn. If you don't want to do all that with a succession of right clicks, one of the options here is this option. When you right click is this options dialog. So when you bring that up, this lets you do all that with the one. So I'm looking at elevation, polyline data, layer name. Let me turn that off and put, say, entity type on. But you do want these options at the bottom. You want to enable the tag display that shows you the pop-up, okay? You could set your cursor back instead. I like to use that new cursor, the combined cursor, so I know it's running sometimes. Report and high precision just gives you further decimal places, etc. You could have a surface that you've already built and you want to know the elevation. It can display that as you hover the mouse, etc. So we're going to look at the direction, the data, and the elevation and the type. So now if I hover here, you can see the direction that those lines were created in. And I can see that this, for instance, has an elevation of 1300. It is a lightweight polyline or a 2D polyline, has a horizontal distance of 13.896, a slope distance, same thing because it's flat. The elevation at the start, at the end, the slope in percent, in ratio. The total distance, that's the entire item, but the current distance is 290.519. That means that's that far from the start of that feature or that element. But if you go back up to the third line down where it's reading the distance, that's just the distance of that little segment. So if let's zoom in a little bit here. If I hover here, that particular distance, you see HZ distance is 4.756. But if I go back to, and its current distance is 271.154 from the start. If I look at this portion of it, that's a longer distance. That's 13, almost 14 feet instead of 4 feet. And it's a little bit further from the start. It also tells you whether it's open or closed. Now, if I look at this particular item, it's a 3D line. Notice it can read me the slope. That's on a 3% slope. It's a 33.3 to 1 ratio. It has a horizontal distance, a slope distance. They're very close to the same, but they're not the same because it is elevated. It has a Z at the start and a Z at the end, and that is the start and end of the segment that you're on. And just read you that same type of information. Here's another one. Again, a 2D polyline. This is a polyline or a regular, a 3D polyline, whereas the LWs are lightweight polylines. So you can use that to help sort of go through and identify things about the drawing. If you suspect something might not be elevated, hover over it and see, like this building pad, for instance, this building outline. Look at that and say, oh, well, it's got an elevation of 0. So that's not something I can use to model my surface with. But if I look at my curbs, I look down here at this curb, and I see that's an elevation of 1296.3. I go right up behind it, and I see 1296.7. So, okay, I see this one's lower than that one, and that's a little wedge curb. So hopefully that'll give you something that is useful as you try to pick apart a drawing and see what's in it. So I'm going to right click now and I'm going to turn off the drawing inspector. You can also do that from the menu, from the inquiry menu. Again, it's just a toggle. So that means it'll go away. Now I can hover the mouse and it won't get in my way. All right, so that's something that is potentially useful for us. All right. Now, we talked about making that surface with these break lines, and you saw when we looked at this surface that we made from the contours, how it was giving us some problems. Now, we did add that one in. We told this one to minimize the flats, and so that's where you see this edge has been minimized, but these over here are still a little goofy, and we still have all this mess over here, okay? And if we look up around where those curves and stuff were supposed to be, I really don't see much definition. Now, here's what I want to encourage all of you. I see a little bit of definition in there, but not really enough that I can look at that as a curve. So here's what I want to encourage all of you to do is when you're building these surfaces, don't just build a surface, and if it goes through and creates it and comes back and says, ta-da, I'm done, here's your surface. A lot of people will look at that and say, well, that's perfectly fine. That's good enough for what I'm wanting to do. Well, it might be if you're doing a countywide drainage study and you need, to route hydrographs through your watershed. But if you're designing, the fine grading for a parking lot and a building construction on a commercial site, then, you want a lot more definition. You're going to need that surface definition. So understand when and where you need those. Again, I didn't have any of those curves anywhere. So you would want to identify, those things that you're going to need. And we find on this other layer, they've got indeed a layer with nothing but a bunch of break lines on it. They've got another layer with a bunch of points on it that was used to create the contours. So let's make the contours this time from a different, or make our surface from a different source. And one of the things we can do is you can isolate the layers. So if we know that it's just those two layers, now I've got some of those points are on, you can't really see them because they're just dots unless I go to settings, AutoCAD settings, point style. Let me change it to look like those X's. So now I can see the dots, their points. So you could isolate those two layers, okay, and just select, and then when you build your surface, use those two layers. Or you could, instead of isolating those, you know that you've got these elements as well as these elements and the points. Those are the only thing that have elevation. In fact, if I select everything and go to view, 3D view, drawing viewer, which is the same viewer as the surface viewer was, it's just loaded up drawing elements instead of surface files. I can see, indeed, I've got text, contours, all of these white lines, and I look at those curves are nicely defined, and I've got these points. So I can also get a sense of it from, if I uncheck this ignore zero elevations, I've got all of that stuff down below that is drawn at zero elevation. That's just the planimetry. What's up here is the elevated information. So what I've got, I'm going to turn that back on to ignore the zeros. So what I've got, if I were to select this data and build a surface from it, I've got these things that have elevation. So those would be the items that are red. Now, look at what you have here. And what you might be tempted to do is say, well, I'm going to use all those break lines now because I needed to add those to my contours. But here's what is going to happen is if you were to do that and run this command to triangulate contour, you see everywhere these 3D break lines cross these green contour lines. That's a crossing break line. And there is a potential that those elevations are not exactly 100% the same. In fact, I guarantee you they're not, because they put a little bit of contour smoothing on these contours. So they're slightly out of position from where they really should be as they cross these edges, okay? And so you get a whole bunch of errors where those crossings occur. And they would be small, but they would still be, non-zero. So what I want you to start thinking about, if you don't already, is the idea of contours. Drawn contours are not what define the surface. Rather, they are defined by the surface. In other words, they are an output from a surface, not an input into making the surface. Now, I know you're going to say to yourself, well, sometimes that's all we have. Well, that's true. Sometimes it is, and we have to build our surfaces from contours because that's all we have. And that's where we're going to make sure we remember that little switch that says minimize flats. Okay. But if we look at that, then we realize that, well, these contours were probably generated from some other more controlling information. And in fact, that's the case here. So we could just isolate those two, the break lines and the points, use that to select our data, or alternately, we could freeze the contour layers and get them, get them out of our way. Everything else, all of these road edges and little boundary things are drawn at zero elevation, so it's not going to affect us if we select this, or either way you want to do that. And again, on the layers toolbar now, same as on my view menu, if I say, I'm going to freeze a layer by pick, well, I'm going to come in here, I'm going to pick one of those contour labels, the contour line, and I'm going to pick one of the intermediates. Now I see I still got a patch of contours in these obscured areas. So I'm going to get one of those, one of those. And so now I've got everything in my drawing showing except for their drawn contours. And so everything that is at elevation is indeed just the things that are supposed to be elevated. Okay. So now let's go back and run our surface menu, triangulate and contour. So we run that command, and here we've got our familiar stuff. Look at selection tabs, make sure nothing's filtered. Let's go to the triangulate tab and let's write the triangulation file. And let's select, and we're going to call this one, instead of EG contours only, this will be EG-VKLN-spots. Okay. So we'll save that. Now we're not going to use this inclusion exclusion area because I did not draw the boundary yet. So we're going to let it do it for us with this shrink wrap, and the amount of perimeter reduction would be, let's just leave it at a medium, let's say. And if we want to see it, we can go over here and turn it on to draw it, put it on a particular layer, etc. We would then also ignore zero elevation, so I can leave all those other stuff showing and have those ignored. And I don't need to minimize flats here. I don't really want to. This is only if I'm doing stuff where my source data is contours. And now let's go to the contour tab, and let's go ahead and draw the contours this time. So we'll turn that on. We'll contour by an interval. And I'm going to look at these layers. It's going to go on V, surf, cont, enter for my intermediate contours. I will check to draw the index contours. That's going to go on V-surf-cont-INDEX. My contour interval is 1, which makes this a 5. Different things here. Now, I'm going to uncheck hatch zones. Otherwise, it would create a colored banded map of elevation zones, which, see if there's a picture of it. I don't want to step you through. It takes a bit of time. Not terrible, but here it is. If you do hatched zones, it creates hatching between the contours. So when you're done, you're going to wind up with, oh, I thought they had a picture of it. Okay. Anyway, it's a color-coded map where all of these zones, like you might have elevation 13 to 1325 would be red. Elevation 1325 to 1350 would be pink. And, 1350 to 1400 would be blue. And it would color in, and you've seen those. It's actually what's technically called a chloroplath. I thought they had a picture of it, but I guess not. So, anyway, that's a way, if you hatch zones, that's a way you can show that. And might be a way if you wanted to identify, if you hatch zones and said the only zone you turned on were areas that had slopes steeper than 25%, then you can indicate that. That's a common thing that people want to see, particularly review agencies. If you're doing erosion control designs, they want to see high-risk slopes, so you could have the steep areas be colored in and the rest are not. So that's just an extra little thing there. But now, here's what I want to talk about next is down here, the very first thing everybody wants to turn those contour smoothing on. So let's smooth up those contours so they're prettier. Well, that's true. It will smooth the contours. But you notice over here, I've got this little slider where I can control how much smoothing. There's just a little preview of it. But What happens is if you put too much smoothing on it, the contours are very tight, close together, they can overlap one another because the smoothing adjustment of one contour might bulge it out a little bit in a spot. And if it has a nearby neighbor that also got bulged out, they could actually cross. And they're not really the true contour location for that surface. They're just smoothed out a little bit. I am a big one for not doing your smoothing. I know that makes some squared off looking type of contours sometimes. There's ways around that. We'll talk about that in a minute. But so let's turn our snow smoothing off now. Todd, we're getting toward this explanation of these hard break lines when we talk about the contour smoothing. And we'll talk about that in just a brief minute if I can get uh, yeah, I'll show that around the curbs, for instance. Um, so if we do this, we're going to turn there, no smoothing. We'll just leave it there. We'll look at our labels and we can go ahead and turn on the labels and again, fill out your uh, layers, your text sizes, all this different stuff. You want to probably most of the time, you want to check down here to hide the drawing under the label. So that makes it look like the contour line gets broken where the label gets placed. You can have it up here, physically break the contour at the label, and it will do so. And then you could also have it put that broken piece on a separate layer. If you say draw the broken pieces, you could put them on a different layer and then freeze that layer, et cetera, et cetera. But the advantage to not breaking those and hiding them under the labels is that you can slide that label along that contour line and reposition it. Whereas if you do this break, it nails that label down right where it happens to fall. Okay. So we will label the index only. We'll align the text with the contour. We're going to draw it on the real z-axis, and then we can either do by intervals, like one label, two labels, three per contour, etc., or no internal, only on the ends, or we can go by a distance factor. So let's go every, oh, I don't know. Let's say 500 feet would be sufficient for this site, and there's really no real way to find out what that's going to look like until you do it and see. There's nothing intuitive. So I said, okay, now it wants to remember I turned off the use inclusion exclusion and I want to select the points and break lines to triangulate. So that's everything here. So I'm going to just grab all my data. We'll say okay. And there you see it drew that boundary for me, which is right there. Okay, that's part of that internal shrink wrapping. And it also drew contour lines. But look what else popped up. This little data problem log. And you have three potential problems with data when you're modeling a surface. You can have crossing break lines, you can have T intersections, which essentially are crossing break lines that just don't quite cross, they meet at a T. And then you've got vertical edges. And this problem log is going to show you areas that have differing elevations at these three potential sources of data of error. So I do have some crossing break lines. I say I've got 5 crossing break line errors, and you can expand these. So let's expand both categories. And I've got 2 vertical edges. And notice when you select, you'll see a little marker in the graphics screen to show you where they are. You can zoom to, it will center it, and then zoom in, click, 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 or you can just click over there and then, use the wheel on your mouse to zoom in, zoom to it, it'll point to it. All right, so right there's where I'm going to be looking, and I zoom, 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 and I zoom in tight enough, I see that indeed I've got a 3D polyline here. If I hover over that grip, I read its elevation as 1293.72. If I select this one and I read over that grip, It's 1293.68. So I've got 1293.72, 1293.68. So 0.04 difference. And in fact, right there it is. So all that means is when these guys were compiling all of these 3D break lines, so they were doing the curves, and then they did this one here. Remember, they're doing that by looking through a stereoscope at aerial imagery taken from, whatever flight height they were up in the air. So, they got real close. They got this area here, and here's another one, for instance. If I zoom to that area, it's again a situation of where they've got actually, I think, an extra. All right, so there's one 3D polyline, and it comes up and meets this 3D polyline. So that was part of the curve. And then they went on here, but there's a drop of 100th of 0.011. So you could resolve those types of things, and you could do that most readily by taking that one. You see that's at 1300.80. And if I just move it out and around, and I'm going to snap it back to the endpoint of that other one there. Now let's see if that has, yeah, see that's now at 1300.81. Okay, so your snapping will work in 3D to snap those up together. And you could fix things that way. You could go through and find them. However, I'm going to also point out some of these, like here's two. Let me zoom back out. If I look at these two, they're they don't even register to the nearest thousandth. So if I look at that, I'm going to zoom two and then zoom in, and I'll see. And remember, that's a vertical edge. So that's actually where these two things cross, and they cross. I mean, that's a crossing break line as opposed to vertical edge, is what I meant to say. They cross, but they're actually crossing at the same elevation. So I could probably safely ignore those. Or you could trim them off to each other. You could trim those 3Ds. Um, but now there's a couple of others. I'm going to go to this one and show you what that is. These three, there's one, two, well, not that one. So that one, and skipping the second one. So the first one, the third one, I guess it's just those two there now. Where this one got to. Oh, okay, that's just a little bit of an overshoot. Let's see where it's shot out. See how it crosses that. And the way to that I would really, fix that is I'd probably just pull this back, a little bit in there. Get this back to. It's there. Now this one underneath it is a 2D poly, so it wouldn't be used anyway. So now I've pulled that 3D polyline back away from crossing this road edge. See, that's the actual edge of the pavement. This is another edge of something. It had crossed just by a little bit, so that one would go away. But if I look at these two here, I'm going to zoom to that, and those happen to be, if you see what a marker is there and there, they're crossing break lines. Now, what they happen to be talking about or related to are these structures right here. And I'm going to change this one to be red, and I'll make this one green so you can see them as differences on the screen. If I go to my first one, there it is. All right, so this particular or those particular two items are parts of this drainage structure, and I think I just did something. Let me redo that. I thought maybe, yeah, I had scooted one out. But those are these particular two items are part of this little head wall for this. There's a culvert underneath this entrance, and there's a ditch that goes down through here. So what they did is when they got these things, in their stereoscope, and they were zooming around there and setting those elevations, they got in a little bit of a hurry and they allowed those to cross each other. You see right there. So one of them needs to be on the inside, one needs to be on the outside. And so what we're going to do is go back to our top view. We'll leave the elevations alone, but we'll zoom down into it, and we're going to need to pull this so that it doesn't cross. We need to pull it back on the inside there. That's elevation of 1393. So if I pull this back, say right in uh, here, I think I did mess that up. It's now 0. So I want to pull that back in. I'm going to snap nearest. I'm going to snap back to itself right in there. So now you have to still has elevation. So that now is completely on the inside of that green line till you get here. So we got to do the same thing with this. And we got that is an elevation 1371. So I'm going to pull that out to here. And I may have to reset that vertex elevation. Nope, that's still 1371. So that's fine. So I didn't snap to the underlying 0. That's fine. Let's see if I can pull that to there. Yep. Okay. So now I've got these two items no longer crossing. All right. So the white one is part of the planimetric, and they've only drawn the single line there. So that part would not matter. Okay. So let's back this off. I'm going to exit that error box, and I'm going to redraw this. I'm also going to change this so it's a little more readily apparent. And we'll set that up. So we'll give you some weight on it. Say okay, and we'll also turn on our line weights. Regen. So there was our little tucked in boundary, and that's fine. We don't have to fix it if you don't really need to worry about it. However, one thing that you could also do is we could use these building outlines as exclusionary areas. So let's take a look at putting that in there. Now I've already got this one drawn, and I've got something else for you to remember and to think about. Let me also I'm going to go back and change. There's too many white things on the screen. I'm going to uh, look for my contour layers. So I just typed up here my filter asterisk, CONT asterisk. And instead of red and white, I'm going to make this, let's make it, say 253, and this one will make 251 maybe, or 2, let's see, there's 251. We'll make that a little bit heavier. Let's say a 0.2. And we'll make this one, say a nice skinny 0.09. And we're also I'm going to load up a particular line type that I happen to have. And you don't need to do this. It's purely cosmetics. It's just so you can see it a little better. If I look at my iCAD line, I'm looking for these two contour types. And so now for my index, I want that to be contour. My intermediate, I want that to be contour 2. And I'm going to P line gen, make sure that's on, it's not. And I'm going to select one of each of those, right click, select similar. I'm going to then turn on the line type generation so it doesn't restart everything, and I'm going to set my line scale to 0.5 and set my regular line type scale to 1 with MSLT scale set on. Regen. So that's going to be what my existing contour is going to look like. Now here's what I want you to think about as well. When you start to resolve these errors like we did with that head wall and a couple of those little crossing things, you're going to need to then go back and rebuild the surface. Now, here's what you need to be aware of when you do that. If you go to surface and run triangulate and contour, one of the switches that we had in there was right here on the triangulate tab, we said, well, there's our shrink wrap reduction. Actually, I'm going to not use that anymore. I'm going to use the one that it already drew. And I also want to do that so I can get to these exclusion areas. All right, so I'm going to do that first of all. But right here's a switch you need to be aware of under erase previous contour entities. If I were to say that either the current surface, the one I'm working on now, or anything that was generated with the contour command, the triangulate and contour command, and that includes that shrink wrap boundary, by the way. If I have that and it is set to be erase, to erase those things, then when I go to run this command again, and if I hit OK, it erases all those things that were previously generated by this command. If you don't, if you leave it as off, and I did leave it off because I wanted to be able to select that outside border, then when you say OK, and it's going to ask you if it's okay to overwrite, and now it wants you to use the inclusion boundary, which you can get there, then the exclusion boundaries, you can get these building outlines, etc. All right, so I'm not going to do much more. Now it says select the points and break lines to triangulate, but look what's still out there are those contours that the last run generated. They would now be incorporated into our data. We don't want that, okay? So that's why that switch is there, is to give you a quick way to get rid of those for the next time you model the surface. But if you don't want to, in a case like mine, where I wanted to use this generated outline, and I didn't want that to go away, use there's another command that will run first under edit menu, erase, and that's erase by layer. And so right now I'm going to either type the layer names if I happen to know what they are, or I'm going to select the layers from the screen. And I want to get rid of those previously drawn contours, the ones that my command drew. So I'm going to select by layer. I'll select that label. I'll select that contour line, and I'll get one of the intermediate contour lines. So all that's done is identify the layers that those were created on. You can also restrict it to just certain things that you want to erase. Well, I'm going to say all. I'm going to say OK. Now they're going to go away, and I'm left with my boundary. And now I can go back, excuse me, to triangulate and contour. Erase, ignore my zeros. And let's see, do I have smoothing? I have no smoothing. So OK. OK to overwrite. Yes, it is. Here's my interior or my inclusion polylines. I found one of those. It still wants more but I'm finished selecting, so I hit enter. Now it wants exclusion polylines. And now's where I'm going to come up here and get these building outlines. So there's one, there's one, there's one. Now that canopy, I'm going to trust that I was able to see under the canopy. There was a shed and a tank. These ruins, that's just an old concrete pad. And I see I've got points along it, so they were able to see that. Um, Canopy, there's some points underneath there as well. So they, maybe surveyed under there. So I'm just grabbing all of these building outlines. As my exclusions, I'm through with that. I'll hit enter. And now it asks me again to select the data. I'll just grab everything. Everything 0 has been, now it says error, discarded the perimeter polyline because it was not closed. Okay. I think there was one of those, that building outline somewhere wasn't closed. Don't know which one it was. So now you see I've got only the one vertical edge that we did not fix, and it's only that 400ths, and I've got these crossing break lines. They're both at 0 elevation difference, so I'm not going to worry about tracking that down. You can see down, if I select one, you see the Z diff down at the bottom is 0.00049. So it's so close, I'm not going to worry about trying to fix it. You could have. And you've got settings where you can, give it the tolerance that you're willing to live with and all that kind of stuff. So I'll just say exit. It now has built that surface out there on our disk. And let's go take a look at that in comparison to what we looked at yesterday. So if we view 3D view, surface file viewer, and we get our EG from break lines and spots, that's going to come up. Now here we're going to spend a little bit of time to understand how to use this viewer better. First of all, it is a relocatable window. It can go on, multiple monitor on a different monitor, or it can be resized and maximized and all of that. You zoom in and out with the wheel on your mouse, just like you normally do in the regular CAD window. You can see my exclusion areas now. I guess one of those was not closed. And you can zoom in and out by rolling the wheel. You press and hold the wheel and move the mouse, and that's a pan. But now there's a couple of ways to navigate your way around in this in 3 dimensions, and those are going to be controlled over here on our side panel. We have 3 tabs. We got the view control, different settings. Again, you could turn on, for instance, to display the contours. That's every 2 feet. I could put those in at every 1/10 of a foot if I wanted. I just type that out, and it generates those contours from this surface and draws them on the fly. So, but if we wanted to match what they gave us, we'll set that back to a 1-foot contour interval. All right, so you can show those if you want. Now, they're just drawn in memory. It's not creating anything out there on in the CAD system. You can also turn those off if you don't want to see them necessarily. You can display your triangle edges, and you can set those to be all of the triangles that got built. And you can see on the outsides where they got trimmed out, and on the insides they're missing there as well for those exclusions. You can, back on the view control tab, this little icon that looks like a fishnet that's colored in green, it's a toggle. It just shades these 3D faces that it's created and drawn for us here. Okay. So sometimes that's useful. The little yellow square and the blue circle, think of that as the sun up in the sky, and that's going to be where you want the sun's position to be, maybe casting shadows. So if I'm up here to the upper left, I'm going to cast shadows to the lower right. Now that happens to be what we most often perceive, because advertising for they show something that looks like a 3D floating image almost always has its drop shadow dropped to the bottom and to the right. So we've gotten conditioned by Madison Avenue over the years. If, for instance, if you pull this all the way down to the opposite corner where my shadows are cast up and to the left, you see this area down here looks to be sunken. This area here looks to be mounded up, okay? But in fact, it's not. It's just the way the shadows are. You see how that's perceived separately? So if something's not looking right to you, just move that around a little bit. And I would, by normal behavior, I would keep it up and to the left, just to cast shadows the way we're used to seeing them. Now, what these other icons are, first of all, let me ask you this before we spend too much time here. Do you guys use this tool, this 3D viewer? Are you familiar with what these icons and things do inside it?
No, we don't.
Yes. No, sir.
Okay. Sarah's no, Lisa's a yes. Todd, you said no, right?
Yes, we don't. No, we don't use it.
Okay. So I'm going to encourage that, but I want to give you some tools that makes it easy for you to do. That's why I want to spend a little bit of time here. Um, so
That's fine. We're just learning. Yeah, I mean, so.
okay. All right, so we've got this viewer that's going to help us look at things. Now, this is actually the very same viewer. There's two different commands. One is called a drawing viewer. It's on the view menu, 3D views. One says drawing viewer, one says surface file viewer. They're one and the same. It's just a matter of whichever one you choose and as to whether it asks you to select objects or to select a surface. And when you select a surface, it goes out and reads the surface file and creates all of these little 3D faces. So I could, in my drawing, back out in my drawing, I could draw the 3D faces from my surface and stick them in my drawing, and then go out there and use the drawing viewer and select those faces and load them up in here, and it would do the exact same thing. But I don't need to do that. I'm going to just let it read the surface file, and it makes these faces in memory, and then it gets rid of them and doesn't hog up my drawing. So when you come into this with a surface as your chosen thing to view, you also get those controls under the settings menus to draw the edges and draw the contours. If you're just selecting data out in the drawing, it can't calculate contours because it doesn't have these faces to figure out where those contours are. All right. So here's a couple of things you can see as you go down there. You can set the color by elevation. If you change that from none to all, for instance, you'll get a spectrum of color. And you'll see this quite often on a lot of uh, YouTube videos that Carlson uh, has put together, because for whatever reason, they love to see this in this fashion, and they leave it that way all the time. They never do anything other than show you color by elevation. To me, it's sometimes a little bit distracting, but I do use it, and I use it in this fashion. I look for, if I've got a bad spot in my data, let's say I had a couple of bad points over here, and it was like 250 feet high up in the air. So I'd have this little spike that's over here, but then it was going to make everything else down here look all blue, and then only that little spiked area is going to be the high part. So I want to sort of expect to see a nice little even distribution between low to mid to high elevations. And you can change those colors, by the way, on the settings tab. There's this set colors button where you can set the color of high, middle, low, the contours, the edges, all of those different things you can preset your colors for your surfaces. If you look at more, you can have 8 different surfaces loaded at one time. So, that's another way. And this is another good QA/QC tool. Remember, I showed you on the drawing cleanup where you could scan the drawing and look for that elevation range. You can also turn this on, and if you see numbers, you can't really set the interval, but it will show you, low-ish to high-ish. And if you see numbers down here like real close to 0 or maybe really deeply negative, for instance, or outside of the range of what you would expect, then you know to go and look for some error in the data that you use to build the surface with. One of the other things you can do on that settings is you can turn on a box, and you would say if I wanted to find my these are slightly different. I'm used to that being right here. Oh, bounding box, there it is. So if I look at the box, see, that's another way, and along with these numbers over here, or even if you chose instead of box only, box with labels, and you saw those numbers, you would get a sense of, um, what those ranges are. And like at this box, if you turn, I'm going to just make that box only. So if you saw this data, and yet when you spun it up, the box looked to be like, several 100 feet or 1,000 feet, deep, that means there's some kind of data somewhere that's pulling all that stuff down. So that is a couple of ways that you can use this just for a little QA/QC review. All right, so I'm going to go back now and turn off this color by, I like to see it like so, and I'm going to choose. Now notice I keep hitting these buttons over here. I've got a plan view, which does a zoom extents. I've got also a case for, let's say if I'm zoomed up and rotated around, if I go over here and hit this button, that just resets it to plan view, but doesn't do a zoom extents. It just turns it vertical under my eyeballs at the moment, okay? If I do the other one next to it, that's also turns it vertical, but goes out to the furthest extents. Now I've got some other icons here. I've got these plus and minus, and then the plus minus dynamic zoom. I've got zoom previous. I've got the hand for panning. I've got these zoom in and out with arrows and stuff. All of those you can forget about and ignore and just use the wheel on your mouse, because again, press and hold the wheel. That's a pan. Roll the wheel in and out. That's your zoom function. All right, so the others that we need, there's the color in for the 3D faces. And again, they have to be some 3D faces. If it's just drawn line work, you won't be able to see any difference. There's an arrow here. Now, because I chose the surface file viewer, notice it says in the little pop-up there, switch to 10 edit mode. And if I do that, I get this little thing down here where I can edit my 10. I can swap edges, add break lines, remove points, etc. Again, I'm not a big proponent of that as a means of fixing problems with the data. We'll come back to that, another time. Obviously, we do it sometimes, but that's what it means when you are in the surface view. That's what the arrow means. When you go into this by choosing drawing viewer, even though it's the same actual viewer, the arrow then doesn't allow you to edit the 10 because there's no surface data. It becomes a pointer, and then things that you point at with that pointer show up down on the bottom of the screen on the status bar as to what it is, what layer it is, what the elevation is, at that location. And we'll see that when we look at this in the other direction. Now, something a lot of people forget about, they don't ever pay any attention to, is we've got these clipping sliders down here where you can clip near, you see, so if something's in your way, you can sort of clip out, and then here's the far, I'll get it to, where we basically are clipping out things that are farthest away from our eyes. Now that's near and far, that's in relation to our eyes. Top and bottom is always in relation to the vertical axis, the elevation, okay? And you can even type in a known number to limit that to something. You can synchronize top and bottom and front and back. But let's say if I've rotated this up, for instance, and let's say I want to look, say right in this area here, but I want to get some of this stuff out of my way. It's a little too crowded. That's when I can use this clipping. So I'm going to clip near. You can see I can pull this back and sort of get get some of the stuff out of the way. Or if there's something, in the distance, again, I'll clip, the far, I'll bring it up like so. All right. So again, it's just visualization. Now it's doing nothing to the drawing. All right, so let's take a look now at the real breadwinner here, and that's how do you navigate your way around in the drawing or in the view? And there's a couple of things. If you go over here to the right-hand side of the View Control tab, uncheck this little box if it is checked. And those are sliders. Now you can see if you slide, you grab the slider, you can see I'm sliding around the x-axis with that one. I'm sliding around the y-axis with this one. And I'm sliding around the z-axis with this one. Okay, now I'm going to try to get those all back even, Steven. Now, so the real way to do this with the mouse, instead of using these sliders, is to choose this icon right here. It looks like a little three-dimensional cube and a rotating gray arrow around its base. That's our navigation icon. And when we do that, move the cursor into the screen area, and you see once we're off the panel, it becomes a Z with a little rotating arrow that indicates rotation around the Z axis. As you approach and get over, and it's not exact because you're in a perspective view, so it's not always going to be right on those edges, but when you get over the bulk of the data, it switches to an XY axis, and you see the arrows indicate. So if you press and hold the mouse and move up and down, that's that Y motion. If you move back and forth, that's the X motion. But to do the Z motion, you have to get off of the bulk of the data and get out to the edges and click and go, left, right, up, down, whatever to do the spinning. Now, to set this, and as you notice, by the way, as you do this, notice the sliders over on the panel. See, it's reacting to what you're doing. So to make this easier to do, and what I found makes it, and it will become second nature to you very quickly once you do it, but it used to confuse me to no end because I've done a lot of 3D data manipulation and all kinds of other software, and some have different ways of looking at it, but this was the easiest for me to remember. And if you go ahead and hit the far right icon that says Zoom Extents, so it's looking straight down on it. And that means the little sliders have returned to the middle position. And then let's lock the Y axis. We're not going to ever allow any rotation about the Y axis because what we can do is spin around the X axis and then spin around the Z axis. And then you go back to that X axis because it is now, where that Y axis used to be. Don't try to remember any of that. It's basically babble. But here is how to line yourself up to look at anything you choose from any direction. And it's the easiest way to do it is if you keep this bit in mind. So let's say I want to look down that road edge. Remember, we've been talking about that road edge over here on this main road. So if I want to get myself down here and looking down that edge so I can inspect it a little better, I'm going to do it this way. And I'll show you how to switch it to another one. After we look at that road edge, we're going to go up here and look at this retaining wall on the upper road, and then we're going to look at this little loading dock retaining wall in here, and then maybe look up this little pond and valley. So here's how to do this. You choose the icon of that cube and rotation. So it's that XYZ icon. And you're going to position the cursor over the data and you're going to go down toward the bottom. But once it switches to Z, go back up to where it's still that X and Y. You want to make sure it's looking like that. And here's what you're going to visualize. You're looking at this bulk of data and maybe say to yourself, hey, I'm looking at my garage door in my driveway. And what I want to do is reach down and grab that garage door and raise it up into the ceiling, and lay it back. It's not articulated, it's just a slab, and we're just going to click and hold the mouse. And notice if I go up and down, if I go left and right, there's no motion because I've locked that Y button. So I'm going to push this up, and if I go up and say need to get another bite, I'll release the mouse, go back down toward the bottom, click, and push it up again. And what I want to do is I want to lay it back fairly obliquely. I don't want to go up underneath it. I just want to be at about an 80, maybe an 85-degree oblique layback. Once you've done that, now release the mouse, put it down at the bottom only, not the right, the top, or the left, just the bottom only, and then spin it around until you're lined up looking at what you want to look at. So we're looking at our road. We're going to line up to the road there now. And now I'm going to just point at it and roll the wheel. Okay. I can then, if I need to, sort of fine tune it a little bit here. But there you see how nice and crisp that road edge is. And also, and again, I'm going to change this little orientation, look at the other side of the road. All right. So I'm going to reposition that a little bit. So there's that little flat walking area I was telling you about. Now, let's go and look at that on the backside. You can either, go reset it back to plan view, or I just find it easier to zoom out enough to where you can turn that around and then zoom back in. And so there now is that little retaining wall, those little raised up areas in there. You can see the curbs are really nicely defined. Okay, now I'm going to go back to my plan view and I'm going to come down here. I'm going to lay that up and I'm going to spin it around and line up with that loading dock along that building up there. And I'm just going to roll into it right there. And I remember all those little ski jump ramps that we used to have down there. Now that's been cleaned up because we're using the brake lines. And I'm going to put my shadows back to the way I'm expecting them. And then maybe I'll zoom out enough and zoom back around here. Let's look up this little drainage channel, little sluice area in there. And let's say maybe I want to visualize this pond. And then again, if you need to, clip things on and off, and again, the top and bottom is truly elevation based, but these near and far are in relation to your eyes. Okay. So, and if you ever get, things are sort of lost and out of whack, uh, you know, just go ahead and hit that plan view again, go back, raise your garage door up, spin it around, line yourself up, roll yourself in. So there now you can see that little retaining wall for that particular area up there. Okay. So, oh, by the way, let me do that one more time. I didn't mean to exit it. Um, so a couple of other things you can do with that is all these icons down below. You can save an image, you can print it, you can make a PDF of it. If you go to the settings tab, you can see this has, let's say you rolled this around and you say, well, I need to do some real fancy edits in my actual drawing. I want to work at this little area over here. You get that turned around like that, and then you can choose this set the CAD view to that current view. That's on the settings tab. And if you do that, it tells you it's now set. So now when you exit the viewer, you are in that perspective, even though I wasn't, I'm at the same rotation and vertical change. So if you wanted to edit, this file directly um, in your 3D views. So couple of other things that you can do as well with that viewer. Let me come back to my zoom extents. Here is the 3D view, and that's one we chose, was the surface file viewer. Notice those two icons. They are on up here, my surface menu, which has triangulate and contour. It's got there's a surface inspector. If I turn that on, for instance, let me choose the right, let's do the break line spots as our first one. We'll do the contours only as the second one. And now I notice if you move this around, you see there's slight differences in the surface elevations. You're going to see them show up there in that little window. And of course, if you click the mouse, you'll drop the text into play. All right, so take that back out. But if we do this view, our drawing viewer, now that's the same viewer, but now it asks you to select entities for the scene. So I'm going to select all of these entities, hit enter. There comes my viewer. I'll maximize that. Same thing happens, but notice if I click over here with those little shading, there's a slight, you can see these text change hues a little bit, but no real change in that because there's no 3D faces in this. Same rules apply. Grab that, raise your garage door up, zoom around, point to it, roll in, okay? So this lets you choose things in the drawing, and notice the arrow now, instead of the 10 mode, this says switch to pick mode. So now if I do that, if I pick on something, notice on the status bar down below, it's telling me what type of entity. That's a polyline. It's on a layer V topo break line. It has an elevation range of something such to something such. Here's one. If I point to this one, it says it's an LW polyline. It's on that layer and has an elevation of such and has a length of such and such. You can also, for instance, if you double click it, it tells you to select an action for that thing you double clicked. You can change its layer, you can set it to 0 elevation. You can add it to a selection set, re-render this if necessary, blah, blah, if you've done something to change layers or elevations, etc. Cancel that. So you can also, again, the color by elevation still applies. Okay, it's just not colored in solid. There is also a vertical scale exaggeration where you can, if you've got if it's really, really flat and you want to see it, exaggerated, you can do that. And so it will basically stretch it just in the viewer. Obviously, it doesn't do anything in the drawing. Just make sure you put that back to 1 if that's what you're expecting, because that sticks between sessions. Okay. Settings, you don't have the display contours because you don't have those faces to create. All right. You could say display triangle edges. If I had triangles in there, that's still there, but I don't have any. So, but one of the things that you can do beyond, and you do this from either side, is look at the model tab. And the model tab governs what is in the viewer. And right now, that's all of that selected data. And if I scroll this up and down, you see I've got various layers. Let's say those pink layers. I'm going to go back to my view control, get my pointer, and I'm going to point to, say, one of those points. And it's not telling me. Let me see if I can get it can't really be exactly on it. Anyway, you could say in your model tab, these are different layers. Now I could say for those layers that, see, I've got some building outlines. Here's some V site outlines. Well, all of those zeros are not showing up. These are just the break line and the, I've got the contours and I've got the break lines and the points. That's what I selected. But let's say if I wanted to turn these contours, remember the ones that I drew right there? If I wanted to turn those off, let's say I want to turn the intermediates off, I can just, right click and freeze the layer or change it. I can even make it, if I wanted to highlight something, I'll make it bright red. So now they're all bright red, the others are not. Or I could double click it and just turn them on and off. So I've got that V topo deep, that's my points, that DTMP, there's my mass points, say digital terrain model points. I've got the break lines. If I wanted to turn them off, for instance, I'll turn them off. I'll turn my contours back on and then maybe set that color back to, whatever it was. All right, so you can turn individual things on and off. You can change their behavior. You can do that. But now here's the cool thing, and this is how you know that it's actually the same. The same viewer. In fact, I'm going to turn those points off again. Except I'm going to get the right layer. All right. So of these things, you notice we've got points, we've got polylines, and these actually basically we'll look at this as polylines on individual layers. So those index contours, for instance, see, it's got every single one of the contours, and you could, if you knew which one it was, you could change its visibility and, show it to be a different color, what have you. So a lot of control over the visibility of this stuff. But notice there is a surfaces tab or icon here. And I can right click and choose add, or I can choose these items up here. So if I add a surface, so right now it's going to be just like I'm viewing the surface. So I'm going to add this break line spots, the one we just been doing. And it's going to come in just as if I had loaded up the surface viewer. However, I go back to my view control, I get my arrow. It still doesn't let me do surface edits because I'm in this thing based on it being the surface, or I'm sorry, the drawing viewer. So I'm really about looking at these entities. I'm just using the surface for reference. Back to the model tab. If I, let's say, I'm looking at this surface, that wall over there. If I go to the model tab and I open up this surfaces, I've got a list of the surfaces I've got loaded. I could have more than one. In fact, let's go ahead and load in the other one from the contours that I chose. I choose that one. So that's now both of those. And you see down at the bottom of this little window, I can double click to toggle the visibility, or I can just right click and choose hide surface if I want. Either one works. So if I hide, if I get my mouse to work, if I hide that one surface, hide that surface, now I'm back. There's the bad surface. You see that? See all that? See the comparison between the two? I'll go back to here and just toggle this one on and off. Now there's the good one. Let's toggle that one off. That's what the good surface looks like. That's what the bad surface looks like. But I know a lot of people, a lot of companies that would have built that surface from the contours and lived with this and just gone on about their business. But that can be some serious miscalculations in earthwork volumes. You can't tie into features very correctly. So, one of the things that I do constantly as I'm doing my modeling is I'm just constantly in and out of this viewer, making sure that everything looks to be exactly like I intend it to be. Okay. Now, the same thing happens if you go into this viewer as the surface file viewer, you load up the surface file, you can go to the modeling tab, and instead of choosing surface, although you can add another surface at that instance, you can then also add entities, and it lets you go out and pick things from the drawing to add in to the surface viewer. Whereas here we added a surface into our drawing viewer. Okay, and then you can, all kinds of things you can do. You can add some text to this scene and then save it, and all kinds of different, behaviors that you can do with it. You can turn blocks on and off based on, this model tab. It's very, very useful, very powerful to help you try to visualize things. A lot of people never use it just because in fact, a lot of people never even use the 3D viewer because they found it too difficult to use. But I would like to encourage you to explore that a little bit further. If if maybe what you've learned in this class will teach you that, first of all, it's very fast and it doesn't reset your drawing views and come right back out to where you were in plan view. And it can also help you view things sometimes that you can't normally see. For instance, if I go back and set my AutoCAD settings, point style, I'm going to put it back to this little dot. And so now, I can't really see those points very well. I can select them and tell that they're there, and I can zoom, I can see them on my screen. You probably can't see them on what I'm showing you across Zoom, but they are there. They're little dots. Can't really see them. But if I use that drawing file viewer, which was my little cube icon here, 3D viewer window, grab my data. Now watch what happens when I do that, is that those points show up nice and heavy. All right, that's one of the aspects of that viewer, is that when it's looking at points, it's going to make sure you see it. All right, and there's even a setting over here somewhere that you can, your point pixel size. So you can turn those on to where you can really see, hey, that's where I know I've got AutoCAD points. All right, so I'm going to put that back down to 3 or 4. All right, so that's going to, that's one of the benefits I have found. And plus I also find it to be a lot more intuitive on navigating my way around as opposed to being out in AutoCAD and doing it, because it's just maddening out there. All right, so again, I would encourage you to use that and load that into uh, your quiver of arrows, if you will. Now, we're going to stop and take our little 15-minute break here that we're a half hour late to get to, so I don't want to push you too late in today. But when we come back, I want to wrap up this idea here I want to just briefly illustrate what those hard break lines are supposed to be for and how they're used, and how I don't really know that they work all that well. But we'll come back and do that. So let's go ahead and have our full 15 minutes. I'll give you till it's approaching 5 after. So let's come back at 20 after. Any questions before we go right now?
No,
Anybody?
sir.
Lisa's good. Sierra's good. All right. I'll see everybody back at 20 after. On. All right. So now let's talk about this. It's a bit of little bit more advanced concept, but that's these hard break lines. And I'll show you what they're meant to do. And again, I don't really, I never use them. I just don't know that they work. I never use them because I never uh, turn contour smoothing on. I do my contour smoothing by adding additional data to make things smooth out. I will point you to an article here. Let me see if I can find it. Let's see here, this one. Yeah. Here's an example. This was, I used to be a columnist for American Surveyor magazine. I wrote a little column in there each month called Model Behavior, and this was one of the articles. And this illustrates what we're talking about. Here's an example of this building at some, finished floor elevation. It has a 10-foot sidewalk with a 2% or a 2.08%. There's your quarter-inch per foot cross slope to define the edge of the parking lot. Okay, and then so it set those two corners at 100.5 because the building elevation was at, I guess, let's see, 10 times 2, that'd be just a tenth. So it was like 100.6 or 7, whatever it is. Anyway, this sidewalk edge was defined as 100.5 feet all along its length. Okay, so that's a constant elevation. Then the parking lot was defined to be down to this corner here at 97.98 at a 3% drop, but it was only a 1% drop down to 99.66. Okay. So in modeling that, you wind up with contours that are not smoothed if you only have these points at the corners that look like this. And that represents the triangle formed, the triangle edge went from this lower right point to the upper left point, and it was basically two big giant triangles. Now, down below is that same surface, but with contour smoothing applied. And a lot of people do that because they say, oh, well, that makes better sense. That shows a smoother surface, because otherwise up here, it looks like there's just a big folded crease down the diagonal of that parking lot, which indeed it is. But if all I do is turn on contour smoothing, the surface hasn't changed at all. It's still two triangles with a big crease down the middle. And if I put that on a thumb drive and stick that on a dozer and tell it to go out there and grade that parking lot, it's going to come up looking like the one up here in the top. And you can't rely on the contractor to look at these contour lines and go every contour line and figure out that kind of stuff. He's going to load in the surface model and go out there and prepare that surface. Isn't that correct, Sierra? Because you guys don't need to be trying to trace every contour line and try to make that match that. You need some other more automated information. So,
Yeah.
yeah. So one of the things that we can do to help that is to add in additional points along these driveway edges. Because right now, they're just the four corner points. That's why there's two giant triangles. So when you do that, you wind up getting triangle or contours that look like this, a little jigger jagger looking contour lines, because the triangles, you see, I put points all along these lines, and the contour or the triangles formed by sitting at each point, looking around itself and finding all of those other points over there. And that's the way they found it. Now, some people will spend an hour or two trying to swap triangle edges until they get those kinks out of the contour line. And that works to a point, but you chase yourself into a corner a lot of times trying to do that. The better way to do it is to give it more data so that the triangles don't go edge to edge, they go edge to something else. So what I did was I put where each of those points were, I did an array. I did a edge on this side and I just copied it up every 10 feet all the way to the edge. And then I densified those lines. So in 3D, excuse me. So in 3D, instead of it being just this upper top edge, and you can see the curb top there, and this bottom edge, I've got all of these lines that connect those points, and then they also are densified. So now the triangles are going to form between all those points. Instead of going edge to edge, it's going to go, little smaller triangles. So I've densified that, and that's going to wind up as a surface. And you can see this surface is more as intended. It doesn't have that crease down the diagonal. It just drops 3% on the back side. It drops 1% on the front side, but it's smooth everywhere in between. And the result of that extra little data supplementing is that these are the contours that got generated with no smoothing applied. These are just directly from the triangles. And you can see that's a much more pleasant looking surface even than, say, this one with the contour smoothing just turned on so that the algorithm does it. This is really more of what we meant for that parking lot design. So that's what I tend to do. I don't generally do my edits. So that's, whoops, didn't mean to kill our training guide while I was at it. I just want to get rid of that one file. So that's what I typically do to supplement those. Now, what we were going to talk about in terms of hard break lines, let's go through and I'm going to erase by layer again, and I'm just going to keep those same layers. So it's going to get rid of the contours because I'm going to build this surface again. But I'm going to code in some hard break lines. And what that is meant to do is if in fact, let me isolate these layers here, that one. Let me restore that. Let me. Uh, no, hold on a second. I know what I'm trying to do. I want to isolate just the points and the break lines. There we go. So that's going to be my data to build. But what I want to do with that is I want to take this. Now, there's a couple of things. You see how far apart those points are? I might want to densify those and give them a few more points, same as like this, because this would form a triangle, possibly like this, just one giant triangle. And it may be valid, but I may want to smooth it out a bit. Um, so that's one thing I'm going to do. Now, in the older versions, you used to have to go to polyline utilities and densify the vertices, and that adds them into the drawing elements. But now that's built into the modeler for the surface, and it only does it in memory, so you don't hog up your drawing. So that was a great improvement. We'll turn that switch on when we do it as well. Now, the point behind hard, what they call hard, why do I have that? There we go. What we mean by a hard break line, and you can see under our surface menu, you have, where do we have it. We've got this predefined boundaries. You can set those up and pre-name them so you don't have to pick them each time, but you can also then set hard break line polylines, okay? And once you tag them, you identify them, then you can highlight them to see where they are, and then you can report their names and all that kind of stuff. But what we want to do is establish some hard break lines, and I'll show you how they're supposed to work. So we do that, and I'm going to select these curves. And let me get a few of these. I won't grab them all, but I'll show you how this is supposed to work. I'll do those, but I won't do that one over there. So hopefully you'll see a difference. We'll see if it works or not for us. All right, so we're going to make those hard break lines. Okay, so they've now been tagged as hard break lines, which I can see to just highlight them. You see they light up and show you which one you coded as hard break lines. Now, the only thing that they're intended to do is control when we triangulate and contour. We're going to triangulate and contour again. Looks like I got rid of my boundary outline. Oh, no, I didn't. I need to turn that back on to restore my layers. So if I triangulate and contour again, I'm going to my triangulation file. I'm going to make this one e.g. break line spots dash hard break lines. And we're going to use those inclusion areas. We won't bother with the exclusions for now. We'll just let them go, ignore zero. But I'm going to turn this switch on now to densify the break lines. So those longer edges, every 10 feet, I'm going to drop a point in them. And again, it's just going to do it in memory, okay? And now, here's where the hard break lines come into play, is if you do use contour smoothing, and I'm going to run this up to about an 8 level. I'm going to say, okay, and answer my prompts. Here's my inclusion perimeter. No more of those. I won't do any exclusions. Select my data. I'll just type all, hit enter, hit enter. Now, what's going to happen? I got those same little errors. I'll pop out of that. I'm going to now freeze these break lines there. Let me freeze. There we go. So these contours now have been smoothed. So they have been, extra points have been added, and they've sort of been smoothed around. Now, what a hard break line is meant to do, and remember this one, these were set as hard break lines. These over here were not. So what they're meant to do is when contour lines cross them, because they're a hard break line, they are not supposed to be subject to any smoothing as it goes across those features. So if I look at these, I want to make sure that they go, face to back. They're looking pretty good. I want to come up here now, compare a couple of these that cross, and where else did I have some over here? I think I did these. And these are certainly going around the face of it. Let's see if I can look. All right, so yeah, see, this is why I said I don't find that it works very well, because what it's supposed to do is when you have a hard break line, that is supposed to control the contouring that crosses those. When I turn contour smoothing on, it's supposed to recognize that as a hard break line and not smooth in this instance right in here. It should hit there and come right down the length of this and then up here until it starts to break away and come up to the back. So, like I said, I don't think it really works the way it's supposed to work, but that's what that is for, is if you look at Carlson help, the hard break line. This tags break lines with a description so that Triangulate and Contour can identify those as hard break lines. It's invisible, doesn't change the polyline. And it says that it will not smooth the contours as they cross these hard break lines, even with contour smoothing turned on. So they say you should do that when you're looking at curbs and walls, and say should go straight across without smoothing. But as you saw right in here with this, where was it? This one right in here, it didn't really work. Now, if I try that, let me try the other smoothing real quick. And let's triangulate and contour again. And this time, let's, instead of using Bezier smoothing, that's really all I can do is none or Bezier smoothing. Yeah, I can't really. If I reduce vertices, subdivisional, surface. All right, let me see if that'll work. Grab this, none and all. You get the right stuff. It's like that. No exclusion now. Ignored. Oh, sorry. I need to turn back on those break lines points. There we go. Now triangulate and contour one more time. Say okay, and choose this. Nothing there. All data. All right, so let's next zoom in there and take a look at that particular contour that was this one. So you see it still did the zoom, it still did the curving or the smoothing around there. Whereas if I had smoothing off, it would hit that face and walk the face until it starts to come up and then go all the way around here to where it hit, as close as it gets to that and come back out the other side. So like I said, I don't think it works very well the way it's intended, but that is the intent. So, be that as it may, and that's one of the reasons too that I don't ever use contour smoothing, because to me it's not representative exactly of the surface. It's more just to give you a pleasing looking set of contours. So let me freeze off these. Here's again, and now because I already did that build once before, I can just come to, and you can do this, you don't have to rebuild this, you can just contour from a tin file. I'm going to use the ones that we did without the hard break lines and without the contour smoothing. I'm going to turn no smoothing back to here. I want subdividing these surfaces, and that should work. Don't need to worry about these at this point. It's just going to put them in there. There we go. Now I'll select similar and set their line type scale down a little smaller. There we go. So that now would be, here it is without the smoothing. And if I come back up and look at that same contour line, you see how it hugs the curb. So that's what, and that's what it's supposed to do, Todd, is if that's identified as a hard break line, it was supposed to have prevented that contour smoothing as it crossed those, and it didn't. So, like I said, I don't think it works. That was the intent. And I don't think enough people have complained to tech support for them to fix it. Over the years, it's just never come up. So that's really all you really need to know about hard brake lines is that they don't really work. And there you see where we fixed that head wall. We got better looking contours in that area anyway. Okay. So that should conclude what we want to look at there surface wise. All right, just keep those lessons in mind and how to use that 3D viewer. Now let's talk about the rest of these concepts here. We'll go to uh, to edit and process, excuse me, a raw file. And one of the things, yeah, one of the things that we did that we want to talk about is, you know, when we, all right, let me get this back. When we talk about raw file processing, they're going to be used to process that raw data file. And those are typically a file that holds all of the observations, all the survey measurements out in the field, excuse me, that have been used to generate or to locate a point. So this would have no real effect on just a point file. It would have to be using the raw file that created the points, and it lets you go and actually edit those values. We saw a little bit of that yesterday when we were setting in those traverses and side shots. And we're going to use that RW5 extension on the files. What we're looking for is a raw file. And here's the key to everything here is that several assumptions, talking about measurement theory and how do you apply these to survey observations. And so obviously you try to be as careful as you can, but you're going to, come back to the field and measure something over again if you didn't observe it correctly in the first place, which again, that old adage of, measure twice, cut once. So, and here's where I get a lot of, I get this attitude from a lot of surveying companies. So given the state of the quality of our survey instruments, and particularly with GPS equipment and high precision theodolites and total stations, it should be close enough. And one, company owner, he said, well, that's the way they treat it. They just do it. But the problem is that you cannot get rid of random errors and systematic errors in the instruments. The only thing you can do is to spread those errors out equally among all the different observations. And I say equally, I don't mean just individually, like divide up the number of angles and spread them out just as an average. They also will, consider the length of the observation and all of that. So it gives more weight to more precise observations. And that'll get you into the least squares type of adjustments as well, where you can actually apply individual weighting to specific equipment types and observation types in the well. But the typical way that we've done this are using these three particular types called the compass rule, transit rule, and the what is it, Bowditch or something. But and this again talks about the least squares, and again that's not a bad approach, and because that actually uses a statistical method and it does these best fits. So yeah, compass rule, transit rule, and Crandall rule. There's also a Bowditch rule, but the three that we have available here is compass, transit, and Crandall. And that's typically the transit rule was done mostly back when we were surveying using transits and tape. So we measure our distances with tapes, but our angles with transit, and they were considered a better observation, more precise than the taping measurements. So it gave more emphasis to the angular adjustment, whereas the compass rule, which is what we tend to use more today, especially with total station electronic distance measurements, is it basically equalizes all of those together. Crandall rule is the opposite way around, where your distances might be measured more precisely, I think, if I'm recalling that correctly. But in this case, see, this compass rule adjustments are the preferred because it assumes that angular measurements are as precise as the distance measurements. See, transit rule assumes angles are more precise. Crandall rule adjustment makes the same assumption, but provides a limited least squares type adjustment that was easier to compute before we had computers. Okay, so that's what Crandall does. All right, so and least squares, which is a big scary term for a lot of folks, the only thing really that you need to know about it is that you can control individual weightings, but the way it works is it comes up with an adjusted position such that all of the adjusted positions compared to their original raw positions are going to leave what are called residuals. And those are going to be the distances that it moves during those adjustments. And what you do, those are called residuals. And so you add up those residuals and you take their squares and you find the case where all of those residuals have their squares is minimized. And that's why it's called least squares. So that's says down here, the least squares criteria is reached when the sum of the squares of residuals have been minimized. Okay, so that's what that is. So let's take a look at a simple example, and then we'll load up a separate one. So we're going to start a new blank drawing, and then we're going to open up this raw file called raw file 1. All right, so let's go ahead and we'll get out of this and come back to it. There's one thing I'm going to show you folks. Do any of you guys have like the Civil Suite and you have the GIS module also? Any of you?
Like the full version GIS
Yeah,
for Carlson.
yes.
I think mine has GIS, but it only like one menu, one tab, just to import and export shape files.
You've got this one here under.
Yes.
Yeah, okay. So if you have, and I won't step you through it, but if you have the actual GIS module, there is an images where you can bring Google Earth images in as long as you're registered to the right coordinate system, the right state plane and all that. And you can bring those in to sort of help, you know, proof up your survey work. So we won't go through that.
Geolocation also works. Well, I guess I have
Yeah,
geolocation because I have Civil
yeah.
3D.
Uh-huh.
Okay.
Well,
So it's the same thing, right?
actually, Carlson there's an article in Carlson's last newsletter about geolocation. Um, I don't know. I can grab that real quick and look at it. Um, Let me see. Actually, I think the easier approach is going to be this. Let me just get it from their website and Well, let me see if they've got it. Maybe there's an article about it, geolocation. I think this is it. Yeah, so this is where having a complete site image, several tools to assist. You can afford geolocation services. The first requirement to use GeoMap makes you in a known projection. So we do all that. A known position, label lat long, annotate, label format. All right, that gives us our position. Turn on the services. And we set the location. If it's not prompted to run, set location. Okay, so that ties you to the ground. Turn map on and off. All right, so this is running geolocation, which is GeoMap drawing setup. We do that. In the annotate menu there, turn on the services. All right, so here it is. That's what I was looking for. It does require the full GIS module to do what he's talking about here. All right, so that's the same thing that I was going to potentially show you. So if you don't have that, you don't have that ability necessarily. But since you have Civil 3D, or if you have AutoCAD map, you can do all those things separately from that anyway. All right. So anyway, we'll leave that to your own discovery, and we'll push ahead here. So we're going to start us a new drawing. And we'll just call this one raw file example. Will be in our, let me change directories, make sure I'm in my survey class data sets, raw file example. And we'll, 30 scale is fine with that. We don't really care about the coordinate system. It can just be a grid system. We'll say next. Now there's my empty drawing. Nothing there. What do I have in terms of just a few layers? All right, so let's go to then our survey menu, and we'll do edit process raw file. And we want to open this raw file that's included in our data set called raw file 1. And you can see a little preview of it over here. And this is what it produces. And if you look at this, we've got a couple of items. Now, all of these things, like that's a store point command, a PT. There's a BK, that means that's a backsite. Then these are all traverse commands, traverse, a CL, which is a closing angle, and then there's an angle balance observation as well. Then in this store point record, it stored a northing of 5,000, an easting of 5,000, and it had a description or elevation of 100, control 1. Then it took a backsite and it set it as the azimuth of 270 degrees. And that's actually this point down here that you see, this 0.99. It's not actually you know, that we set the number right here in this angle balance where we closed back to our backside. That could have been, you know, a steeple on a church halfway across the town or something, but we knew the azimuth for it. So these are our typical observations. And you see, as I select in these individual lines, it's highlighting down here below in aerial graphics which particular observation that is that set that particular point. And you can see there's setting point 4. So that's 3 to 4. So I was traversing, I was 1, which is also under 5 down here at the bottom. Let me get to the, so I'm sitting at 1, which is under 5. Looking back here to the backside, I turn an angle right of 180 degrees, go 100 feet, and I set a zenith angle of 90, and I set 0.2. That's my trav 2. I move up, I'm 2, looking at 1. So my next angle right is 270 degrees, 100 feet, set trav 3. So basically I'm doing a square. And I've got one particular error right here. When I set 0.4 instead of 100 feet, that was 99.98 feet. So I missed it by 200ths. And then also turned that next one around to set 0.5 at 270. Oh, also this angle was not 270, it was 269, 59, 58. So 2 seconds out, 200ths off. So I've got a case where I've got an error of just in one particular observation, but we don't necessarily know that in our larger sets of observations. So here's what you do. There's a couple of things you do here on your open and save settings. For instance, you can have it prompt you for a raw file when you first start up. You can set a closing shot description match. So if you have a description on an observation, that will force it to be that closing shot or angle balance. Now, I don't have it in here. I've just got, but that's there if I want to have it. Automatically save the coordinate file, yes or no. A couple of things you can do there. The edit menu, of course, you can basically that controls what you're doing in these particular spreadsheet entries. You can delete row, modify measurements. Now you can do that just by clicking directly in it. You can also click in here and, you know, at that point you could add these particular types of information. And again, all of this stuff is typically gathered by the data collector. You're not going to need to be building those things directly. But let's suppose you set this and you were sitting on 1, you thought you were looking at 2, that's what you recorded in your data collector, but maybe that was a different point. So you could come in here and change that to a different point number if, or instead, that's the foresight point, that's 2. And if we moved up to, we're looking at its previous traverse point, which was that 1 point. So anyway, those are the things that you could change in here, and you could change these particular types of observations. Now, what I've done is my spreadsheet colors. I've got like traverses, side shots. If I'm collecting sets, multiple angles, and set collection, you know, if I do multiple measurements, and it can average those and etc. Instrument height, rod height values, if I had those, I would see those. Oh, man, I didn't mean to do that, but oh well. Let's set my side shots. I want to set that back to green. All right, so those are those. And then you can turn on things like your description records or hide them. You can show the record headers or not. And the record headers are these. Every time when you change to a particular type of setup, you'll see those headers. Let's see, let's show the record headers. So now you see the headers are these lines. So it shows you what those are supposed to be. Let me set those record headers. Instead of black, let's make them make them red. So there were, all right, so there's my headers. And so the first thing you want to do is you look at all this, you want to do some processing. And the first one that I would typically do is a no adjust. Now, here's something about traversing. Todd, since you guys do a bit of traversing for most of your work, let me ask you your concept of traversing. When you traverse, you're going to set up on a control point, backslide another control point or some reference, and you're going to start moving your way around. How do you close out your traverses? Typically, do you come back to where you started?
We typically always come back to where we started to make a complete closed interior loop, but
Okay.
every once in a while we may start at some known points and then like RTK some ending points and then do the point to point one. Yeah, I mean the
Yeah. So you're starting at two knowns and you're ending at two other knowns. Okay.
yeah.
All right. So what I want to throw out there for you is an example of something that I ran into. I was working for a company that designed landfills, and we had like a 6,000 acre site. And we know our design and months, and we get to where we're going to go out and start doing some stakeouts, but we're starting to miss things on the site by, significant amounts, half a foot here and a foot and a half there. And so we got back in touch with the company that supplied us the base mapping, and that was, in fact, the same aerial company that did that one we just looked at before, that T3 sample from T3 Global. And so they gave us all the data, all the control data, the survey, the traverse information. The traverse closed nicely because it started here and it's closed back on itself and everything was worked. But here's what was up. The distance meter that the surveyor was using had a calibration error in it where it was reading everything a little bit long or short, whichever way I don't imagine. But imagine this in the figure you're looking at on the screen. We read those legs and they're supposed to be like 100 feet long. But let's say we've got an error in our distance meter where it's reading everything only half as long as it really is. So it's got a scaling error in the distance measurements. So when you start at a point and you go out, however many legs, long and short, and in fact, let me just keep yours up there. I'm going to exit out of this and do a figure here. I'm going to draw, let's say this was my traverse. All right. And then if I, let's see, let's just, we'll copy that. I'm just going to move it over here from that. And I'm going to make, this one is my, one that I observed, and I had this one, and I'll make it green so you can see it as different. All right. So what I'm going to do now is I'm going to scale this. I'm going to make it radical so you can see it. So I'm going to scale it, by something like that. So it's really big. So let's say we had a scaling error in our distance meter. And what happened was this. He started off at the same point. He measured, and he had like in this case, it might be his scale error was like 25%. So he's reading about 75% of each leg. So he starts off and he goes here. He thinks that's 100 feet, but it's really only 75 feet. He goes here and he thinks that's another 100 feet, but it's only 75 feet. You get the idea. But as long as he goes around here, and if it's a scaling error to where it's a percentage of that distance, you're going to still wind up on the same point you started at. And this is going to give you know, the same closure that you're going to get if you were doing this one, okay? Whereas if we had something like this, to where his original traverse was supposed to come around. I'm going to do one more little thing here. Oh, get rid of that. And we were going from, so let's say we did um, something like, let me try that one more time here. Symbol, let's make that say 10, so you can see it here. So we did a symbol there and a symbol there and a symbol there and a symbol there. All right, so let's suppose these are our known control points. So if we start at this one, backside this one, we set our red ones around, we come back and we close into two other known points, and these back here to another, you know, horizon close to that location. So if you do this with the same scaling error and you go around this green, when you hit here, you're not where you're supposed to be. And it becomes readily available, readily apparent, as opposed to when you do these closed internal figures, because you will come back where you started and you won't be able to find that based on that. If he had done this situation, he would have known that misclosure right there, and he could have resolved it either by just adjusting the raw file, which would distribute that error all the way through, and he would have wound up coming into where he's supposed to be, even though his measurements were off. But, and again, we're talking something very slight, but over, you know, a 6,000 acre site, those little distances tended to add up. So this is actually the situation here when you start with two knowns and end on two other knowns. That's a little bit more robust. I know that we do this all the time. We close back where we started and we check, and that gives us a good control over everything, but it doesn't really check for the scaling errors of the distance measurements. It only gives us good information about the angular measurements. Okay, so that's something that, for whatever reason, isn't taught very often in survey classes. I picked that up in my geodesy classes, but a lot of surveyors don't study geodesy because they're, you know, a lot of what we're surveying is a closed figure. It's a parcel, it's somebody's property, you know, so we do it that way. I understand that. I'm just want you to keep this in mind. And if you have the opportunity to use two other known points, you're going to get better results. You're going to possibly find some additional errors. Okay. So just keep that in mind as a little something in the hip pocket. All right. So back to our raw file processing, which was my raw file one. And here we're back. All right. So, and again, in this little example, we've got that same closed figure. So let's go to our process menu and let's do a no adjust. We're just going to get our raw data, and you can tell it if you're using multiple measurements, you can take the average, you can take the last ones, you can, same thing for backside reciprocals, you got your different choices, you can average the elevation, the distance. et cetera, create and point protect, calculate scale factors for each measurements. And you can apply all of that stuff. I don't know people who generally do that for single site work. It's generally not enough to even show up visually, but it's there if you want to use it. And then let's report the closure, and our closure point number, that was our point number 5, which was supposed to be 5,000, 5,000. We start at 1, come back around. All right, so our closure, if we do 0.1, that's going to be where we're supposed to close back in. Now, I'm going to say, okay. Now notice up here in our descriptions, point number 5 is trav5, and it says equals 1. I'll show you that in just a minute, what that means and why it's there. So you can specify the traverse points either automatically because it reads it and knows it went 1 to 5, or you can be prompted, and you can see what that looks like is it's going to bring this up, and you can choose, whether something's going to be included or not. Okay, so it's the same thing as just having that to be automatic. So we say okay, and it's going to go through here and it's going to run, and it gives you a bunch of stuff that you've got, any scaling and earth curvature corrections. And here's our closure results. And you see our closure is pretty crappy, actually, although it's better than what a lot of agencies used to use in the old days. We used to have it had to close within 1 in 10,000. But anyway, it's still pretty bad. And you can see that my northing is pretty tight, but I'm off in the east by about 2/100ths. And, it's just about a due east, a little more than a due east for my closing leg. So that gives me, um, you know, my closure computation. So I started at 5,000, 5,000. It reports my observations, and there you can see them. See, I don't think, that doesn't wrap around, just puts the descriptions there. And now here's this thing called a checkpoint. So my reference point 1, I measured 0.5, and you see that description? Traverse 5 is supposed to equal 0.1. That flags that as being a checkpoint, and it tells me how far off I am at that particular point. And again, gives me that distance, and it shows me the line in my file, in my raw file. It's on line 9 that set that. So I occupied 4 at a slope distance of 100, a horizontal angle of 270, blah, blah, blah. And that is what set that point right there. All right, so that gives me a little bit of information. And I go back to that and I look at 0.9 right there's where I set that 0.5. So that might be something you want to check out in case you might have missed it, but obviously the miss was up here. You can tell just by inspection. All right, now, you may notice also that when we did that, our figure was at an angle. But when we did the process, no adjust, it processed everything we read. And since our initial back sight was 270-degree azimuth, it recomputed it. And now that it's in the position that it thinks it's supposed to be in. So again, if we'd, changed that instead of 270, let's just make it 200. You see, it's going to change those to match. All right, so now we've done that initial thing, and let's look at these process settings on the process menu at the bottom. And right down here, this checkpoint settings where I said report checkpoints, and it's looking for a checkpoint code, and I've got an equal sign. So that's why this trav5 equals 1. That's not the description of the point. The point is still trav5. But it has this equal, which flags it as a checkpoint to go back to 0.1. And that's what you'd actually type into the data collector if you were wanting to flag that as a check shot, okay? And you can see you've got, various tolerances here that if they're outside, so there's your distance measurement tolerance. So if it's outside of those tolerance values, it will report them and, let you make some further information. You report any blank descriptions if you want, balance direct and reverse, or use directs only, balance foresight and backside, or foresight only, just however you want to control what you're looking at. Store the point record to coordinate file only if it's empty. And that's a store point. That's like this point number 1. So this action actually created point number 1 at those coordinates, 5,000, 5,000, because the coordinate file did not have a point number 1. All right, so you can also then compare measurements to those store points if you want. So it would do the same thing as this checkpoint to find that out. All right, so then if we go back to process and let's look at an angle balance. Now, what this is going to do is going to leave the distances alone, and it's only going to distribute the angular misclosure throughout. So when I set this up and give it again this point number 1 as my reference closing point, and I say okay, there's my traverse starting 1 to 5. I'll say okay. Now here's where it gets the reference closing angle, and that was this angle supposed to be from 1, actually it should be from, see if I get this right, from 5 to 99. And that closing angle should have been, I think, 90. No. I do an azimuth of 270. Yeah, okay. So from 0.5 back to my backside point there that I used for that closing shot, that angle balance shot to 99, should be so from 5 to 99, and the reference closing angle, this is what it should be. So it happens to be what I observed, as well as an azimuth shot. And then when you put that value in and tab out of that field, you can see it calculates these values up above. So the measured closing bearing was south 89, 29, 58 west, the measured closing azimuth, and there's your angular error. So there's 2 seconds of error. So it found that angular error. Say, okay. And what it does in this angle balance, again, reports the closure before the angle balance, and there's what it was. We saw that before. Here's our traversing information. Here's our checkpoints. And here's a little warning that says, hey, that distance exceeds that tolerance value that we typed in of 0.01. So that, again, lets us flag that as a possible source. And now here is after the angle balance gets applied. So it's going to distribute 2 seconds of that total error among 5 different traverse sides, which would adjust those angles each by 4/10 of a second. So then closure after the angle balance comes up here, and you see I've got a, and again, all it does is the angles, not the distances. So that now gives me some slightly different numbers here. And I get a closure precision error of 1 part in 2588, whereas before I had 20,900. So that's not necessarily always a better approach, but you do want to balance your angles typically to spread those errors throughout, okay? So then if we use our compass rule adjustment, and again, we've got a reference closing point, which was 0.1, multiple angles, which we don't have any here, vertical error adjustment. I'll leave it as least squares here. Now here's where you can choose to apply angle balance or not. I don't know that I agree with having that as a choice. I, for one, think that you should always do that, and yet it's going to actually, we'll do it twice here. Let's uncheck it the first time. And let's see, let's set these, okay, no side shots to worry about. I'll say okay. Starting 1 to 5, that's okay. And here now is before, this is our raw closure. And then down here, we're going to get all the adjustments, etc. And here's our compass closure adjustments. And so that now has closed. I don't see where they actually write that into the report, but you can see that 0.5 is now sitting at 5,000, 5,000, and 0.1 is also at 5,000, 5,000. So it's now distributed the angle, has distributed the distances, whereas some of these distances were good to begin with. It was just the one that was a bust. Okay, but if that were a systematic error throughout the whole traverse, it would have spread that equally among those different, and then come up with these adjusted coordinates. I wanted to, let's see, there's that 2,900. They used to, in older versions, recompute the closure, and it's probably a good thing they took it out. Let me make sure if I've got it on here. If I, yeah, I don't see that anywhere. If I do this, do I should be clicking back to 0.1. Squares, apply angle balance. We're gonna put coordinating unadjusted, report side shot. Yeah, it doesn't give me the option to recompute that closure, but when you do it now without, if I don't do the angle balance and I run it, there's that still starting closure. Here's our compass closure. It doesn't give you that. It still makes the compass closure adjusted point comparison. So there's your original and adjusted comparison. So it does bring that up. It doesn't recompute. It used to recompute the closures. And what used to happen was you would find out in some of these examples where if you applied the angle balance, your closure went down as opposed to if you didn't. And so some people were choosing, when they do this, they would then check or uncheck this to try to come up with better numbers. So it's not really, again, I don't think it's something that you should really be able to choose necessarily. Let's see, what was that's my options. Angle balance, not angle balance rather, but maybe it was just, well, no, it wasn't even that. If I did my compass rule adjustment, yeah, so some people were running the angle balance and seeing that that closure went down from the raw closure. And so they chose not to apply the angle balance. But in most of these cases, you're going to want to apply that angle balance so that you spread that error throughout all the observations. And so once that's done, and these are now computed, then you can go back and save the coordinate file, and then you can exit the raw file, save changes. Yes, if you made any changes, draw the line work into points, and there now is my points. I need to set my drawing set up to, let's make this, say a 50 scale. And let's set my points. So there's now my locations. And I've got this point. I've got 2 points here. I've got this one, which is 0.5 with that. It actually kept that description. And then I've got this 0.5, which is supposed to be 1. So that's showing you that it's just repeating that 0.5 and showing you where that is. Now you can see the, I don't know if you can actually see the difference between them. So that has a location. It's too small to actually zoom in and see. That's different from that one. Okay, so if I take that out and then just locate my points, draw them all. And there you see I've got 0.1 and I got 0.5. And actually, yeah, it actually did use that. It kept it as the description. So I would, maybe update that. And let's see. All right. So with that, let me change that point style just because I like that style a little better than that ugly looking text. All right. So that now gives us our adjusted points. And if I list these points now, you're going to see that 1 and 5 are exactly what they're supposed to be. And then 99, you see how that was probably supposed to be 5,000, 4,500, but because of the adjustment, it changed it a little bit. Same thing as number 2, should have been 5,000, 5,100. It should have been 4,900, 5,100. So that's made the adjustments, and that is actually, what those should be based on that as an observation. And it took this one single bad observation, but it distributed the errors all throughout everything evenly. So that's generally not what you want to happen when you're doing this. If you can isolate a particular one that's bad, you might want to fix that observation first. Okay. And now there's a couple of tools that can help you with it. If you look on the tools menu, you can do a find bad angle. So the first thing I'm going to do is go back to my process and I'm going to compute with no adjust. Just to reset these back and exit that. So now it's been reset back to its raw conditions. And if I go to my tools menu and I choose find a bad angle, reference closing point is 1. And it's going to go to okay, and it's going to find that, compute everything here. It's supposed to be, what do we say, 5 to 99. And it should have been 90. Say okay, and so now it's going to say 1 to 5 horizontal distance, find a bad angle. Bad angle is that setup 2, foresight 3. Now let me show you what that's going to happen. So setup 2, foresight 3 is this one right here. That's not the bad angle. Okay, the bad angle is actually down here. So even though that tool shows you that, it's not an absolute. It's just trying to find things statistically. Now there's a way to do this. If you go back to this no adjust and you look at those closures, here's where you can find if there is a bust in a single measurement. You're going to look at, okay, so it's mostly in the easting somewhere, but you're going to look at this, the azimuth of the error is 92, 54, 58. All right, so I'm going to actually copy that. I'm going to highlight it and do a Control C just so I get the number. And I'm going to close this off. What is my distance? Is 0.01906. All right. So I'm going to come out of this, no, and I'm going to draw a 2D polyline. And I'm just going to draw it here, just starting in someplace blank. And I'm going to go a distance of, well, just going to make it say 10 so we can see it big enough to go 10. And then the direction method is I'm going to use angle. And the angle code, I'm going to use an azimuth. So that's the line above it. So I'm going to use code 5. And the angle, and I'm going to paste. Oh, it didn't paste correctly. What was that? Let me display my last report. Let me just write that down. So that was 92, 54, 58. Distance was 01903. All right, so if I create that line, if I just draw from here, I'm going to go distance of 0.01903 by angle, code 5. The azimuth is going to be 92.5458. Enter, quit, and then done. So now I've got my misclosure, which is right here. And I want to move this. I'm going to grab that endpoint there. I'm going to go up to my figures. Let me just put it here in the middle. And let me draw one to 5. All right, now where's my little guy here? And if I look at that, and I move it from here, I think you can see this a little better as if I, let me copy that and then change its length. I want to extend here. There we go. We'll go a T of 50, well, let's say 25 feet. All right, so now we got something to look at. So now, this is how much 0.5 missed 0.1. Well, these have been adjusted. So if I go back to my raw data here and exit that, let's save this back to the coordinate file. All right, so I'm going to take my points, move the point attributes with the leader. I'm going to move that one there. So that's actually should be 0.1. It's the difference is down here. All I do was move the label. All right, so if I draw then 1 through 5, there you'd be able to zoom in there and see that there's your misclosure. You see, we started here, went around, and it came back up to 5 here instead of 1 back here. See, that's 5,000, 5,000. So I've got 1 down there. It did not draw the symbol for 0.1, but that's at the end of that red line. All right, so now the way you can check for a potential blunder in an error in a closed figure like this. Now, this goes against that advice I gave you earlier, Todd, about closing to 2 separate unknowns. Maybe not. But angular closures, because I'm missing, when I get up here, I'm missing in that direction. So that should have, swung that out that way. So the angle that caused, if it was all an angular problem, that means, because this came up short, that means that one of these angles is too low. It should, if I can find that angle and stretch it out, and that angle happened right up here. So if I pushed that out, it would have pushed everything back around into position. So generally, you can take that closing line, that closing azimuth, and then if you move that around, you can, like, it's generally supposed to be sort of pointing to the angle that has the problem, and it would bisect it. So this is not actually working in this square figure. But if it were one, if we had a bunch of different lines, and if you find the line that is most closely bisected, you could potentially find that. Now, the other thing is, if you see that, and it's also up here where this, where did I put that? Let me bring that back down here. So the one that's the actual real distance is this one down here. And if I move that up in here, you can see, there's that amount of extra distance right in there that it missed. And so what generally happens is, and you would see it better if that were gapped open. And so this generally tends to be along the same bearing. If it's a distance error, it tends to be parallel to whichever distance might have been the problem. Okay. So in this case, with a square figure, it's not really showing me anything there. So those are just some graphical techniques that you can use if you need to isolate a specific error. But again, in terms of our equipment today and with our raw file, this raw file that we were editing, oh, I guess I better get the right one. I missed that one. Yeah, but anyway, the raw file tends to, and here, let's let this one load just to show you what it looks like. What it's waiting on here. turn my side shots off. So there now, this is a rather lengthier set of traverses with interlocking networks back and forth. And you can see we start here at point number 1. Let me get my selection cursor so that, you know, that's a side shot there. But if I set up to look at this point 3, it jumps me to it up here. Again, these are all a bunch of side shots. If I turned on all the different side shots, you'd see them show up. So you can see that's more like what we typically do with our work. All right, so I'll turn the side shots off. These are just the traverse positions. And again, this is that raw file is called North Line 6. Okay, and so that had a bunch of observations, and that's actually in your book. There's an exercise to go through the least squares adjustment of this. You'd see that, you know, how to use that in that particular adjustment. So in this particular one, for instance, if you did computation here, I had no idea what the closure is, but if I had to prompt for my traversing, you see it's got a bunch of these different ones I would need to pick. And I think the ones that you see in red are the ones that are just identified from that first little subnetwork. This has 3 networks and a fly line, 2 fly lines out from that original work. So it's pretty extensive file, and you can see all the information up above. And all of these DS records, those are called description records or comments. And that's where you put this information in here. You've also got your HIs and HRs are included. Yeah, so, and you can turn off your descriptions, for instance, display. You can hide your description records. So now it's just the observations. And, you know, you can see it's obviously much more extensive than any of that. Now, the other thing you can do that we talked about just briefly yesterday was you can set a separate coordinate file for your control, and it's on that tools menu. You get your control coordinates, and you can set a separate coordinate, a control coordinate file. That's what we're talking about, Todd, about using those so you don't keep adjusting those points around. Okay, so when you do that, it doesn't adjust those. It just leaves them alone into what you're working in. Okay. No, nothing to worry about with that. Although I think I did get them in my points here now. Do I? Nope, I still only have those. All right, so that's the generalized approach to that, is you're going to, you know, let it look at that traversing and compute those misclosures and then distribute that evenly throughout the traverse, as opposed to this particular example had one, you know, glaring blunder that if we were to fix, it would close perfectly flat. Okay, so questions on that? We're at a good stop for lunch. If we want to do that, we'll take our hour for lunch and then we'll come back, hit a little bit of field to finish, and then we'll want to look at the survey processing tools where we do the deed processing and the analysis for field versus deed points and all those different things that we can do. Okay. Questions on this stuff at all?
No, sir.
Everybody good?
Yeah, I'm all good, Ken.
Okie doke. Well, I will pause our recording and so let's next take a look at some field to finish. And there's a couple things I want to point out to you in your data sets and such. And that is what you have included, let's get to the right folder here. You have a couple files in here in the data set that we've been working with, and we'll come back to that for this example. But I want you to take a look inside your F2F quick start guide as to what a couple of resources are there. This will be for you to sort of practice as you get further into this as a practice. So you've got in here a series of files. There's a DWT, that's a drawing template. There's a CRD as a coordinate file. Then you've got a couple of guides here. You've got an easy start and you've got an advanced guide. You've also got these two different field code libraries. You've got a configuration file, and then you've got a setup file that governs some tree survey stuff. But here's what they are. Let's take a look at your easy start F2F. So this is a document put together by Doug Aberg. He's sort of the survey guru that works. He's not really, he's like me, he's not a Carlson employee directly. He's a consultant, but he has his own surveying practice, etc. And so these are little guides that going to help you, and they've included, it's basically an exercise as you go through everything here. And it shows you how to set up using these particular settings and different configurations. So here's this CSWEX CFG, which is your general configuration file that has a bunch of default settings for most of the commands. That would be when you are in Carlson, if you go to settings, Carlson configure, you would load and you would look for that file, okay? Now, what I would tell you to do before you say load and load it all up, make sure you save what you have now and give it a name so you can put it back to the way you have it now. So this just preps it so that everything will work correctly with these examples. And so, and he steps you through all of this stuff, and you can see what's, what all is involved. Let me view that as I continue to scroll. There we go. And all right, so as you work through those examples, you can see, I mean, he steps you through exactly what I was just telling you about there. Hit your load for your configuration and such like that, but do make sure you save the ones where they are. So, and then a template file that you can work with, and then how to use this code table. So it gives you some different examples. We're going to go through, some of this stuff in our exercises, and you can see, a code table, you can have various categories that you can create and edit and assign various codes into each of these categories to sort of, restrict what you're looking at any given time. Name of a field code, the description of the code, the label as it will be displayed in the drawing, if it has anything. So these are all what field to finish is going to do is it's going to look at your coordinates and it's going to look at the descriptions, and that's where it's going to get those codes. And based on those codes, it's going to draw a number of possible things. It can be drawing just points at specific symbols on specific layers. It can also connect line work between points of the same code description so that they all get created together. And that's how we actually collect and automatically create our break lines for when we bring those in to do our terrain modeling. Okay, so you can see all of this, and he's, again, very thorough in what we're looking at here. And so this will take, a couple of hours to work through, so we don't really want to take class time to do all that, but I wanted you to have this resource. And so, explains what those all do and some different examples. And it really gets some interest in here. He talks about this coding trees. So you can actually have a tree survey, which actually behaves a little bit differently. You can do it with standard field to finish, but it's just a separate sort of category inside the field to finish process that you can tell it this is for a tree survey, and it will obey a different set of rules. Okay, and you can see that when you are editing the codes, you can, let's see, not that particular one, but if we look at this, where we're looking at the codes, you see there's this tree setup and pipe setups. So you've got three different types of setups you can do. Is one for trees, one for pipes. So it will actually create three-dimensional pipe shapes and such in the ground. Or the other one, which is just the default, is what we call, just standard topo or planimetric type modeling. Okay, so he goes through a bunch of these examples and shows you that. And it's basically taking that point file and it will generate, something like this with the center line of the roads, the edges of the pavements, the driveways, the trees all throughout the buildings, puts them in three dimensions and builds the surface from all that data. Okay. And then he shows you a number of ways to do some edits. And here's how you can, for instance, rotate these catch basins, for instance, to line up, parallel to the edges of the roads and all that kind of stuff. So you can, figure out how to dress that thing up. There's an example of a sign and a catch basin and have it either automatically line up or how to make those edits itself. Okay, so this again is the easy start guide, and it shows you how to basically get things started. There's a little example explanation here of the difference between text versus point attributes. So when you're drawing a point, you have the ability to put the attributes down, but you can also put down text instead of an attribute as a block. So he explains all those differences there. It's pretty nice and thorough. Then there's a treatment on special codes, and these are all those little extra codes like append, different descriptions. You got begin and end codes, PCs and PTs to define the start and stop of a curve, etc., or whether to close. So it's sort of like you're out there drawing in the field when you're collecting these points. So multiple field codes, how does that work? Starting a curve. Again, all of these examples, and we'll go through a couple of these, in our limited time that we'll be able to show you about, but it's just really good treatment. And that's essentially the end of that document. And then you've also got a second document for the advanced guide. And that's a lot of the same type of information you're looking at. It gets overview, your definitions, the general tab, and what these different things do. There's companion coding, fixed parameters. So it gets a little bit more complex, setting the symbol tabs and bringing in these custom attributes that you want to display on points. Okay, so really, and here's an example of like a car. If you shoot three corners of the car and it can actually put in the symbol based on those three corners, it scales and rotates accordingly. This is using a template to draw a line. So if you're setting a line, say that's a curb, here's this idea of on the line type tab here, you can make a template right down here. You assign it to a particular template, and it's exactly the same editor. Well, not exactly the same, but it's very similar to the editor that is in the civil module for our roadway design. So here he's taking a single point. I don't know whichever point he's building this from. Maybe he's shooting the gutter line down here right up against the curb. And as he goes along down the road, he shoots the gutter line. Every time he shoots that point, it's going to connect those points up together, but it's also going to build a point that's essentially vertically above that point and then 6 inches back behind it. So it's going to define that curb as you go along the line. So here's some other examples, having automatic hatching for closed figures. Again, the special codes, multiple coding. And this is one thing that a lot of people miss out on field to finish, is that if you shoot this point right here, you notice all of the points that are coming along this feature out here are EP, edge of pavement. So there's my begin, there's the edge of pavement, there's my PC point, that's the start of my curve. And I go right here and I've got these EOG, edge of gravel. Well, that point happens to also be right on this edge of pavement, so I don't need to shoot that point twice. I just put the rod down and I shoot that point and I code it twice. I code it as an edge of pavement, so that tells it to connect to the previous edge of pavement point or be within the PC and PT. So it is an EP point, but it's also an EOG, and it's one because it's the side over here as a EOG1. I come along and I get this also EP EOG2 because it's defining this second feature. There's the other point for that edge of gravel number 2. And then finally, edge of pavement PT to stop my curve at my point of tangent. So these points right here can serve double duty. And that's, the way we will treat that. Up there is another good example. So you've got an EP EOG1. Here's an EOG1, also DRV. So it's part of driveway. You come up here and you've got this point is a DRV, end is a special code. So it's going to end the start of that DRV. And it's also going to be a point for a shed. And he's got a shed over here and he creates a rectangle and it creates that. So he does every bit of that work. He's got a point here called DRV. He's got a point over here, EOG 1 DRV, and it's the end of that one as well, of the driveway of the DRV end. This is DRV end. So you can see all along the line, and here he's got this EP, edge of pavement, begin. He's got an offset horizontal of 1/2 foot and vertically of 1/2 foot. So it's going to create an offset line that he does not need to survey. That's a horizontal distance of 1/2 foot away and a vertical distance of 1/2 foot up. So that would represent the face of curb and the back of curb. And if that's a square curb, he would need to have included the sort of nearly vertical line above it. He could either do that after the fact, or he could have used a template in there instead of this. This is just going to have the face of curb and the back of the curb. So it could represent a, say, a triangular wedge curb or something like that. All right. So that shows you, again, he's getting a bit more advanced. And then he starts in on the lessons. There's that same lesson 1 that's from the other book, and it winds up, let's just jump down here ahead a little bit, and he goes into a lot more detail on the tree survey and how those trees are defined and how they fit into, looks like I missed 26, 5, 6, 27, 28. I thought I jumbled the pages around, maybe not. All right, so, then ultimately when you're done, you wind up with that same feature, and then he's going to show you an example of using text instead of attributes. So it's essentially just expanding on what that getting started book is going to show you. There's the same rotation examples and little bit further detailed examples on that. Here's an example of moving text with leaders and, just basically how he can generate that finished plat very quickly with this process. And he does it again with these two different manuals, and you can work those things out. The easy start, I'd recommend starting with that one and work through that example, and then go to that advanced setup and work through that example. It's going to be the same example, but with some more detailed diving into. Okay. So with that, I wound up closing off our training guide here and put that back if we need it. And so let's look at what we're going to do now. We're going to create a file. So we're going to start this exercises on page 67. You can see here called field to finish processing. We're going to start a new drawing, and we're going to import points into our coordinate file called plat.txt. So over to where we are, I'll close off my field to finish, don't need. I'm going to choose new. I'll use this Carlson NCS survey civil template. It doesn't matter. I'm just as a different example. I'll choose my set. I'll go to my particular folder location, and I'm going to just call that F2F class example. And let's make that a 20 scale, 10th, 08th, doesn't matter. Define projection. Let's see, let's change that. These are just arbitrary, so I'll say no projection. I'll say, okay, next. It wants to know a coordinate file will be the next step in the wizard. I'll accept that. It will be a new file, and I'm going to import points from a text or ASCII file. So I can do this right now as part of the wizard or after the fact from the points menu. So I'll choose next. Up it comes. So we need to select a file to import at the top. So we'll select the file, and the one we want also in our datasets folder is called plat.txt. And you can see a little preview of it over here on the right. And it's got some descriptions and how they're going to work. And we'll say open. Now we need to choose the proper format. Here's some common ones. There's P, Y, X, Z, D, which is what we're after. That's what these identifiers mean. P is point name, description. S is skip. N is note. M is multiple notes. Y is northing. X is easting. And Z is elevation. So we have a point number, a northing, which is Y, an easting, which is X, an elevation, which is Z, and a description, which is D. Okay, so we're going to take that as our format. We have commas between them. That's also included here. If we had spaces, we would choose that. So different choices. So we see how the preview is going to work. We could either add some values to the point names, put in prefixes and suffixes if we wanted to change these numbers. We'll leave them alone. You can limit it to certain descriptions if that's all you wanted. If you had a header line, if you had a line in here that just said, say, PT, comma, NORTHING, comma, EA, if you had that little header label line, you would want to skip that header line. We don't have any. We'll leave that alone. You can do a number of different things. Once you bring those in, you can draw points or not. You can do a draw locator. You can go ahead and go straight to field to finish if you're ready for it. So we'll just go to draw locate points, and you can even assign a point group. And this is how, like, if you bring in multiple coordinate files from various days of different processing, you could assign maybe a date or a party chief's name or something so you know where these particular groups are coming from. Store to the coordinate file either a current file or a prompt for another one, or name another file based on an input file, etc., etc. So we're going to use the F2F class example. Store to the current file. We'll say OK. So it reads in those 54 points We choose OK, and it says, all right, now, as part of, you said you wanted to draw them, so it gives you the choice to actually change your mind again. But I'm going to put this here as draw locate and say next. And this brings up, just as if you were running the draw locate points command. And I'll just take everything that I see here, and on my layer name, maybe I'll just call that P and TS. It's just going to all go in that place. And I'll choose draw all. So everything's going to draw there. I need to change my annotation scaling so you can see the points. So I'll bring them back to 1 inch equals 20 feet. That's a little bug, by the way. I don't know if you've noticed, but you see this, when I choose these annotation scales, I choose the one where my drawing was set. Now watch what happens when I do this. I go to settings, drawing set, but if I change that to 50 scale and say, okay. Now, nothing happened here. But if I look here in my available choices, I can pull that down and now choose, well, I'm supposed to, 1 inch equals 50. Run that again. Settings, drawing setup. Yeah, there's 50. Let me make sure I've got the configuration set correctly. Ah, right here was unchecked. What is? Well, I got unchecked. All right, so if I do that, say exit. Now let's go back and change my drawing setup. I'll put that back to 20. And if I change this to 50, now what you might see happen, so I did that and it did change, and it changed for me automatically down here. That is governed by that little setting in the configuration where we say automatically have the setup change my drawing annotation scaling. Again, to show you where that is settings, Carlson configure, general settings. Down here on the left, these bottom two, I want to use annotative scaling, and I want to set the annotative to the drawing scale. So I'm going to let my settings set drawing scale is going to set that. Now, here's what I wanted to point out about this. That only works on files that are version 2014 of AutoCAD or newer. I think it's the 2014 version or newer. It might be a different version, but at some point there is a bug, and you don't get the warning in the AutoCAD version like you do in the IntelliCAD version, but it will say, due to a known limitation, unable to automatically set annotation scale. Now, what it does is it goes ahead and creates the scale, but you have to manually change the annotation scaling down here in the lower right of your status bar if you're using annotative scaling. And that will happen even if you start a brand new file. So here it's obviously would be in the 2018 version or 2024 version of AutoCAD, but whatever format version it uses for its DWG files. The problem is if you start with a drawing template that was saved under a different version, an older version, and you just carried it forward without resaving it, then that could cause that to happen. So if you notice that not changing, you just know you have to go down there and pull that list down and change it, or resave the drawing template that created this file. All right. Now I'm going to get my mouse to jump to it. There we go. All right, so here's my points, and I've just brought in a bunch of points. And now at this stage, I would see things like Okay, there's a shed, so I can go 5 to 6 to 7 and connect my dots or draw these up together. There's a utility pole, there's an iron pin and a fence line. You get the idea. You could sit here and play connect the dots all day long. PV, PV, PV. So that's all. Let me set my scale back to 20 so we're not so jammed on top of each other. There we go. So I've got these PV points, which are paving points. I've got some points along here, which there's a manhole, there's an edge of pavement, iron pin. Okay, pave, 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 iron pin, EP, PC. There's an EP point, an EP point, and there's an EP PT. So, you can see based on these codes that you would have to go through and start drawing those things accordingly. So what you would normally do, and those of you who use Field to Finish, is anybody not using it right now, by the way, just by show of hands or tell me yay or nay? I know, Todd, you said that you guys do it somewhat, that um,
Yeah,
you got
we do use it. Yep. Like I said, we're always willing to learn more because it's everything that we've learned is what we built between us three. You know what I mean?
yeah.
So
Mhm.
we'd like
Yeah,
to see how other people are doing it. You know what I mean? Or anything we can learn with it. You know what I mean?
sure. Sure. So let's sort of go through this exercise. I want to make sure we we have enough time to cover the deed stuff, although that won't take very much time. But so what we've got is a series of codes in our coordinate file, and we need that to draw our field to finish. And you could have gone again straight into that process as part of drawing the points. Even if you draw locate points, you see there's nothing in here that lets you do that necessarily. Although you do have this under your points defaults down at the bottom here, you can say use field to finish for point styles. So what that will do is it will read the code table, matching up the codes, and it will assign the layers and the symbols for the points. But it does not draw the line work. Okay, but you could assign the code table right here and you could do that. And I generally don't do it there. I usually, when I'm doing field to finish, I'll do it straight out of my survey draw field to finish command. And that's where we're going to go here next. So it tells me right now my code table is empty. I have none. So I can either import codes from the coordinate file itself, or I can select another table. So let's select a table, see if we've got one that will work. And not even sure. Let me get a little preview of this. I can't really make heads nor tails of this. Let's take a look at this one called field.fld. I'm going to edit the codes and I've got 17, 18 ground. So that one's not a good one to use. So let's change that code table. So let's see if I can do that from my code table settings. I can come up here to the set button and I can set. Oh, I'm looking there. So if I go back to my data, excuse me, I go back to my data file, you notice when I did that the first time, it looked in my settings folder. So I'm going to go back to my current data file folder, and I'm going to use that F2F example and choose that one. And say, okay, and now I see, okay, there we go. I've got things like hub, IPS, X, FL. I've got some additional things and they're based on different categories here. And so here's what I've got. I've got a series of codes. Let's just look at, say, the road features. I've got EP, I've got Mark, which I don't have anything in my file called Mark. Let me see if I've got, it was an EP, I had a PV. So I'm going to go here to all. I'm going to scroll down and see if I see a PV. I don't, but that PV is like a driveway. It's just paving that they're calling it. All right, so we'll build that one as we need. All right, so we have a bunch of codes here that were pre-built. We still need to build some of them. And let's take a look at something that might help us along the line. Let's go to our bottom buttons down here under our code table. And let's see code table by point descriptions. No, let me not. Okay, they've pulled that button over here under the right-hand column. Sorry, under feature settings, let's report the codes endpoints. So there's three different things you can look at. Code definitions, data points, those are the points in the coordinate file, or tree report for your different tree setups. So let's look first at our data points that's in the coordinate file. And you can say, well, sort those by codes if you want. You can only report any undefined codes, or you can give it a range, what have you. You can use a report and you can look for a field code match. I'm going to set that to asterisk. I'm going to sort by codes, no other restrictions. I'm going to say okay. And here's now what I have. I've got these codes on the left. And I see I've got 12P, 18D, 24D, and 8P are not defined in my code table. But I do have a BLD that is defined as a BLDG is a full name, a CM is a concrete monument, EP is an edge of pavement. You get the idea. And these are the points that are assigned those particular codes. And notice I've got a few of them that aren't defined. So if I go back and report my codes and points, and this time say only report undefined point codes, I see these are the codes that I need to add to my code table. All right. Now I can also report codes and points. Let's look at it by the codes. And this category match, I'm going to set that back to asterisk. I don't know why it's in there as B-wall, but left over from last time. I can report these code definitions and I'll just say, okay. And these are everything in that field file. And you can see these lines are my category names. So it pulls them out and sorts them, by the different categories. So these are the ones that I have. And you can also, let's go back and report the codes this time. Only report the codes that exist in this current coordinate file instead. So now I look at that and you see I've only got hub, CM, X, FL, BLD, shed, and EP. Those are the only codes I've got. Everything else is already defined, but I don't have any in my points. All right, so no problem. So now we've got some points, namely these that I need codes for. Now you can either print that out, write it down, remember it, whatever, or in my code table column on the left, I can choose code table by point descriptions. Okay. And I can say, I want to remove appended digits because that's a special case that we use to start a new feature. All right, we'll talk about that a little bit in a minute when we get to it. And it asks, do you want to append the current table or create a new one? So I'm going to append this particular table. So I did that. Now, they've been added. They're in my total list. I can look now at these ones that were unassigned, and that part doesn't work. Okay, let's see. Where did it put those? Looks like it put them in trees, put them in the last category, which was odd. Okay. So what I'm going to do is I'm going to select that first one there and come down here and shift select the last one. And I'm going to come to this middle set of buttons, which works on the whole code table as a whole. I'm going to say move category, and I'm going to move them right now to unassigned because I haven't assigned them anything yet. I've got my trees. My tree codes are now trees. My utilities, I've got a telebox, a pipe, a box, a CATV, and a power pole. I've got a couple of other things. Now, if I look at my unassigned, here's another one that I had. There's a UP. That's a utility pole. There's an iron pin. I've got an 18-inch diameter, 24-inch diameter. Those are trees. And there's a 12-inch diameter P for pine, or maybe that's 18D for deciduous. I don't know what it is that they mean it to be. 12-inch pine, 8-inch pine. I've got a PL, which stands for a property line point. It was just a point on line. And LP, which I think is a light pole. So it's a freestanding light pole. I've got a utility pole and a light pole and a PV. That's my pavement for my road. I've got a manhole. So I'm going to select UP LP. So I'm going to control click down here. Let's see, I've got UP. I'm going to control click. If I can get it to work, UP, control click into LP and also into manhole, MA. So I've got a manhole, a light pole, and a utility pole. I'm going to move that category then to utilities. And let's see, I missed this one. Apparently that's not working all that well with control clicking. Okay, if I do that and control, okay, now if I do them that way, maybe move category into utilities. Yep, UP now. Yeah, see, it's still different. I have to go to LP and move that category. All right, just little naggy things that haven't done. All right, so I've got a few things else to reassign. I've got an unassigned IP that stands for an iron pin. So I want to put that one in my set control. So I can either do it again with these middle buttons, or if I click the edit button on the code itself, I'll come over here and actually change the category from within to set control. Now these 18D, 24D, 12P, and 8P, these are all trees. So I'm going to click there and shift click here and move the categories to trees. And that leaves me finally with PL, which was a point on line. And it's maybe we'll call that a ground feature. And I've got a PV, which was pavement, and I'm going to put that under my road features. Okay, so this is just a way of helping you to limit, scrolling through long lists as you go along. All right, so now we'll hit the save button down here. So we've saved the codes. We haven't changed anything about them yet. So let's see what happens in our first blush. All we did was bring in the codes, but we haven't told it to do anything yet with them. So I'm going to say exit this editing box, and I'm going to get this back, and I'm going to draw now field to finish. So you can limit your range of points. We're going to take all the points. You can choose to draw just the points or the lines or symbols, 3D faces if your coding creates any of that stuff, or all. We want them all. Different ways to limit, different layering names. You can put prefixes, you can put point groups and stuff on these different names, et cetera, et cetera. Now, the other option here is to erase any existing field to finish entities. So when you go back and do it again, you don't have to erase by layer and do all that cleanup. You just have it pre-erase it, erase in the range. So if you set this to a subset, it would only erase those particular ones. This preview only is sort of worthless because what it does, I'll show you. I'm going to go ahead and check it on and choose OK. So there it is. It draws it as a preview. And I say, oh, okay, well, I see what's going on. Well, let me zoom down here and see what this is. As soon as you, well, no. Well, how about that? That's that's resolved. It used to be as soon as you did that as preview only and you zoomed in to take a look at something, those things disappeared, okay, because they were just temporary graphics. They still are. Notice if I select it, I look at my properties, nothing is selected. Okay, so finally, when it comes back around when you're done, You have to hit enter to continue, and then it comes back. And so preview only. So now everything's gone away. I do zoom extents and nothing's in my file now. So let's go back to draw field to finish. And this time, instead of preview only, I'm going to have it draw. So I'm just going to say, okay, and it's going to draw things permanently. And there they are, just like you saw it before. And you see a couple of things have happened. Let's go to our inquiry menu and turn on our drawing inspector. And, oh, sorry, that's my layer inspector. Let's turn on our drawing inspector. And let's say that we want to look at the layer name. Oh, let's look at the elevations, I guess. I don't need this stuff on here. That's just layer name and elevation. So now when I look at that and if I hover the mouse, I see, oh, okay, there's a fence line. So if I hover over that, I see that's a layer called fence, and it's drawn at 0 elevation. Here's a symbol, or actually a letter, X, same deal. And I look at these other points and I just see a bunch of standard points with the standard default symbol, point number, elevation, description. I look up here and I say, okay, well, there's a little square shown for my concrete monument. I hover over here, I've got an EOP. That's a layer called edge of pavement. And I see that it has an elevation of 502.344. And if I walk down that list, you see that elevation keeps changing. So I know that that's a 3D polyline. I look at this coming around this particular point, there's a symbol, and it's on a layer called traverse. So those are my hub points, I would imagine. It's on a layer called points. Now, if I were to double click point 48 and it's going to bring up the point editor, you're going to see something right here. Notice in the drawing, it does not show a description. It still has a description in the coordinate file called HUB, but there's nothing in the drawing. Okay, look at my symbol. There's the symbol it's using. And that's a hub. That's my traverse control, my traverse hub. So it had redefined the behavior of that point to make sure that it put it on a particular layer using a symbol, but turned off the description. Now I've got right here, if I look at this and double click that, you see it's not an actual point. It's just a piece of text. And it has, it's 498.23. And you can see there, it's just text that you can edit. And there's also a little symbol shown right there. It also has a point, but it's not, I don't think if I double click it, see, it's not letting me, yeah, it's not letting me actually edit that as a point, because the coding said, don't draw the point, draw a piece of text and put the decimal point at the location of the point. And that's sort of the way some spot elevations are drawn. All right. A couple of other things. I see a 0.8 here, 501, 0.1, whatever that is. Let's, if I double click that one, that's point number 8, IPFL, elevation 501.97. And it's in here twice. So there was the first time with the no description in the drawing. The second time it was drawn, it put an IP into the drawing, but its full description is IPFL, FL meaning fence line. Same thing if I come back here to my point number 1, if I double click that guy, I see that it has a description in the coordinate file of FL, meaning it's part of the fence line. And it also has CM for concrete monument, and it has a slash parentheses 4-inch DIAM close parentheses, which means to tag that on to whatever description the concrete monument said to use. And if I look up here, the drawing description is only that little bit, which tells me that the concrete monument description in the code said don't draw a description in the drawing, just add on whatever might follow it with that special code. All right, so that's what we're looking at as being part of this drawing. Now, I've got a bunch of other things that are not coded, like this UP, that's the utility pole. If I double click that, I see just basically has the same. And by the way, you can do these edits if you want to make them non-surface. If you're building a terrain model, you can, even though they have elevation, maybe you shoot the top of a fire hydrant. You don't want that to be part of your surface. You can set those to be non-surface. You can also set that as a code in the code table. Okay, so let's go back now and see what else we can clean up. We also have a bunch of things here. And we look at these PV points. We've got, looks like starting at 27, 28, 29, 30, 31 through 2, 33, 34, 35, 6, but they're not connected. Okay, so they're all just floating out there because that was one of the new codes that we haven't built yet. EP, on the other hand, again, turns the description off, but it has a code that tells it to draw this line. And if I look at this, if I spin this thing up here in 3D, I can see that, you know, the fence was drawn as 2D, the traverse lines were 2D, and this line for this building was drawn as 2D. However, this one for the shed was 3D. So that building line went right here between 18 and 19. All right. So one of the things that you might want to consider doing with field to finish, like here's a code that said, draw this, and you look at the points. This point 46 has a PC that's to start your curve. And all these other points are just points along a curve until you get to the PT. And there's that point there. And so the code says draw a 3D line but along those points. Well, 3D line or 3D line work along an arc, there's no such thing as a 3D, you know, with changing elevation as a true circular arc. You notice it approximates the arc by building these individual little segments. And remember, each one of those points will be a point in the triangle as well. So one of the things that you might want to consider when you're doing things like this, that if you need to make from this map a label maybe that points to that arc, and you want to show it to be of a certain radius. So it needs to be true radius, you know, true arc geometry. So you need not only the 3D line, but you need the 2D version of that, which will keep the arc instead of courting it. Then that way you can freeze off the 3D edges and keep the 2D edge so you can label things like the radius value and such like that, okay? So if we take a look up here at our fence line, for instance, if I just do like this, I'm selecting these things, I see they're pieces of text. It's just text drawn on top of a line, all right? So that doesn't help me. If I needed to tweak this and do something with it, you know, that's kind of stupid, right? So it doesn't really help me out. That's just one potential way of coding in these lines. So we'll fix that and we'll use an actual line type that will set that up. So one of the things I want to do first is I'm going to check two system variables. One of them is called MSLT scale, which means model space LT scale. And I want that to be on. Right now it's off, it's 0, so I'm going to make it 1. And then I'm going to check the overall global LT scale, and that's set to my current drawing scale of 20, but I'm going to set that down to 1. And the reason I do that So instead of using just the Carlson coded lines, I want to use some AutoCAD coded lines potentially and use them to set singular line styles and they will show up. All right. So if I were to say, look at this line here, I see that its line type over here in my properties is continuous. And it's on layer fence, but it's a continuous line type. So we're going to actually use that as we want a fence line type to be available for us. So the symbols, the X's are all included with it. Okay, so now what do we have? Let's go back to survey, field to finish, and we're going to be visiting this several times here. And if you look at a couple of things here, there's this additional draw options. And these are just some additional things you might tell it that you want to draw or not to draw. And you can use prefixes and suffix based on code. That's in the code definition. If it says to use a prefix or suffix, and that's for this elevation label, like you could put a suffix on the elevation of, you know, a foot symbol and then like AMSL for above mean sea level, something along those lines. But we're not going to deal with any of those here. Locate the points on a real Z. Yes. Locate line work on a real Z. Again, by code. So if our code tells it to, we will. If it doesn't, we'll leave it at 0. Now the PC to PT curve type. That is when it sees points that define a curve, like you saw around the edge of pavement. What kind of curves do you want to fit in between there? And there are 3 different fittings. One is the Bezier curve, which will actually hold all of those points and go exactly through those points. And sometimes, like you can have, 8 or 10 points along a curve. You start the curve and you finish the curve, and they might even define a shape that's like a letter S. You might have reverse curves and all that stuff in between. And if you're using Bezier curving, you don't have to start and stop curves and you don't have to try to figure out where the point of reverse curve is and all of that. You just, hey, here's where my curved feature starts. Here's some points along the way. Here's where it ends. And it's going to put that Bezier fit curve through those points. The sequential arcs, which is what we typically want when we're dealing with things that we want to be able to display the radius value of certain arcs, like edges of pavement and curb returns and things like that. That's going to take 3 points to define the arc. And so let's say if you had, 6 points in between the PC and the PT, it takes the first 3, makes an arc. It takes that last one that you just ended on in the next 2 and makes an arc out of those 3, and it just keeps making sequential arcs until it gets to the end. Now, it is possible to have a code that just says PC and another one that just says PT without a point in between. So when it does that, it needs an incoming point behind the point that starts the curve that will set the tangent direction. So it knows how to project out to the PI, and it will therefore then create a tangent curve from that PC point and go to the PT. Now, the only, that's a nice way of getting nice tangent geometry. The only problem is it might actually draw a curve that doesn't exactly hit where that curve might exist on the ground in real life, because not everything is always built exactly tangent, and you might not have exactly picked where the curve starts. So I would suggest when you are gathering points that you get the point that starts the curve, and you get at least 1 point along the curve before you get the point that ends the curve. And the more you get in between, the more you help to define the curve. Now, the other thing is, when you do that, you get a start point, a point along it, and an end point. indicated by the PC and the PT codes to start and stop. And it takes the 3, including the PC, and the next point, and then all the way up to it hits the PC, or the PT rather. But as it puts those all together, it can, let's say that the point you start with and the point along the curve and the point you end with, and then you go on down line for what's supposed to be along the tangent and you get another point. Well, that does not guarantee that that arc is going to be tangent to the incoming leg and the outgoing leg, okay? But if you see down below this little checkbox, this is adjust the PCPT for arcs to make them tangential. And you can give it a tolerance value. You can give it a distance that you're willing to move that point to, to sort of trim off the, adjust where the curve starts and stops so that it does make it become tangent. And if you're outside of that tolerance, it just leaves it as non-tangent. So that's one way to do it. Now, the other way to do it is that best fit. And what it does there is that it will make a tangent curve between, or no, I'm sorry, it won't be tangent, but it takes a curve that starts exactly where the PC point is and exactly where the PT point is where it will end. All of the points in between those that you survey and say that they're that same code, and they're basically on the curve because you've bracketed them with a PC and a PT point, then it will look at all those points and it will do a statistical analysis of that and come up with a single arc that best fits all of those points. So they would obviously not necessarily go through all the points the way the Bezier curves do and the way the sequential arcs do. The sequential arcs do uses 3-point arcs, so that's, a good way to generate the arcs, but it doesn't guarantee tangency. The best fit will put a single arc through a whole bunch of points, so, you decide how that needs to be collected. And it's sort of hard to keep that coordinated between field crews, let them know when and where they need to decide, what to do and whether to flag that up to tell the guys in the office to mark it. So you can, use these as sort of additional nuanced interpretations of these codes. So I'm going to leave this as sequential arcs, and maybe even leave the adjust on, and you'll see that I'm probably outside that tolerance value when we get through here. Now you can create point groups. You can do them by codes if you want, ignoring the suffixes. You can also define a group for a point based on the code definition, so you could do it that way as well. You can put different, prefix for a group name, all kinds of management that you can do on these groupings. Point notes, if you had notes you want to create as well. You can, when you are running this, you can, when it says allow 3D arcs, it doesn't mean an arc with variable elevation. It means allow arcs that have elevation, but they still have to be planar. They have to be the same elevation. Otherwise, if that's not on there, it will still chord horizontal arcs, even if they have a non-zero elevation. So you can, take that as for what it's worth. Let's see, set levels by codes, pause on undefined codes, and auto zoom extents. So if you have any undefined codes, if you have this switched on here, it will stop and tell you that, and you can choose to go on or stop where you are. All right, so that's my little additional draw options. It sets some real finesse on that. You've got, again, now it's built in as part of this. You can actually go ahead and go straight into triangulate and contour and build a surface out of all this stuff. I generally don't do that. I wait and see, make sure everything looks good before I build my surfaces, but it can all be done together. Now let's edit these codes and see what we've got. Now we want to, So we got a bunch of things here. I've got nothing undecided. Here's my set control. Now here's my concrete monument. Now you can get a bunch of information here in this window. You can see some of these full descriptions. And if you just, let's look at this CM. I know I've got a code in my file. If I edit my points, there's my point editor, and I see that I've got this point up here with a CM. So that's a code that I have. It's in my set control, concrete monument. I choose that edit, and here's what it's doing. Uses the code CM. This full name is just the label that it's going to show up in this code list here that I see for myself. That helps me to realize what it is. The description right now is blank. Now, if you change that to say, let's call that concmon, okay? So it's going to write out that word concmon. It tells you a layer that's going to go on. And notice there's a main layer, there's a distinct point layer, and there's a dual 3D polyline layer. So these are all, this is the main layer where the point itself gets stored. And the line work, if you come down here at the bottom and if you are drawing lines between those points, that main layer is the layer those lines live on. And the point as well, unless you also say, I want a distinct point layer. So you may, you see what it does is it offers to suffix the monument layer with points. So you can control the points to be on a separate layer so you can freeze them separately from the drawn line work if you want. And we'll go ahead and maybe do that. It's up to however you want to do it. But you see down here, the entity type, I'm drawing points only. I'm not drawing lines between concrete monuments. And that's all well and good. Let's see, we're going to separate, if I want separate attribute layers for the points and the symbols or both or none, let's just leave it at none for now. An attribute layout ID, here's your preview. I'm going to change that one to a 2, for instance, so they're all lined up. Again, you can type a point group if you wanted to. There's your attribute size scalar. I'm going to make that a 10th instead of 800ths. Or I'm sorry, not, it's my attribute size scalar, not my symbol scalar. All right. So now here's down at the bottom, the choice, again, points only. And I'm going to locate points on the real z-axis. And now and there's where you can also set for non-surface. But my feature type, there's your topo, tree, pipe, or utility. So topo is your typical non-categorized type of feature. If you had a tree or a pipe or a utility type survey, there's other places to set that stuff up, like right in here, utility setup, tree setup, pipe setup. So all kinds of different rules. Look at that in your advanced guidebook. All right, so now, so if I set it here, and I look at these other tabs at the top, I've got a symbol. It's going to use that SPT6, the square. And again, you can just click on the picture and it will take you to the, choose that SPT6. You can have it rotate, if it's drawing lines, you can have it rotate to match the line. You can give it a specific rotation, give it a symbol size scalar. That's where I wanted to set my 0.10, et cetera, et cetera. Any custom attributes you want to add with that symbol points. If you have a multi-point symbol, that's in that book. You saw the description of a little police car where they had the 3 points. And you can even draw a second symbol if you wanted, in addition, and where that goes. And then under line type, and again, it's defined right now as just continuous or even by layer or whatever you want it to be. But this will have no effect because under general, we're only drawing points. All right, so now we're going to say okay to that. So now CM will draw that symbol, and it will be a little bigger. I'm going to, be a little bit bigger than that one was, and it's going to write out CONC space MON. So I'm going to hit save, hit exit and say okay, let it redraw. Let's zoom in there and take a look at that particular one. So there it says Conchmon 4-inch DIAM. Wow. First of all, it shows me as a square symbol. A square doesn't have a diameter, so that's one thing. But here's where this 4-inch DIAM comes from. If you double click the point and look at the point itself, its description was FL, which made it part of this fence line. That's why it drew the fence line off to the side. And CM, so it looked up the CM code, which said to draw in the drawing description, Conchmon. But then it also has this little slash and parentheses 4-inch DIAM close parentheses. What that means is this. Let's go back to our field to finish. Let me turn off my drawing inspector. And we'll go back to field to finish. We're going to edit the codes and we're going to look at code table settings down here. Actually, not the settings, but special codes. And we've got a bunch of characters that we can add to these codes, one of which is right here, this character append description. And that means when it sees a slash, it's going to take what follows the slash and append it to the description that we told it to use back here when we edited the code. Okay. That's why the first time it didn't say Conchmon, it just said 4-inch diameter by itself because it added that to nothing. Now you can use character prefixes, character suffixes. You can use code prefixes and suffixes. So these are slightly different than the actual description itself. It's actually going to change it's going to modify the code itself. Here you've got it where you could put in an NE for no elevation, so you can capture the point and it sets the elevation to 0, or you could say NOS for a non-surface. Now again, these are all whatever you want them to be. You can put that as NS instead of NOS. So, there's a no elevation, a yes elevation, a non-surface if you want, a ZO, which means it's elevation only. I don't know exactly what benefit that would be for you, but it's there. This block below it has to do with some rotations of those, and you can assign, photos. And when you do a 2-point circle, are you defining the diameter or are you defining the radius? If you're doing a third rectangle point, is that to be the corner or are you just defining the amount of offset? So if you shoot, let's say a rectangular inlet, shoot one corner, you shoot the head corner, and then you go and get the back corner. If you say that is a corner, then it's going to square that off and use those as corner points. But you could say just get the first point, the next point, say this whole dialog box is that I could get this point here, and if I get this point back here on the back edge, if I'm telling it I'm using that as an offset instead of a corner, then instead of drawing this corner to corner and me having to find the corner and then completing the rectangle, it's going to draw this here, treat this other point as an offset and just offset this edge through that point and then connect the ends between. So that's actually a new feature. It used to be it's always required the corner or it required a numeric value for the offset distance. Okay. Now over here, and this is, oh, excuse me, this is something that's easy to get out of sync. These begin codes and end codes, and this is where we start and stop linear coding features. ST for start, and then we usually say, you'll see this a lot of times as end, or you'll see, you saw that as EL, that was end line work. Sometimes you'll see a BEG and STOP, whatever they want to be. What you have to do is make sure when you are coding out in the field that the field data collector, the code list in the field is going to match these same special codes because they can be different and you want them to be the same. So if he uses BEG and you're looking for ST, then, it won't know to process. Same thing as PC and PT for point of curve and point of tangent. You can, whatever you choose to make them, you can make them. CLO means if you are drawing a linear feature and you get around to, the last point you choose, you could give a close command, just like drawing a polyline in the drawing. So you don't have to go back and reshoot the first point. You just give a close command on that last point. Okay. Rectangle, that's the special code that handles things that we talked about down here for the corner or offset. So you can choose to shoot just 2 or 3 of the points and give it a rectangle code on the last point, and it will close it off. Here's your offsets: horizontal, offset vertical, offset left, offset both. Your only offset, so it doesn't draw the line actually between the points, it only does the offsets. If you're drawing a circular feature, you can get just 2 points and define it as a circle. This one is very handy, JPN, that means join to point number. So if you don't have a particular code or a line, but you do need to draw a line between, say, the corner of a house and a telephone pole, you could do that without having to have a separate code on the house corner that says, hey, this is also part of the power pole, because you don't want a pole there. You just want the line that goes over to the power pole, et cetera, et cetera. Jog codes are extend by distance. That's also one that we use quite a bit. This ramp code is relatively new. That's to be able to survey in sidewalk handicap ramps. And what I want to point you to, we don't have time to go through it all, but if you use the help button for this, there are some, here's some examples of different ways to code different things. Like there's your sequential arcs versus Bezier fits and things like that. So, but this help system is really extensive. You can see how far it runs through stuff, and it really explains all these things in a lot of detail. So we were just then talking about those special codes. Let's say that ramp. So if I look for ramp, that's actually, that's actually not part of that field to finish, but what I want to do it in is here under draw field to finish. They turn these search highlights on. And now see if I can find it. I wanted to, if you should notice as I go past here, give me a yell. Right in here we go. All right, so now turn my search highlight off. Ah, crap, it moved me down. All right, so let's go down and find ramp again. There it is. So this is an actual code, and this is a special code that adjusts any of these 3D polylines that you might be using for curb features, and it will create this entire structure. So it looks for these parallel 3D polylines for the bottom of the curb, the top of the curb, and the back of the curb. So, this bottom face, the top, and the back. And it's centered at the point that has the ramp code. So if you were to shoot a point right here and put a ramp code, special code at the end of it, so the dimensions then follow the code in the order of the width, which is, I guess, this, the depth, and which is front to back here, I think, and then the taper, which is this distance here. For example, a description of BC ramp 321 uses BC for the bottom of the curb, then ramp for the special code, and it has a 3-foot width, a 2-foot depth, and 1 for the side taper. So that would be this distance right here. So a foot here, It's 2 feet here, and it's 3 feet across the face here. So with one point, you can define all that if it's regularly constructed, and you can make those, you can figure out what these distances are out in the field. So you just shoot the one point, you measure those off or estimate them, and it will create that actually in the drawing from that one point. So what I'm getting to is on this particular system, this help system, you're going to be able to learn a lot of all of those nuances, plus those 2 guides that you've got in the class data stuff. All right, so use them, but make sure that you have a beginning. I'm going to actually use BEG and END for my begin and end, and I'll say okay. And so those were my special codes. Now I've got some code table settings. I'm going to use Carlson coding methods and my split multiple codes. And that's a multiple code like that, CMFL. That's a multiple codes, fence line, concrete monument. So I want to split those codes so it recognizes them as independent, as if I had got 2 points. If you say none, then it tries to find a code that is FL space CM. So in this case, it won't work. So I'm going to leave these set to all. And I'm going to use multiple points to process line work and points, line work only, or line work and symbols. So without drawing the points, it will still put the symbol there. So if I'm going to do line work and points, and that's why you saw on that fence corner, there was actually 2 versions of point number 8 drawn into the drawing. One that had no description, the other one that did. So it drew it in there twice. If I just said line work and symbols, then it would have suppressed the other one, okay? All of these different things, draw field codes without a suffix as points only if you choose. And what that means is if you have a code that tells it to draw a line, let's say EP for edge of pavement, draw the line, edge of pavement. But if I have that switch on, then if I choose to get a point that's edge of pavement, but I don't want it to be drawing to the next edge of pavement, I would leave the suffix off, but I would define all of my edges of pavements as an EP1. The next edge of pavement I would get would be an EP2, EP3, and I can go back and reuse them after I've put a stop code on the first one before. I can go back and reuse EP1 if I've stopped it previously, etc. So you got all of those kind of controls that you can do with these. So I'm not going to turn that on though right now. And let's see, interpolate no elevation points. So if you're shooting something for 3D polylines and it doesn't have an elevation in the point that you get, it can interpolate through it. That's just a little safety catch. Right here's something. These maximum delta height and maximum length for line work. Let's say, and I had this situation happen in a crew down in Texas. They were down in outside of Houston, and over in Sealy, as it turns out, where they first made the Sealy mattresses, and they were doing a long roadway widening for Route 36, and they were going along and picking up driveway culverts. So they would get the end of the culvert, go the other edge of the driveway, and get the other culvert. Well, they didn't have start and stop codes for those. They would, and so it would connect all of them. Well, you might have a house sitting somewhere, they had a 20-foot long culvert, and the next house would have been, it was half a mile down the road, maybe even on the other side of the road. And so it would draw a line connecting from the previous culvert all the way up to this new culvert that's, a half mile long and goes across the road, but you can't really see it. You can't even tell it's slanted because if you're seeing the entire length of a half mile, you're not seeing a 30-foot wide road. So this is a little safety catch that says if you go over whatever number you put here, if you go that far away from the last one, even if you haven't ended that line work, it's going to start it over again. It's not going to connect it. Same thing if it's a height. So if you're getting something and you go way up on, top of a mesa, but you're within the horizontal distance, but you're too far away vertically, it won't connect things. All right. So that's basically, and here's your default distinct point layer that you can put here. And there's that little suffix underscore PNTS. That's what you saw in that code for a CM. So just some ways of doing it. Oh, also on this code table settings, you see this import column. These are where you can bring in these different codes from different companies. There's your Trimble codes, for instance. You can also export codes to then be used in a Surf PC or Surf CE data collector using Carlson field work. You can, I guess the rest of those are imports. That's really the only export that you can do there. Okay. All right, so that's my settings. I've looked at my special codes. Now let's look at my points. I'm going to edit my points and I'm going to get a sense of what's going on here. And here's what's happening. I have, I see point 1. It is an FLCM and it says 4-inch diameter. So it's going to call it a concrete monument, 4-inch diameter concrete monument. I'm going to actually just make that 4-inch because it's not really a diameter if I'm using a square. Fence line, that's my FL. All right, I've got a hub, that's my traverse. I've got utility pole, shed, shed, shed. Now notice that shed, 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 that's 0.5, 6, and 7. And if you recall, I can't scroll over there to see it. I can in my IntelliCAD version, I can zoom in and out. But you saw two edges of the shed. So 0.5 connected to 0.6 connected to 0.7 because the shed code said draw a line. Okay. So if you, we'll keep that in mind. And there's that rectangle special code, remember. Okay. There's my IP. That's an iron pin. And an FL is my fence line. There's another iron pin. 18D/oak. So it's an 18-inch diameter oak tree, a 24-inch diameter oak tree. So that's the way they coded that one. And then they've got a 12P and an 8P. That's a 12-inch pine and an 8-inch pine. Really two different ways of coding the trees. They weren't consistent with it, but it's just to show you that you can have, any number of ways that you can do these, just define them and be consistent across them. Another iron pin, there's a point on line, another utility pole, there's a building, so just 2 points, another tree, another traverse, another light pole. Then I've got these X's. These are just ground shots, spot elevations. Then PV, which is my pavement. So I start with this 0.27. It starts at PV, goes to 28, and there you see that PC, where it starts the PC and goes 3 points, and then it has another PC. Now remember, when we saw those codes, we saw things like start and stop, and we saw things like PC and PT. The field to finish system will allow you to not use start and stop, or if you do start one without the start code and then you give an end code at the last point, or if you do a start code on the next point of the other unconnected feature of the same code, it recognizes those and lets you get away with not using them. I personally want people to get in the habit of always using them. So I'm going to go to this PV point and I'm going to type that BEG. Remember that was set to begin. And I'm going to set my PV PC. And again, like begin and end, the curve codes allow you to start a curve with a PC and it doesn't make you use a PT. So it sees this next PC, so it knows that this curve ended. And what it does, if it doesn't see a PT, it just assumes 3 points for the curve and then goes on. Well, then the next point was the start of another curve, so 3 points. So I'm going to actually come in here and put in my PTs just so I'm keeping good practice. Now here's a PVPC, and you see how it went 1, 2, 3 into his PC. Well, what would happen is that these 3 points here would be a curve. Then it would be tangent, 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 till it gets to another PC. Oh, actually, that's an edge of pavement, sorry. So these 3 points would be a curve here, this one to here, but then this would be back to the tangent. So I'm going to go 1, 2, 3. I'm going to make that a PT, and then I'm going to come to my last PV point, which is 44. And if I say end here, that will stop that, and I could start another PV somewhere else, and it would not connect it to this one, okay? So let's see what happens with this. If I save and exit my edits, save changes, yep, I'll save the change for that. And now those PVPTs, the PCPTs were for the pavement and the edge of pavement. So my EP, you can see if I go to my road features and choose edit, down here I'm saying use it, don't put a description, go to the symbol. I'm going to say don't use a point. I'm going to take the point out, but I will put that on the EOP. I'm going to make a distinct point layer, and I'm going to not just draw a 3D polyline, I'm going to draw both 3D and 2D. And I'm going to put the dual 3D on this layer, just called 3D-BKLN-S. So my 3D break lines. And so now it's going to draw a 3D polyline and a 2D polyline between all of my EP points, because I would use those to create my topography. All right, so I'm going to say okay for that one. And I'm going to also look at PV. That was my driveway pavement. So I would come here. It has a description. I'm going to also take that out. I'm going to take my symbol off. Again, no symbol. And I'm going to have it draw also 3D and 2D polylines so that I can use them and label them. And I'm going to set my attribute scalar to 0.08. Nothing necessary there. A distinct point layer. I'm going to put this actually on a layer called v-site-drive. Okay, so even if I haven't created the layer, it will build it for me. So I'll put that on the separate, and I'll put this also on 3D-BKLNS or 3D break lines. And I'll say, okay, now I haven't done anything with the line types yet, so that's good for those. Let's look at fences and walls, and let's fix that fence line. So it's now going to have no description. It'll have a code there. The main layer goes on fence, a distinct point layer. If I want a 2D polyline, I'm going to again put that on underscore PNTS if I wanted it done that way. But what I need to look next is my symbol, no symbol, line type. And right now you see this, it looks like a fence line, but it's this fence 2 underscore E, which means it's built out of separate entities, the lines and the text. So I'm going to just hit my set line type, and I'm going to get this line type picker. And even all of the ones that say CAD, these are ones that are defined in my list of line types in my CAD system. I probably don't have a fence line showing there. I go from D to H, I don't. If I see the ones that say E, then it's going to assemble them out of these different pieces and leave them separate. So I'm going to scroll down past those, and I'm going to get the ones that say continuous next to them. I'm going to see if I can find some fences instead of entity that would be with these continuous. May not have, I might have to add some here. I've got a fence. There we go with the C's. So that's a fence continuous, and I look at it down, there's electric, there's fault, there's fence, BC right here, or I can say fence CC, and there's fence S. See, I think I like that one, so it doesn't put a gap in it. And then I can come down here and define the spacing scalar. So I'm going to go every 1.25 inches, and my sample size, I'm just going to make a 0.08 and say, okay. So it's now going to actually create this on the fly and build it for me. I'll say, okay, I'll save that, and I'll save the code table. I'll exit, and then I'll hit the OK button to erase everything and redraw everything. So now you see this symbol, this line work now is a complete line, by itself, not individual text. My description for my concrete monument just says 4 inches. That's fine. I've got my IP. Well, the IP, now notice that's a plus mark. So let's focus on that one real quick, and we will. We're going to redo our field to finish, and we're going to go to edit codes, and we're going to look at set control IP, and we're going to call that one, say, iron pin, and it could be found or set, whatever. And I'm going to change that symbol to be, my points wiped out my SPT4. Say okay and save, exit, okay, and then you'll see the difference right there. Now I've got, and you see that I'm going to turn my frames off, or wipe out frame rather off. There we go. So you don't see that, but you notice where the actual end of that line is the center of that symbol. Okay. And then of course you can, freeze on and off the various aspects of that. You can, that was that X code. I'll just show you where that one is. We need to move ahead though, so we don't miss out on our survey stuff. Here is that where it coded. And now you see what made the arc. And if I freeze temporarily that 3D layer, this is now my 2D, and there you can see that's an actual true arc. It's not all those different, okay? So that's there. Now, what can I have put right here? I started at 27, went around 28, blah, blah, blah. I got all these arcs. Get around to 43, I get to 44. What can I have put on 44? If I double click 44, I said that was the end of that feature, which it ended it. I could have also put on there.
Join 27.
Yeah, you could say JPN 27, or because I'm drawing that as a figure and I want it to be a closed boundary, if I put CLO on it, okay, and then reprocess it. So that's a close. That's one of those special codes for that. So now when I reprocess, you'll see that actually close back to the start. Join to point number would work. All right, here's another one, 5, 6 to 7. And if I go to 7, if I put a close on that, it would draw a diagonal line there. So I don't want to put that one. I'm going to use this other special code, RECT. Now, nothing's changing yet because I have to reprocess it. Now, I can do that, though. Under survey, this field to finish inspector, and I'll get this little list up here. And I'm going to come down here and find these particular codes. And I'm going to come down here and find my shed code. And I see that's points 5 to 7. And I'm going to come down here to 5 to 7. And then I'm going to select that instance. I'm going to choose 7. And I see it's shed rect. So if let me not isolate, let's just leave it there. So shed rectangle, if I say apply, All right, so let's see. Let me take that off and apply there, and then if I put the code in here and choose apply, it's going to do that command where it takes those two edges, gives a rectangle, so it completes the rectangle. Okay. Now the same thing where I had that building code, which was BLD, and let's zoom to that area. And now, so that's a house, it's part of a house, but I only shoot the two edges. So in my instances of point 18 and 19, I could go to 19. And if I said rectangle here, I need to put a distance. So 18 went to 19. My distance, if I wanted to go up to the upper part of the screen, that's to the left. So I would say negative, let's say 8 feet. And if I apply that, boom, there it goes. And so that would then create that as a structure there. Now, that actually is another code. That could be a jog code. So I could say jog 10, negative 10, positive 10, negative 20, negative 30, I think, not sure. I didn't add up the distances, but you can see, okay, so it went up here, it jogged 10. Okay, so that first jog I should have made negative 10. And actually, no, I wanted to make that straight 10. If I apply that. All right, so there it went. Out 10, turn 10, turn 10, 20, came back here instead of 30. That's probably, I don't know, call it 40. You know, we could go and look at it, and there it is. So that could be the actual house itself, you know, that maybe I've got trees in the way and I can't occupy those corners. I can't see them. I can get to one corner, I can get a part of the wall, and then I could just, you know, send my, you know, the rodman around with a tape measure and come up with the dimensions of the building, and I could apply those accordingly. Okay, so I will go next to my pavement, and I've got this last one here, which was a CLO. If I go back to apply, leave it alone. And now let's put the CLO back on it. So now this has the exact same effect as if I were doing field to finish after editing the points. Okay, so that took care of that. And I've got this point 19, for instance, has all of these jog codes with it. Here's an example up here at this shed. I've got a utility pole. So I might put with shed on number 7, I might also put a JPN 17. So now I have to redraw field to finish. That utility pole, let's go ahead and fix that while we're at it. UP is going to be, you know, some kind of like a power pole. Let's say, okay, save, exit, okay. And now you'll see it drew in the line that is defined by shed up to utility pole. However, you could just as easily have done this. And if we go back to draw field to finish, that was 17. So I'm going to look at my codes, that utility pole again, and I'm going to have it draw a 2D polyline. And it's going to be on the layer of utility, and it's going to be that symbol. I'm going to rotate it to the line forward. And then the line type I'm going to set, I'm going to come down here and look for these continuous, look for E for electric. There's an electric. Electric 2. That's the one I want. About 1 1/4, and that should work. Say okay, save, and exit. I'll also edit my points. So point 17 is a utility point. Now, I could say JPN 7, except I didn't spell it right. All right, now here's what happens. When I use that code, that particular JPN code, it will take the line type from the code that it was using. And that's why the first time I did it, it used the red code. The second time I did it, it used this. And it actually, I've got a bad choice on that. So that UP, I might actually say in my symbol, rotate, there's symbol, that's fine, set symbol. My line type, it didn't, yeah, I didn't update that. So every 1 1/4, there we go. Set that, save, exit, say okay. So there's now my electric line. And the symbol, rotates to line up with the line going forward. So this one's rotated to that. So you can see all that stuff. And it used this same line type to connect back. In fact, it's just a little bit too, yeah, the line type scale was such that the E didn't show. So you can set that accordingly. But so that's how, you can do this bit, and you can see now that I've got, for instance, down here, 2 actual lines. I've got a 3D line and I've got this single white edge because I wanted that to be an actual arc. Let's see. There we go. This is the arc. That's the 2D arc. Up here was that 3D break line that has all those chorded segments, okay, for when I'm going to build a train model from it. All right. So that's sort of this from drinking out of a fire hose. A couple of things that you've got going on. If you were to build this as a train model, you're going to get some crossing break lines right here. So what should have happened is when they're doing this edge of pavement, there's a 45 EP, there's a 46 EP PC, comes on around up here and does 50, should actually be the PT, it is, okay. So what I should have done if I were surveying this correctly in the field is as I'm coming up this road, I should have gotten that one corner point, okay? And so instead of tracing this driveway all the way around, I might, stop this at point 33, put an end code and then put a start code and finish this back around and interrupt that closing face. Or I would, and that would really be what I would do is I would choose this point, call it EP, and then call it PV begin, and then let this come all the way around and come down here and call this one PV space or PV end, and then space EP, so that it doesn't draw the driveway closing point, but it connects this edge of pavement all the way across. So this is not, very well done. There's my iron pin. You can see this iron pin up here in the front. So that's just a way to, it's, and you can sign trees and different things. And I'm going to leave that to your own discovery. And you can go through, I think we talk about a bunch of that, not really in total depth. But here's an example of what happens is that, or what can happen, is I had changed these codes to do this kind of, sorry, this kind of treatment. I need to get, there we go. So for instance, those spot shots, I had it, instead of the way they had it, I had it use a attribute ID of 3, which turned the elevations up at an angle. I froze off all the point numbers and descriptions. I put in my property lines. I think in recent other times, I've actually changed that to be a PL labeled line. Connected my sewers through the manholes. I've shot, here's my edge of pavement, but I made it a template. So it actually has these edges instead of just that one edge. It goes out 12 feet and up 2%, makes the center line, goes down, and you can do that as far into the ridiculous as you want. There's those tree symbols. You can see they're created independently as well. Even coding in the hatching inside of this feature. There's my little building with the jog codes. There's my shed with that closing point. There's no joined point number there, but you can see the idea. And then all of that was used and made into a terrain model so that it could be have the contours generated. Now, let me show you another place where this is available if you want to go through in this particular set of data. If you look on the Help menu under Carlson Help in the Contents tab, on the Tutorials button at the bottom is this one here that says Field to Finish for faster drafting, and that's going to step you through this same data set, okay, with a little more patience and a little more time. We just don't have enough hours in the days to get through that and everything else that we need. But that's going to show you that, and it's actually going to go through the whole steps of creating this, title block and map, the whole business, okay? So we're going to put a bookmark in that right there. We're going to take our little break. Let's come back at a quarter till. That'll be a little bit shy of our 15 minutes, just 3 minutes shy. But I want to get to these deed tools, and that will pretty much round us out today. I don't want to hold you guys late. It's the weekend. I know, getting a lot of this stuff blown at you like a fire hydrant, it's going to be kind of tough. So step through the rest of that at your leisure. Also look at those 2 documents in your data set. That's also in those files for you to practice this field to finish to get a little more depth in this. I did want to, when we do come back, I will show you one last thing to use field to finish to help with, even if it's not a specifically, let's draw the map kind of thing, okay? So we'll come back at a quarter till. If anybody's got any questions, I will take those now. Okay, so I'll see everybody at a quarter till, and then we'll wrap it up. Fly through the rest of this. Now, here's a great example of being able to use field to finish, even if you don't use it as part of that daily workflow, to really help automate bringing your field data in from the field and starting off your finished design work. Let's go ahead and start a new drawing, and we're going to bring in a coordinate. We're going to assign a coordinate file called Mantopo. This is on page 70 of your guide. So we're going to make a new drawing. So I'll close this one. And I'll make a new one. I'll set, make sure I'm in my folder. I'm going to call this one manual topo. 30 scales fine. I don't much care about much of any of the rest of that, and just set that along. Coordinate file, and I'm going to set to this one called man topo, and I see I've got 1 through 356 points. That's what I want. I'll open. I'm not going to do any import points from. I've got them already in there, so I'm going to say none and hit next. And there I go. I've got no points in my file. Nothing drawn in my drawing. I am going to do, oh no, nothing there yet. So now let's just go to see where our points are. Let's draw locate points. We're going to go to the points menu, just take our defaults, and let's just put it on PNGS and draw all. Then I do a zoom extents and I see I've got a bunch of points here. I see some descriptions, ground/shot for all of these types of ones. And then I see 17s, 18s, and 17s. Okay, so I really basically got, if I look at my edit points, I see that I've got a couple of these that have been coded into already to create these. There's a begin codes. And there's 17s and there's 18s, and you should see an 18 begin. There it is. There's a 17 end and join to another point number. 18 begins and it goes down to 18 where it ended again, but started a new 17. That's where that begin goes. You notice I didn't have an end code there. I could put one there. Just END. So I've got some things on here. I've got these ground/shot. So what I want to do is I want to actually edit or search rather and choose replace. And I'm going to find that ground/shot. I'm just going to replace this with GS for ground shot, just and then replace all. All right, so it took care of those. I just didn't want those slashes to get in the way of what we're doing here necessarily. All right, so I'm going to save and exit. And there you see their points are set accordingly. Now, let's triangulate and contour this data. And you notice there are no really inset areas, so I'm not going to get any of those outside triangles to have to worry about. I'm just going to do a real quick triangulate and contour. And I'm going to go to the triangulate tab, and I'm not even going to write the triangulation file. I'm just going to ignore zeros. I will erase all contours. No need to densify these. No, well, it won't hurt to leave it on. But I'm going to draw my contours, and I'll draw like 1 foot intervals here. That should be fine. No smoothing. Put your labels on if you want. Look at your selections. And I could have actually said to choose a coordinate file and not even had to draw them into my drawing, but I wanted to see where they were. I wanted you to see what they are as well. So now I've got a bunch of points. And I'm going to triangulate and contour, but instead of writing the file, I'm just going to have it draw the contours. So I'm going to say okay, and I'm going to select my data. Oops, sorry. I see what I missed doing. I'm getting in a hurry and I did not look at my line above. So let's triangulate and contour again. Let's uncheck this inclusion. We'll erase. Don't need that. Erase previous. Contours and contours on. Labels. Make sure selection is off. That's good. Triangulate. I'll say, okay, now it selects the points and stuff to triangulate. I'll do that. And now there's your contour lines. And you can see that's probably not what that's going to look like. And if you look at it over here, you see that same kind of wiggy-waggy looking stuff. Okay, but if I look at my data, let's just view my data in 3D and see if we can get a sense of what this really should look like. So if I zoom this thing up and I spin it around, and if I look down these edges where those weird contours were, let me give a little vertical exaggeration. You can start to see what looks like, and indeed is, little ditch structures along the sides. See how that shows up there? So I'll put that back to 1 and exit this out. So when I did those contours before, it doesn't look much like a ditch. And in fact, if I'd saved that and looked at that as a surface file, you would see all kinds of little stair-steppy, blocky looking things. So the key is, if I turn these back off again, if I look over here at some of these points, I've got this 17 to 18 to 18 to 17 back up to the ground. So here's ground, 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 and then 17, 18, 18, 17, 18. So, or back up to ground. So it looks like somebody has gone to the effort of collecting all these 17s as top of bank and 18 as the bottom of bank. And we need some break lines in there. Now we could go through here and draw a 3D polyline, snap, 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 snap. You could do that. It won't take you long on this particular file, but on a large site it would. So let's use field to finish to do this for us. So let's go to survey, draw field to finish. And we're going to import the codes, and this is going to be a code table by point descriptions. So that's what we're going to use, and we'll set this code table to be on the fly, let's call it. Okay, so that was by that, and we've got that code table on the fly. And let's edit the codes. And if we look at all our codes, we've got 17, 18, and GS. GS are our ground shots. We're not going to do anything with those. But 17s and 18s, we're going to connect with 3D polylines because they're going to define those edges. So I'm just going to go to 17, come down here and say 3D polyline. 18, I'm going to say 3D polyline. And that's all I'm going to do. Save and exit. And now I'm going to draw a field to finish. Okay, so there you see the lines got drawn. And so now if I look at that before I were to build a surface, let's again go back to this 3-time vertical. Now you can see, indeed, that should really even out that resulting triangulation. Okay, so let's go to, now I'll turn these back on and you'll see them go away when I rerun triangulate and contour, because I'm erasing these other entities. And again, I'm just going to draw the contour. I'm going to say, okay. I'm going to select all of this data. And now look at the resulting contours, and let me freeze off the actual break lines that I used. That was the bottom and top of the ditch. Okay, so now when we look at that in our 3D, and you can see the actual contour lines themselves. In fact, let's turn off the points. Oh, crap. Can't get back to there. There we go. So now you can see how it's defined those ditches down those edges, and that is what we were after. Okay, so that quickly we're able to generate those. Now you might have some mess up in here that you need to straighten out, but chances are, maybe we're not even working back here. But so you can see in here, there's some goofy looking resulting contours here because of that. Maybe if we had a boundary on it, we could fix that a little bit better. What is this? This is my index. What is this? Oh, let me freeze that layer. I still got that layer on. Let me freeze that layer. There we go. So now there's my resulting contour lines. Break lines are frozen. And all I did was notice that those had codes. And I've also got, some contour labels and such down here. And here's what I was showing you about that hide label under, or hide drawing under label. If I go to my surface menu and choose contour utilities, move the label along the contours. If I select that and then move it up, it'll just walk it up and put it wherever it needs to go in a more convenient place. Maybe you don't want it there in the middle or in that break point. And so it just rearranges it. And it's just cosmetic. Okay, so that should give you the idea of the power of using field to finish. Even if it's not something to generate stuff, you can use it very quickly to help you model this condition a whole lot nicer than if you just tried to build a surface from that. You saw that it built the surface, but it drew some goofy looking contours. A lot of people do that and they'll accept it because they didn't get an error. So use your eyes when you're doing this kind of work and make sure that you um, think your way through this stuff and double check this stuff. Always look at this stuff in 3D and that sort of thing. Okay. So let's now jump to our survey stuff. We're going to do another drawing and coordinate file, name of your choice. And we're going to load up. Well, let me explain these exercises here first. The first one we're going to skip. What this is meant to do is if you have a deed file, you can load in the text from a deed file. Maybe you've scanned them or you've got Word files or something. You can put the text into this deed reader. And if you have to build all these codes that will recognize like N's and S's and E's and W's and the word feet and the word thence and beginnings, and you set all that stuff up and it will actually read the deed and create the geometry right in the drawing. We're going to skip that on this exercise because it's really tricky. And the problem you have, let's say you go and do a bunch of courthouse research and you come back with, 25 deeds. Some deeds will be in the form of N space, number, degree symbol, number, minute symbol, number, second symbol, space, E. Others might write out the word north. Others might not use the spaces. Others might write out the word DEGREE instead of using the symbol. So they're never consistent enough to make this something you can really do on the fly. So it's there to show you that tool's there. So we're going to go to this next little exercise and we're going to enter a deed description, and we'll show you how we can use this and then use some tools to resolve those points with some found field points. So this is going to be the figure that we're going to code in, and this is on page 72 of your manual. I'm going to actually put this over on my other screen so I can see it while we do the coding. So we're going to make a new file. And this time we're going to hit set. I'm going to choose my folder, and I'm just going to call it deed processing. And we'll say next. Already, yeah. If you get that, if you happen to choose the same name, go ahead and replace it. We just want an empty file. And we'll set the same coordinate file. We'll say none. We'll say next. And let's make sure in that points, list points. Let me list these points. I think I've got a bunch of points. I do. So we're going to exit that and we're going to clear out that point. So I'm going to do that simply here. Instead of erase points, I'm going to go to point set coordinate file. It has the same name, but I'm going to switch to the new tab, keep the same name. I'm going to say open, and it says, do you want to replace it? Yes. So now it's empty. I look at points, list points, and there are 0 points in there. That's what I wanted. Okay. So now, and you see me constantly changing this point style just because I hate that ugly looking text. All right. So I've got nothing in my drawing. I'm going to do survey, enter deed description. Now what's going to happen here is down below, I want to store this to a deed file. I'm going to make it a new file, and I'm going to choose a file. I'm going to choose set, and let's just call it deed descriptions, something like that. All right, so I've got this file called deed descriptions. It'll be a new file. And up here I can set layers and points layers and different places to put things on traversing, etc., blah, blah, blah. Here's my description of this particular deed. So you might put a plat book and volume, page number, or an owner's name, or whatever you want. I will come up here and check on to label the lines and arcs. I'm going to draw the line work. I'll create it as a polyline, and I don't need to prompt for the true point of beginning. We'll just let it ride here because it's not a commencement point. So I'm going to say okay. So now it wants, down there on the command line, it's prompting me to pick a point or a point number. So if I just pick a point here, just on the screen, it says, okay, now that's where you're going to start. What are you going to, how are you going to code this in? And you got these options: exit, curve, select, help, angle, bearing code 1. So the angle bearing codes are like this. The northeast is 1, southeast is 2, southwest is 3, northwest is 4, azimuth is 5, angle right, or angle left rather, turned angle left is 6, turned angle right is 7, deflection angle left is 8, deflection angle right is 9. Those are the codes. We're going to be using bearings, and you just think about your quadrants around the circle. Northeast is 1, go clockwise around the circle. So 1, 2, 3, and 4. So looking at our manual, we see the POB, and we're going to type in this code as an angle bearing code of 1 is by default. So I'm going to hit enter for that. So it's looking for a northeast bearing. So we put in the angle in the form of dd.mmss. So that's going to be 25.3045. And hit enter. So now it wants to know the distance. And by default, you see in the angle brackets that your default measure is feet. You can also at this point choose varas, meters, rods, chains, etc. So Our distance there is 165.45. And we hit enter. So there's our first leg of that figure. Okay, so now it wants to know the bearing code of the next one. So that's going to be a bearing code of 2 because it's southeast. The angle is 45. Now I don't need to put the .0000. I just take 45 is fine. And I'm going to go a 200-foot distance. And there now is that one. What's the bearing code from there is southwest. So that's 3. And that is 25.303, which is not necessary because it's the last part of it. And now it wants to know that distance, which is 156.78. Hit enter. Okay, so far so good. Now we come to where we need a curve. So we're going to choose from our options curve. So we type C. And it wants to know some of these different options that we're going to use. The radius which we have, which is a 200-foot radius. So we just type 200. Hit enter. Which way does it go? Left or right? So it's going to go to the right. And now it wants to know the arc length or the non-tangent, reverse tangent, bearing, chords, etc. We have a tangent length, no, I'm sorry, an arc length, which is the default there, 175. 175, boom, there it is. Okay, so as this is going along, it's building this figure. Now the angle code, again, we're out of the curves. It wants to know an angle code. This time it's northwest, so it's 4. And it is 10.152. We hit enter. Its distance is 200. Now, watch what happens. I'm going to purposely put in 220 as if I had a typo. So there it is. Now I'm going to go to my last one, which is 1, an angle code of 1. And the angle is 25.4030, a distance of 49.3 feet. And there it is. And I'm done with that. Now, you can't just hit escape here. You need to type E to exit. So I'm going to exit that. And I noticed that, well, I've got a problem. So I've got to, and I see where the problem is right now. So it wrote that deed as 1. Now, so I see right there's my problem. So how do I fix that? Well, I've saved that in a deed file. So I can go to survey, process deed file, and there's the deed file that I just made. I'll open up that, I'll see lot 1 and I choose edit, or I just double click it. And I come down here and I see these individual pieces. And I come here and I notice that, oh, well, I've got the wrong distance here. Well, I'm just going to type that as 200, fix it. And sure enough, that seemed to close it up. All right, so that's taking care of that. And I will simply say okay, and I'll save that. And it says it's saved. I'll say okay. Now, nothing's happened there, but if I choose this and say draw, erase the previous, label the lines and arcs, and I'll say okay. So there it went and did that, except for I got a problem with that, didn't I? Degree of curve, what the heck? Let's process that D file again and make sure I didn't screw something up. Yeah, it sure did. That was, oh, I must have pulled that down and changed that from arc to line. So that's going to be a line. This is going to be my arc. And that had the 200. I need to set that back to right. And at an arc length of 175 and a radius of 200. All right, so that looks better. Say okay, save, and draw. Now this time it should go back to where it was. So there we go. And this, where it writes degree of curve, that comes from these annotate defaults, where I'm looking at arcs and I tell it, let me see, not that, but annotate, auto annotate. And we look at arcs instead of just, see, the only thing I have on there is my degree of curve. Well, I'm going to turn that off. I'm going to change my arc length equals radius equals, put this stuff on there as well. And say, okay, that's going to be on the, we'll put them there. We'll say, okay, select their feature. And now it's changed that to represent what that arc is. Oh, I put a suffix of foot on there instead of, and it was already typing the foot. So I would I would take that suffix off. All right, so now I've got this as a deed. And you can see when you can do this, you can enter deed descriptions. You can, instead of making a new, you can append to this. And so you could put in all 25 deeds or however many you've got that you want to calculate up, and then plot all those things. And you can choose, like, well, I know deed number 3 was supposed to be adjoined to this property, so I may pick that same point as its starting point and have it and see how they line up. All right, so anyway, we've got our deed in there. We've coded it up. We don't have any points on it yet. We could have done that as we worked under survey enter deed description. We did not say to draw the points. I could have said plot symbols. So we could have put those points on there. And point format is set to none. So if I say complete points, it would actually prompt me for descriptions of these points, and I could put those down, and that would have been, a little easier to have generated those points automatically. But we're going to just drop points along this feature and use that to help us correlate this deed to found field points. So what I want to do is go to our COGO menu, and I'm going to create points from entities. I'll select my symbols. I'll put a little wipeout circle, and I'm going to use these point numbers. Let it go along. Point order will be, based on the selection. So it'll start where it goes 1 through the end of it. And I'm going to put a description. I'm just going to say deed COR for a deed corner. And same description for all points. I'll say okay. And now I'm going to choose polylines to label. And I'm going to skip the radius points and skip midpoints. And I'll draw any new points. And I'll say okay. I'm going to pick my polyline. And there now I see I've got a decor all the way around. And I've got not just here is a 0.1, but there's also a 0.7. Now I'm going to take my wipeout frame and turn those off so you don't see them, but you can see there is a point there. And if you zoom in really close, you can see that there's your misclosure. That's how the deed miscloses. And it's not very much. Okay, and we can, and that was behind the wipeout. So if I change this, let me get 0.7. Let's change that symbol to not use the wipeout one, but the one. And then let's do the same thing for number 1. All right, now we can see under it. And so you can see, if I can get to it here. So your missed closure there is if I do a standard distance from there to there. See, standard distance. Why is it not? There we go. So it's like, it's 1/100th of a foot in that particular angle. So that's how my deed doesn't close. Now you can do a deed closure, for instance, with your survey, you can do a map check by points or screen entities. For instance, if I do, let's get some more decimal places here and let's just pick our polyline. I'm not, this command box is not working right here. All right, so let's map check closure by point numbers. Let's do by screen entities. Let's see. Well, I've got something screwed up in my setting. Probably need to restart it to do that. So we're going to do this one more time. Let's just do a closure by point numbers. I'm going to say 1 through 7 and process that. No adjust. 1. So there's my precision. And you can see my distance that I missed was by that in the east, that in the north. There's my azimuth of it. There's the actual 0.01 misclosure. All right, now you can also see that when you go back to survey process deed file, we'll bring that deed file up. And if you select that and choose report, you can also say, okay, and so that's going to give you the actual deed calls, the ending coordinates, the actual area, the perimeter, there's your closure, and your closure precision. Okay, so now how do we resolve these points if we have found some points out in the field that are supposed to match up with this? So what we're going to do with that is we're going to select our drawn boundary, and we're going to right click and choose copy the selection, and we're going to just drag it off here to the field side a little bit. And we're going to take that last little leg there, for instance, and I'm going to take that point, grab its grip, and snap it into that grip so that it has the actual same point. So we'll just get a single point there. Matter of fact, let me go ahead and I'm going to just clean that out, and then I'm going to set that to be closed. There's a closed figure. Now, I'm going to rotate that a little bit. I'm going to start a base point there, and I'm going to rotate it just a little bit enough here. You can see that it's changed. And I'm going to go in here and tweak a couple of these files, just a slight bit. I'm going to move this point, say, down to here. And I maybe come down here and take this point and move it up like that. And maybe this point and just a wee bit out like this. So that might represent, where you might actually find these points. So we're going to now drop some points on them. We'll go back to Kogo. We're going to say create points from entities. And I'm going to start with this point numbering as 101 instead of 1. And I'm going to put these as FLD PTS. And let's change symbols to just a little tick. Point numbers 101. Field points, that's fine. Layer names for the points, we'll call these FLD, PNTS. We'll say okay. And again, polylines, we're skipping the radius and midpoints. We're going to draw the new points and we'll say okay. We now select this, and now we have 101, 102, 103, 104, 105, 106 that should correspond to, in fact, let's change this so you don't think they're equivalent. So those points should actually correspond to these points here in the deed. And we're going to see how we're going to resolve this deed to make it match our ground. Okay, it's what we call deed correlation. So we've got a bunch of points. We've got 1 through 7. We got 101 through 106 over here. We're going to see what's the best way that we can bring in these points and get them to resolve to where their field locations actually are. So let's go to the survey menu and let's choose deed tools and let's choose deed correlation. So we're going to make a new deed correlation file, and I'll just keep it the same as my drawing file, deed processing. I'll say, okay, yeah, it's the same name. Yes, I'll replace it. I'm going to get a new file, empty file. So now what I have is a potential, now empty, list of points, one set to compare to the other set, survey compared to deed. And what I want to do is when I want to eventually move my deed points into my actual surveyed point locations. So I'm going to say deed to survey as my alignment direction. And I'm going to create these, or I'm going to add these points. Now we could have done it without these points in here. We could have just said add a polyline, but we're going to actually add these points that we found that we've had. So I'm going to add a point, and it wants to know the survey point. Well, I can get my list. Here's my survey points down here. So point number 1, and it corresponds to a deed point of 1. Okay. So I'll say, okay. So 101 compared to 1. And then I can also add 101 compared to 7. Okay, because I had 1, 2, 3, 4, 5, 6. Let me save that and exit and look out of here for a minute. I need to see. I've got 101. Yeah, 106 was this last one. So I only had the 1 point there that I found. Now you could find a whole cluster of points down here, so you can add those in. So I'm going to go back now to repeat my deed correlation. There's my file. So I've got those 2 points in. And then I can add 102 compared to 2. I'll add 103, compare it to 3. 104, compare it to 4. 105, compare it to 5. And finally, 106, compare it to 6. So you can put in as many of these suspected points that you might want to use, okay? So now that we've got that, I'm going to save that file just so that keeps that list active. So I've got a number of things that I can do. I can do a straight inverse report, and that just simply goes 2 columns, survey points. So from 101 to 102, 03, 04, 101 to 102 to 103 to 104 to 105 to 106. So you see these distances. The bearings aren't going to really matter right now because, uh, you're not, um, there's a rotation. So the bearings and the azimuth stuff we're going to ignore for now, but we're going to look at those distances and you might get some insight. Well, there's that distance right there, 165, 377. There's 165, 4. So that's pretty close. Some of these are pretty close. And that's just a straight inverse holding each point. There's 101 compared to all these others. And there's 7 compared to those, 1 compared to all of the survey or all the deed points. 7 to 1, there's that misclosure distance, 7 to 2, blah, blah, blah. Then from 1 to 7 to 2, 3, 4, 5, 6, 101, 2, 3, 4, 5, 6. So it's just a side-by-side comparison that you might get a sense of how they may fit. Now, that's just a report, and you've got these alignments that you want to do. So if you do a compare before align, it just shows you what indeed are these differences. So 101 to 7, you can ignore the bearings on those, and the distances are going to be quite large because it's over here in the field. But you want to look at these deltas perhaps, and you're in an ideal case, if it were rotated the same and just simply translated, you would see a delta X or Y. They would all be the same value. But, this gives you a sort of a sense of how they may fit as they correlate together. So 101 to 7 is like 530.775 to 1 is 530.779. Then 2 to 2, you got this value. All right, so that's just look, just comparison, how the points compare one set to the other. Now you've got a check alignment. So this might be, well, let's check the alignment. So it's going to ask you, okay, in my D points, if I want to hold, let's say I'm going to hold point 1. I've done some work and I've looked at it and I say, well, I'm going to hold point 1 and I'm going to hold the rotation between point 1 and let's say point 2, 3, 4. I'm going to type 4, and I'll say, okay, so that's my suspicion. So I'm going to look at this. It says I held point 1 and I rotated into point 4. And here are these delta X and delta Y's. That's what I'm looking to really try to minimize if I'm just going by pure position. Now, there's other rules, of course, your preponderance of evidence, your seniority rights, everything else that goes into being a surveyor. That's not what this is for. This is just to give you a mathematical tool to help you, perhaps. So you could do another check align. This time let's hold, let's say 0.2 and rotate into 5. And that gives you another set of deltas, and you can compare those as you see. And then there is a find minimum alignment, and it looks at everything and does that same comparison with all of those possible choices. And it comes up with, if you hold 0.1 and hold the rotation between 1 and 5, you're going to get the smallest deltas that you can get. You can see 0.4 has, a 1.5 foot that it's going to miss out that way. So 0.4 got moved a little bit more than the others, but that's okay. But this gives us the least amount of differential is if we hold 0.1 and we hold the angle between 1 and 5 as the rotation to use, that's going to give you that minimum alignment. And once you do that, that last alignment that you just ran, if you apply that alignment, so it's going to take my range of points, there's my 7, and then 1 to 6, or you could decide not to move 0.7, just to move 1 through 6, you know, whatever it happens to be. And then you want to look at, this is just your standard align command. You're going to go from your first source point, which was 0.1, and you're going to go to 0.101. So you're going to pick this deed stuff up, and 0.1, you're going to put it over here where 0.1 is on the ground. And your rotation is you're going to hold where 5 is and bring that into where 105 is. So that's going to set the rotation to match this. Now, these down here is if you want to go ahead and move these things around, you're going to align the screen entities. We're not going to worry about any elevations. We don't have any. And that's going to tell you how much it's going to move, how much it'll rotate. And now we say, okay. Now, pay very close attention right here. It says, select the objects to align, points excluded. That is important. Because if you were to just draw a window around this and get all these points, the points are already going to be aligned. If you select that as well as that drawing element, it's going to move the drawing element, but it's also going to move those points again that same amount. So it would shift those over. First of all, it's already included in the alignment. It would bring them again from that point over that same amount of shift. So you don't want to do that. You only want to select the things that you want to move. So I'm going to move that deed, and I'll hit enter. And then you're going to see when it changes them, it's going to move it over so that it aligns 7 points. So you see the points all got moved over. The red feature got moved over. There's that 0.106. You can see the difference in that. But our 0.1 was held. So that's held. Our 0.7 is still separate out there. But our 0.1 was held. The 0.5 or 105 was also held for rotation. And I didn't actually change the position of 5 much at all, so, or any really. But, and you can see up in here, I've got, you know, some, whichever ones I moved. I guess I moved this one a little bit. There you can see the difference that moved. So that's actually, that figure right there is actually the deed, and it got moved into this new rotation, and you see the positions of how it looked there. So that one missed off a little bit, but it held all of that deed data, but it moved into the best fit that it could find based on that list of point-to-point comparisons. So then you could, you know, use that as your work on your parcel, you know, resolving any particular glaring conflicts, but at least that gets you close by. And you could have found a bunch of other field points and rotate other, you know, other deeds that you had into those same positions as well. Okay. So really, and this being the actual field point, that yellow line, you know, that would actually, you wouldn't even actually have that as a drawing. You would just have a bunch of points that you suspected were the same points. So you add those up, and then this is the original shape. It did not change that shape. So you notice it doesn't sit on that corner, but the points, and the points are also like this point here, 102. If I look at those coordinates, I see that they're 38,303 and 47,392 compared to this one, which is 38,371, 47,337. So slight difference in placement of the point. Let me change that so you can see underneath it. There you go. So the corner of this actual figure is that point. You see, that's 0.2. whereas this point was my field point, which is 0.102. Okay. So that fit that deed into those field points the best way with the least amount of distortion based on that analysis with that find minimum alignment. Now, again, keeping in mind that's just mathematical, it's just statistical. It has nothing to do with preponderance of evidence. You might come up here and find that this point out here, this centered point, which is centered at the corner of this, you might find that that really is the intended point. And so you would need to adjust your deed to actually match that physical location instead of, holding the point that just simply came out of the deed description. Right. So see how that works, and does that give you a sense of, something that you can use perhaps when you're looking at your tools, or looking at your deed work? Let me bring this guy back over. So, yeah, so that's that part here. And here's some coordinate geometry, but we've already done a bunch of that kind of stuff earlier the first day. And here you go. So if you're running Carlson survey on AutoCAD, you'll see the occupy point and backside point on the status line. That no longer works apparently. So that we found out the first day as well. No, it doesn't matter. You can always just inverse between 2 points to set your backside and occupied, and do your traversing and side shots from there. Okay. And then the next bit here is this lot net processing. And again, we're out of time for the day. And it's basically you're going to open up this file from Clearwater Oaks, and then we're going to let LotNet, and that's going to help us define the subdivision design just simply based on the center line locations, the boundary, and we put in things that we want like minimum lot areas and sizes, and building locations and setbacks and all of that different kind of information. And it can generate, all of your labels, your line tables, your curve tables, do the entire subdivision from within that. So real quickly, if we open that file, close this off, and we'll open that LotNet Clearwater Oaks. That's the one I want. So this has within it the only component you need to set that. I've got a closed boundary, and I've got centerline files, or center lines drawn that can create the roadways for me. Okay, so that's all you need to actually do your LotNet processing. And so this is on area layout, and it's all of these LotNet tools here. And in fact, if I look for a lot network toolbar, here it is. And it sort of steps you through the order you need to do it. So right in here is you're going to set up your settings. And the LotNet file is going to be a new one called, we'll call it Clearwater Oaks. And we can set the road network. We don't have one yet. We can select a new road network. Let's just call it CWO for Clearwater Oaks. And you've got your area tolerance values, edge direction away from frontage or toward the frontage. You now put a lot file so you can get individual lots, but the lot network will keep all that data as well. You can automatically label lines and arcs, label the areas, different types, etc. Set up in different settings. We'll say okay for that. Next, we'll define the boundary. So we'll pick that boundary. And the next thing to do is to run road network. So it's going to create these rights of way. So I've got roads, intersections, cul-de-sacs. So my roads, I'm going to add these roads. I'm going to pick this first one, screen pick polyline. I'm going to pick this one. I'm going to call assign a centerline file, and I'm going to call that one, High Street. All right, so I've got that one. I'm going to set up some offsets in my center lines. I'll choose a new CWO subdivision offsets for these. And I'm going to edit those offsets. And I'm going to say they're going to have, we're going to make these 40-foot rights of way. So we're going to go 20 to the left, 20 to the right. Don't need any additional. We'll save that as my right of way. I can edit the center line, the coordinate file. We'll make a new one there. And so I can, make changes to the actual center line alignment from there. If I need it, I don't need to. All of these variations that modify it. So there's the High Street. I'm going to add the other two. I'm going to say I'm going to add a road by screen pick polyline. I'm going to pick this one, and that's going to be assign a centerline file. Instead of High Street, I'm going to call that one North Avenue. Same right away, so I don't need to change that. I'll leave that the same. And now I'm going to add one more street. The road by screen pick. I'll pick this, assign a file. I'm going to call that one Cross Street. Say, okay, so now I've got my roads defined, and notice it has identified the intersections automatically. And if you double click, say that intersection, you can put in these right-of-way radius values as it goes around those corners, okay? Front right, back right, different settings along those. I want to add one more feature. I'm going to add a cul-de-sac at the end of my High Street. And it's going to go to the end. I'll keep a cul-de-sac right-of-way radius. So we did 20 feet. If I have a, let's make it a, say 20, say 10 and 20, so 30, let's make it a 40-foot right-of-way on the radius for the right-of-way, and we're going to use fillets of, say, 25 feet. And we'll say, okay. So now all of that's done. I'm going to save that file, but I'm going to next process right here, and you're going to see what's going to happen. So when I process that, it's going to apply all of those rights of way, and it's going to calculate where all those lots are going to go based on what we set up. And it's going to label everything and put all that stuff in. Now it says pick a curve table position. So I'll just pick over here to put the curve table down. And then it's going to also want at some point a line table, probably. I'll watch the prompts. No, it didn't. It just used curve tables. So there's my curves, different radius, etc. And you can see they're labeled all the way around my subdivision. And you would set your layering and all that to match so that you can, get something that looks sort of like that, with the individual things. Now, you see right in here, I've got a bunch of little segmented pieces that, I would probably want to smooth out those. I would take out those extra points and maybe redefine that particular line. But as it went through, it created all of these individual lots. And if you look at the areas there, there's 15,827, 15,125. Over here's my 10,000, 10,000, 10,000, 10,000. So those bigger ones, it held the frontage, and it went back to the distance we specified for its distance around. And you can see, all of those it put together, numbered the lots. There's 32, 33, 34, 35, 1, 2, 3, 4. And so all of these other tools down here are allow you to add additional things, remove a lot edge, modify a lot edge point, subdivide a larger area. So if you wanted to subdivide, say, this big lot up here, you could do that instead of 17,000 square feet. It's not enough for two 10,000-foot lots, but you could do that. And then it would just automatically reprocess that whole business. Now, if you look in your settings, well, not for RoadNet, sorry, let me save this and exit that. If I go back to my LotNet settings, this is where you put in those required areas and what you want to draw and things like that. So when we choose that, let me see, there's something I'm missing here. If I use my road network, starting lot 1, there's my, I could output a lot file if I wanted. Let's just call it lots. These are my labeling. Oh, my building placement setback or building placement settings. If you can have like a front setback, your side yards. So this is where it would draw these particular setback lines, which you can see drawn in my lots. You can draw building pads, for instance, rotated to the front edge or lot edge. Here's your width, your names, the depth, the setback, draw driveways if you wanted, all kinds of things, additional building pads. So that was that. Let me see, this is actually my labeling. There's my building placement. I say okay to that. Label straw edge. Yeah, load up my road net. Okay, create lots in my settings. Here's where I was looking for. I'm sorry, they moved it into the road net part. So there's my target 10,000 square foot area. So I could say make that acres, and let's make that a half-acre lots. Minimum frontage of 50 foot. Let's make those 60 feet. Minimum depth, maximum depth, minimum back distance, interior and back, reduce the offsets. The edge method, I'm going to go perpendicular to the right of way itself. Any remainder, I can say add to the last lot. That'd be the owner's lot. You can see that down here in the bottom lower right. Or you can, create a separate end lot by itself with just the remainder. So that'd be smaller. If you add to the last lot, it makes it bigger. You could apply it equally to all the lots. And you can even create a back lot edge. If you did that, for instance, and said, okay, say okay, and let's process that again. And you'll see you'll get some different layouts now. And again, I got all those little points over there because it's trying to resolve that. And I would take those out. And it said coordinate is not set, but there you can see I've got my building pads are placed, and there's my curve table got automatically updated. You know, and I would probably resolve some of those corners so that they're not individual corners. And I would also change my labeling to, instead of labeling each little segment, I would tell it to use a line table. I have my curve tables on, but not my line tables on. So you would set that in those default areas. Now here's an example. This is a 0.8787 acre, because that's, you know, it put the half acre up here. I've got this one down here. So if I took this particular lot, I can resize that to be half of that. So that's a 0.8787, that's a 0.5, so that's going to be a 1.37. Mind that. I have so 0.7, 0.7, 0.7, so 0.65 acre maybe. So if I do a sliding side area, I'm going to pick inside the lot to adjust. So I'm going to pick this lot, pick the lot I want to, the lot line. I'm going to adjust this lot line. And it wants to know a target acres or square feet. I'll type A for acres. I'll make that 0.65. And you see what it did, it's shot it down. So now that's going to be 0.65 acres up there, and it reduces that to 0.72. So, you know, you could find that out and figure out where that needs to go to make those adjustments. But for the most part, you know, it's pretty much built you an entire subdivision with half acre lots as you work your way around it. Some of these up in the corners, there's not enough to, you know, I could swing this around to make this a half acre, then this would be a slightly different size in here. Okay, so there's a lot more to designing a subdivision than just coming up with a bunch of numbers and having it spit this out. There would be some considerations of, you know, the topography. Maybe that's not a good place to have a lot line, you know, those different kinds of things. Down here's another case where here's a large area that's, you know, I might want to split this lot. So I would say subdivide this area. I'm going to pick inside this one, and I'm going to make that, let's make that a 0.5 acre with a 50-foot frontage. We'll say okay, and pick the end of the frontage. I'll grab that one there. Oops, too small to fit more than one oh, okay. So 0.93 would be 0.45. Let's set that to 0.45. So there now is split. There's my 0.45 and a little bit extra 0.48. You could do the same thing there. And you see as you do that, that's a 0.9988. That's almost a full acre. So if I subdivide that area and give it a 0.4, let's call it a 49, say acre. So it'll be that first one will be a 0.49 acres, and this will be a 0.5088. So you get a sense of how that can be helpful. If you do any kind of subdivision design, you may not do much with it, but that's where and how that function works. Okay. Questions at this point? You've been so patient and good as we've run over both days. You'll actually, I'm going to give you guys each an extra hour for your PDHs. So Todd, that'll be one less hour you had to sit through somewhere else. So anyway, that is sort of a whirlwind tour. There's a couple of other places I would encourage you to check out, particularly on this area layout routine. And that's things like these parking utilities. This is all sort of new to the software in recent methods, or recent versions rather. And they're going to do a lot of things like designing parking lots, much like this LotNet did for you as well. Okay, and you've got these lot layout utilities for lots and stuff. That's taking LotNet, but on an individual basis. Adjust areas as your hinged area, sliding side area, much like we did these over here where we moved them around, to get a target area. There's that 0.65. So that's, all of those tools are available individually with these commands like this. Parking utilities, again, it's a new feature, and it sort of automates laying out parking lots in big empty parking lots. But this LotNet, and I did everything from the toolbar, but these are all where you set your boundary, your sub areas, and all that kind of different stuff. Okay. And now you've got a lot file. So if you look at your lot file inspector, why did it not? Apparently did not create it. Thought I told it to, but I may have left the switch off. Anyway, if you do that, you can basically hover the mouse over the lots, and they'll highlight and they'll read you the information about the lots itself. Just, you'll get that, it'll color that in and tell you the boundaries and the areas and all that kind of stuff. Okay. So questions on anything, whether we covered it or not?
No, sir.
All right. So here is good. Todd, you wanted to look at, and I'm not going to I won't hold you guys up to show you this about using paper space. They did everything in model space. There is a couple of places, I think. I don't know if it's in tutorials or not. It wouldn't be there. It might be under. There's some annotative text stuff, but I want these general commands survey. Making a plat, but that I don't think talks about paper space. That's just get a sense of it if I can see. Let's see, building dimensions. Yeah, that's doing everything from within model space, where you can put all this stuff together. But generally, we do all that stuff in paper space now. So I wouldn't look under here for guidance there. But what I would look at, though, is under your Carlson online training movies. And you're going to get to their YouTube channel and just search. I think paper space will bring up a number. So here's paper space and model space. Learn more on how you use this to repeat of a webinar. 50 minutes to go over there. Here's your annotative text for a half hour. CAD standards over an hour. So some of those are pretty lengthy, but probably the best one for using paper space might be this very first one here. I'm just going to step you through a couple.
Are repeating this webinar that we had done.
Let me just drag this up here and see. Yeah, see, they're actually in paper space right here. You see the layout tab is highlighted, but they've got it black just for visibility. Normally that would show up as white. And they're setting viewports into the model geometry, and you have multiple viewports all on the same sheet, all at different scales, different rotations. So if you were to play,
So I can do a grip edit. Notice it didn't automatically do a zoom and extend, but I can shift it and shape it. We are working in IntelliCAD 6, so we are limited at this point to a rectangular viewport.
all right, so what she just said right there, that she's working in IntelliCAD and that you're limited to rectangular viewports, that's no longer the case. They can be any shape you want. They can be, and you can set, it's just like you've got little mini models. You're cutting into your model view, and you can set each
And
one of those
and
as a different scale. You can set a different rotation. You can freeze and thaw layers independently inside of these individual things. So for instance, if I were going to, in fact, let me get out of that. Let me load you up a file that I actually have. Something that I've done on a real job. Let me see here. Let's see my projects. I go to documents, consulting, projects. And then I've got this file here. Let me go to my working file, storm system reroute. All right, so just to give you an example of how that's done and what I did, you can see as it loads all this mess up. So I've actually got in, this is my model space layout. I've got, let me turn this down a bit. Well, if it'll let me. Yeah, so you can see the geometry a little bit better. So we basically, surveyed this area over here, and I've got these drain pipes and stuff laid out to collect all this data. I've got individual profiles done. I've got probably more layers that, I've got something there, a bunch of stuff is frozen. There's my existing grades. Shit, that's not even the one. That's not even the file that I'm looking for. Existing conditions, alternate sketches. New work. And so it's missing some of the reference files, but there's basically everything in that same bit. If I look at my plan view, now my missing reference files are things like my existing conditions. I think it is in here. Nope. No. Let's find that one and see. That's not the right one either. And again, that just gives me a plain view. Bear with me one quick second further and let me get the, there's my system design. That should have been, I forget which one was the latest. New works update. Here's my final revisions. Maybe that would be what I want. There's my model. Cover sheet. There's my revisions. Revised system design. And it's still not giving me the layout tabs that I wanted to show you. Existing conditions for plots, maybe. Yeah, there we go. So here you can see in my model space, I've got, you know, all of that layout here done for the modeling. But in my existing conditions map, I've got, you know, text laid in here. This is a viewport, and that's set up to be, select the viewport. So that's set up to be, it's locked right now, and it's set at a scale of 1 inch equals 30 feet. And you can see there's my bar scale there, and that's set, and it's looking at that existing information out here, you see. So it's rotated here. I've rotated it so the building is lined up, and that makes my north arrow look here. So it's the very same geometry. And then I've got, you know, a 20 scale existing conditions, another part of the area. Here's my demolition plan. I've got some other sheets and some other files, but these are all individual looks into this particular model. And so if I were to look at, say, if I wanted to blow up this corner area right here and to show an enlargement, I could do that just by simply coming down here and creating a new viewport and just say viewport. And just make a new one here. And I'm going to double click inside of that, and I'm going to zoom in down here, and I'll zoom down to that corner, which would be like right in here. All right, so I would maybe take a look at that area in here with this. I'm looking at my model, but now while I'm in that, let's see, I can position that around. So it's just like I'm individually in that model right there in that viewport, but I could, while I'm in that viewport, I could go over here and then freeze off, you know, various layers like that image. We can freeze the imagery. You know, so I could turn the imagery off. I could actually change the line styles and everything in here. You notice I'm at a different, you see when I select these things, you see these selecting up here in the top, because that's actually the exact same geometry. So if I'm drawing a blow up of this area, I'm not copying this down and scaling it up. I'm just looking at the same stuff, but I'm setting it at a different scale. Okay, and then I would click out of that and I would set that and lock it and all kinds of stuff. So that's the point behind using these different layout tabs. And you can see when you set those up, if I look at my page layout, I've got You know, I've told it that I'm using a particular printer. I've got a particular paper size, so that's an architectural D size, and I'm using a particular drawing table where I'm setting my just plot styles. So I want to say that, and then so now down here you see this is black, all black, and up here they're in different colors and different things. So you can change those independently of each other as if it's a separate drawing, but it's just looking at exactly the same data. So if I select this pipeline right here, that's that pipeline right there. Now notice this one is not rotated, whereas in up here in this one, it is rotated. You see how my crosshairs are rotated, so I can change that. I would make it match, you know, to look at that. And I could, you know, just maybe do a blow up of this area here if I needed a detail. And I would just get into that area and make it, you know, zoom it in bigger to make it show up. Okay. So that's sort of, again, the, and also as part of this, if these viewports were not here, if I take this viewport and actually just delete it, see, it cuts it out of the picture. So I'll take this one out as well. So these are things that are drawn into this space, just like model space, but that includes, you know, my drawing border, my, you know, PA1 call, drawing notes, the titles, and there's my PE stamp and signature and titles and all the different revisions that we've gone through, et cetera, et cetera. So what this does is it keeps me from having to make a new drawing every time I need a sheet to be plotted. And if I look at the results of those, let me find you these real quick. That particular one was Yanasco. Here we go. Where do I put my plots? Here's my output. So I've got this PDF file. And now let me bring that across. So these were created individually. So there's my, you know, project location map, the titles, and all of these references. I've got sheets listed here and my legend. And you can see I've got, you know, 16 drawings in this, and I can step through each of those. You know, that's my existing conditions at a higher scale. Individual, there's my demolition plan. There's my baseline information. There's all my piping structures. And it gets down into, here's my pipe profiles, you know, all of the different things. And these all came out of a single drawing for the most part. The title sheet was a separate drawing, but, and these are just referenced PDFs that are stuck into this overall title sheet. Some are PDFs, some are actually just blow-ups of the geometry that's designed out in the separate sheets. Like this one, this is an actual cut of a 3D model of this junction box where these pipes are coming in and where they go out. So so the benefits of doing it this way, of course, is and that's down at this location. Let me find it. Yeah, right down here. So, you know, there's all that junction information down there. So if I were to change that, move it around, it's going to automatically go and update that other layout that I've done. You know, I might have some cosmetic cleanup to have to get into, but, and this is all still the existing conditions. Let me, you know, there's that tie-in right there to that junction structure that we looked at in the detail sheet. So you can see, you know, how, and there it is. You see it's called CB1. And there's your incoming pipe here, your outgoing pipe. It goes into this existing structure. And if I look back at that final detail sheet, for instance, there is that CB1 in plan view. There's the output to the existing structure. This is the pull in from the new system. This is an existing pipe that feeds it. So all of this stuff, this is not just a drawn flat drawing. This is an actual model. It's a 3D model that is sliced and cut. So it put in all of these little dash lines for hidden lines that are behind the slice. You know, so all of this stuff was simply created out of that one single model space. And you know, there's so much flexibility and so much more that you can do using these types of layout, using the layout tabs that you don't get from trying to make individual drawings. Every time you do this, you have to copy everything over and you know, redraw everything. So it allows you to keep your work down to a bare minimum, and yet come up with all those different drawing scenarios. Okay. So with that, I don't want to hold you guys up forever. It's Friday night. It's 5:20. Let's go home. What do you say? Beer 30 almost? So now, Todd, I know they didn't teach you the whole works about working with paper space, but that would give you something to explore, and then look at Carlson's videos on that, and then, you know, just play with it and, you know, get into your AutoCAD tutorials and see those kind of things of how to use those. So, you know, it's a learning process. You know, I didn't learn it overnight either. So, with that, I would say, you know, you've got a lot of, I'm going to kill all of these things here.
Yeah, that's fine, Ken. I'm kind of, like I said, I've done things in it a little bit, but I just don't have no experience in it to where I've created my own, you know what I mean, and created my own drawings and stuff. You know what I mean? I've basically taken stuff out of it and cut it out of it and and put it into model space, cheated it a little bit, but
Yeah, and that works. You know, I'm not saying that you don't ever want to do that kind of stuff, because that kind of stuff works, and sometimes it's expedient to do it that way. Because projects have deadlines, and
yeah,
you know, you're working for the county, so you can usually, you know, look down your nose at the consultants, but when you're
yeah,
when you're a consultant working for the county, those deadlines don't move very often. You gotta get that stuff turned in. So sometimes you just do what you need to do. And it's the only thing I can tell you is that I've spent 40 years of my career taking extra time to learn how to do all that stuff. And not saying that everybody needs to do that, just saying that I was motivated to do that so that I would learn how to get that done. And it's paid dividends toward the latter part of my career now, because I know those skills and I can really streamline my work effort now, that keeps me from having to do all that stuff individually. So,
yeah. I appreciate your time. You know what I mean? Like I said, I don't want to take up all these other people's time. You know what I mean? But
yeah, no worries.
I
And
just want to thank you for it.
yeah,
So
Lisa left me a chat. I didn't notice it, but she said she had to scoot off, and that's understood.
okay.
So, you know, we're almost an hour over today.
Yeah, I got Greg and Ryan here. I think they're itching to get out of here, and I see
Yeah.
Sierra still in there, so I don't want to bother all you. You know what I mean? But I told
Yeah.
them they can go whenever they want. You know what I mean? So
Yeah, so we'll do that, and go from there. Let me see, where was Lisa?
and we can always reach out to you, like you said, if we get stuck somewhere. I think you said that you could help us with something if we needed to.
Absolutely, and if you get into where you're playing around with paper space layouts and you need a little, a half hour look over your shoulder, I'll be glad to do that. Or if it gets into something, you got a huge project you want to see about getting it done and you want to maybe learn along the way, and
Yeah,
it's up to be a week or 2 weeks worth of effort, we'll talk about a consulting relationship, make sure you got budget for it and all that. And usually out of, you want your projects to pay for it. You don't want to take it out of the cash register. So, all of those different things are entirely possible. So stay in touch. And I'll be sending each of you your certificates of attendance and completion and your PDH that you've earned. Again, I was going to give you an extra hour. I'm going to give you an extra hour and a half for these because of the stay lates.
perfect.
Unfortunately, Todd, for the others, they're not going to really be able to take much advantage of that. You'll get some use out of that.
Yeah, yeah.
All right. All right. So with that, let me stop our recording.